Umesh sir, a given co-host, can you please share your screen, sir? Just I am checking whether YouTube is working or not.
Okay, sir. I'm sharing the screen. I'm audible, sir.
You please share your screen.
Okay. I'm audible, sir.
Yes, your voice is audible. Try to share your screen, sir. I am
Yes,
checking
sir,
whether the YouTube link is working or not. Please
Very
share
nice.
your screen, sir. Share your screen and keep any slide.
It is good, sir.
Checking, sir. Wait a minute.
Good morning, sir.
Good morning, Umesh. How are you?
Fine, sir. Sir, how are you, sir?
So this presentation is for 30 minutes.
Sir, 45 minutes for each speaker.
Okay.
Sir, yours, sir, 9:45 to 10:30 is there, sir.
9:45.
To 10:30. From 9 to 9:45, Krishna Reddy, sir, is there.
I'm not getting you.
Sir, from 9 to 9:45, Dr. Krishna
Hmm.
Reddy sir is there. His the lecture will be there 9 to 9:45, sir. And
Okay.
from 9:45 to 10:30, yours is there, sir. After
Okay.
that,
Okay. 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 I can join later.
uh, yes, sir, as you wish, sir. I mean, just after the actually from 9, hopefully all will join. So, sir, if your
Okay.
presentation is from 9:45, as you wish, sir.
Okay. Fine.
Yeah, can you hear me?
Sir, your voice is audible, sir. Good morning,
Hello?
sir. Good morning, sir. Your voice is audible, sir.
Good morning, sir. Lingesh, sir.
Yes, sir. Voice is audible, sir. You can speak.
Can you hear me?
Good morning, sir. Krishna Reddy, sir. Good morning, sir. Umesh, sir. You can proceed, sir. All the voice are audible and the slides are also visible.
Hello? Hello?
Krishna Reddy,
Yeah.
sir. Your voice is audible, sir.
Can you hear me?
Yes, sir. I can hear you. Your voice is audible, sir.
Mm. Hello, can you hear me?
Yes, sir. You are audible, sir.
Very good. Thank you.
Good morning, sir.
Yeah, good morning. It's a night here.
Yeah.
10:30 in the night. So yeah,
Yeah.
for you it's early morning, right?
Right, sir. So,
Yeah, it's very good. Yeah, I'm used to Zoom, so I always have to figure out something always goes wrong. Just for sharing, I just have to share my presentation, right? That's it.
yes, sir. Just wait for a few minutes.
Yeah.
Others are joining.
No,
We will start soon, sir.
yeah. No problem. No problem. So, how is everything? Good.
Good morning, everybody. I am Professor Londe. I have already joined. So,
Good morning, sir.
yeah, whenever you say we can start the session, I will introduce the keynote speaker and then we can start the session. So it is up to you. I am there.
Yes,
no
yes.
problem.
Yeah.
Yeah. Good evening, Dr. Reddy.
Good evening.
Good evening. Yeah.
So there are 4 parallel sessions, right? So probably a lot of people will split.
Sir, we are waiting for our co-chair, Dr. Ruben sir, to join.
Okay, no problem. I'm not
Just to
not
wait
in
for
rush.
just we are waiting for.
No problem.
Yes, sir, right. 4 session is going on parallelly. That's why, as per the specialization, participants are joining.
So early morning in India, right? 9 o'clock is very early.
That's good.
So people probably will be free after 10, after having breakfast and everything.
Yes, sir. Just I connected to Dr. Ruben sir. He is right now going to join. As he joined, we'll start, sir. Lingesh sir, are you there? Lingesh sir. Good morning, sir. Good morning, Dr. Ruben, sir. Can you hear me, sir? Ruben, sir.
Sir,
Yeah, thank you for joining, sir. So,
sir, good morning, sir. Good morning to all, sir.
yeah, good morning.
Sir.
So, good morning to all of you. Myself, Dr. Umesh Kumar Singh, Associate Professor here in Civil Department, KL University. I welcome all of you in this session of Third International Conference on Advances in Civil Engineering. So I am happy to have the chair as Dr. Srinivas Londe sir, co-chair Dr. Narela Ruben, and keynote speakers Dr. R. Krishna Reddy and Dr. Zulfikar Ahmed sir. In this session, as per the schedule, Dr. R. Krishna Reddy sir will give the keynote lecture that is scheduled from 9 to 9:45. After that, from 9:45 to 10:30, Dr. Zulfikar Ahmed sir will present. And after that, authors will be present their papers. So as per the time schedule, I request all the authors to be in the time so that all the session can be completed within the scheduled time frame. Now I'd like to introduce the chairs and co-chairs. I welcome Dr. Srinivas Londe sir as a session chair He is the professor at VIIT, Pune, Maharashtra, India. Giving a brief introduction about him. Professor Londe obtained his doctoral degree in water resources engineering from IIT Bombay. His area of interest is hydrology, hydrodynamics, wave mechanics, stochastics, soft computing. He is expert in soft computing applications in hydrology, ocean engineering, effect of climate change on oceanic and hydrologic variables. He is the recipient of prestigious awards like the Jal Vigyan Puruskar. He got this award in 2019 from Indian Society for Hydraulics, Pune, for the journal paper titled A Novel Approach for Knowledge Extraction from Artificial Neural Network. He is also the member of various reputed professional societies like the Institution of Engineers India, Indian Society for Hydraulics, Pune, International Association of Hydro Environment Research, IAHR, LMIST, and many more. He has reviewed more than 100 publications in last 10 years from ASC journals. So thank you, sir, for being there. Now I am moving to co-chair. I will happy to have the co-chair as Dr. Narela Ruben. He is the professor and HOD in Civil Engineering Department, Vignan University, Guntur, Andhra Pradesh, India. About a short bio for co-chair. Dr. Ruben obtained his BTech degree in Civil Engineering from JNTU, Anantapur. Master degree and PhD degree in Water Resources Engineering from NIT Warangal. He has total 15 years of experience in teaching, research, and industry. He has numerous publications in reputed journals and conferences across national and internationally. His 1.18 crore project proposal has been accepted by DST ICACE Government of India. Congratulations for that one, sir. He is involved in various consultancy projects and have active participations as NSS coordinator. He is also a member of various professional societies like Institute of Engineers India, Indian Society for Hydraulics Pune, Indian Society for Technical Education, and many more. So thank you, Dr. Ruben sir, for being there. Now I request to co-chair Dr. Srinivasa sir to introduce keynote speakers and start the session. So I am handling the session to Dr. Srinivasa sir.
Okay, thank you. And
Thank you, sir.
a very good morning to all, and a good evening to Dr. Krishna, who is here from Illinois. All others, I believe, are from India. So a very good morning to all of you. Very good morning, Professor Ahmad. I believe you remember we met a number of times in Sri Lanka, also in IIT also.
Yes,
It's my proud
yes.
privilege. Yes, sir.
Thank
It's
you.
my
Meeting after a long time.
privilege to introduce you both. Yeah, we are meeting after time. So let me start the session. Normally, co-host Professor Ruben, and it's my proud privilege to introduce our first keynote speaker. I will just give a brief introduction because his achievements are so much that itself can become a keynote lecture, and so therefore I would just read out a few things. Yeah, he is a professor of civil and environmental engineering, University of Illinois, Chicago, USA. Distinguished researcher and professor of environmental and civil engineering, director of sustainable engineering research laboratory, and director of geotechnical and geoenvironmental engineering laboratory at University of Illinois, Chicago. Dr. Reddy received his PhD in civil engineering from Illinois Institute of Technology, Chicago, USA, He received gold medals in BE Civil Engineering from Osmania University, Hyderabad, and ME Civil Engineering, Geotechnical Engineering from IIT Roorkee. Dr. Reddy has over 25 years of teaching, research, and consultancy experience with special focus on geotechnical investigations and infrastructure, environmental pollution control, waste management. He is author of 259 journal papers. I repeat, 259 journal papers, 27 edited books and conference proceedings, 22 book chapters, and 226 full conference papers with H index of 64. Now, after reading this, I believe we are really very fortunate to have you, Professor Reddy, amongst us, and to give your keynote lecture to the attendees over here. Everybody who is attending this is really very fortunate to listen to you. We look forward to your lecture, sir. You can please start your presentation now. Thank you.
Very good. Thank you very much, Professor Srinivasan. And it's a good morning, everyone. So it's almost bedtime here. It's 11:45 in the night. So let me, it's a privilege to be talking to every one of you. So let me share my presentation. So just let me see the presentation mode. Okay, slide. Okay, is everything visible?
Yes, sir, it is visible.
Okay, all right. Let's see this one. Okay, just I need to just display this. All right. Is it okay, or is it showing two screens?
Yeah, it is showing two screens. If you can make it like slide presentation mode, because this is also new to me, this WebEx. I'm also, yeah, I'm also Zoom person. So
Yeah, me too.
yeah.
Yeah. And sometimes it works, sometimes. Maybe I should do the other way. Slideshow. Beginning. Okay, let me just try one thing. Okay, can you see it?
Yes, yes, yes.
All right.
Yeah.
Yeah, thanks again for that introduction. And just warn me, 5 minutes before time is up. I don't want to take too much time. So I will try to finish, within the time allotted. So again, I want to thank you for that nice introduction. I want to be, thankful for the organizers for giving me this opportunity. Before I get started, I want to thank my graduate students who contributed to this presentation. And I want to, thank the organizers for inviting me. And I want to thank all those, who are attending my presentation today. So I'm from Chicago. As mentioned, Chicago is a pretty beautiful place. So hopefully after this pandemic, if you are coming to US, please do visit me. So I work on different areas of research. My research is on environmental remediation of soil, sediments, groundwater, and stormwater. I work on waste management and landfill engineering. And I work on life cycle assessment and sustainable and resilient engineering. The topic today is in this area. And my background in master's and PhD is geotechnical engineering, but my undergraduate is in civil engineering. So I call myself as a geo-environmental engineering and sustainable and resilient engineering as my expertise. So over the years, whatever we have done, we summarize those in these books and these papers. So you're more than happy to, we'll be happy to, share any information that you need. So in our research, we do a lot of bench scale testing, large scale testing, numerical modeling, and then we do field testing. So we do, both from lab scale to the field scale and including the mathematical modeling. So we look at the fundamentals and then we try to develop the practical solutions. So this is my lab. As I mentioned, I do a lot of lab research. So this is the equipment that we use for testing of materials and also do physical model tests. So over the years, I had the privilege of working with a lot of students from all over the world. So all my accomplishments are due to these people. So in my presentation, what I want to do is, as I mentioned, I am more into sustainability, quantifying the sustainability. I'm going to present a general framework that I have been working on that can be applied to any engineering project. And then I want to show a case study. The case study that I selected is on groundwater remediation. So, but the framework can be applied to any engineering project, structural or geotechnical or transportation, whatever it is, even in mechanical, chemical, any engineering project. So at the end, I will have a brief closing comment. So we talk about sustainability, but how do we quantify sustainability? That has been my main focus. This has become very important because in our conventional engineering projects, we do designs based on the code and regulatory requirements. And we look at the technical design for safety and ease of construction, cost, construction time. So these are, what we typically do it, which is not bad, but it is the time for us to think about more than what we do. We need to think about sustainability, life cycle thinking, and resiliency. And if we do think about these things, we can actually come up with out-of-box solutions or innovative solutions that can be effective and economical. So the point here is, we need to be considering sustainability and life cycle thinking and resiliency. So that brings to the question of what is sustainability. So everybody knows about this broad definition, development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So this is the UN definition that everybody knows about it. So basically, let's not do anything stupid now that can affect, current generations or even the future generations. So it has become very important to look at sustainability and sustainable development these last few years. Everybody's talking about it because of two grand challenges. The first grand challenge is the global climate change that is due to increasing greenhouse gases. And as a result of this, we are seeing extreme hazards, floods, droughts, wildfires. So this is not a fiction. These global greenhouse gases are increasing, and Earth is warming, and we see all these climate impacts happening. And even in India, you see a lot of unusual climate-related impacts that is happening. More and more are happening in the last few years. So that's climate change impacts is one thing. So we need to get greenhouse gases under control, and also we need to think about designing, for resiliency. The other big problem that we need to think about, sustainability is due to this, increasing population. So this population is increasing at alarming rates, and as a result of that, naturally you will have a depletion of natural resources, increased waste generation, increased pollution, damage to ecosystem, loss of biodiversity, urban sprawl, economic disparities, and social injustice. All these things are going to become more and more problem. These problems are going to become more severe year after year as the population is going to increase. So this is undisputed, fact. So because of those grand challenges, engineers have a responsibility to do something, and to do something that can be done at a different scales: global scale, national scale, regional scale, business scale. But as engineer, we should be looking at even at a technology scale. So whatever you're doing on a daily basis, dealing with materials, dealing with the designs, so we should be thinking about all those things through the lens of sustainability. So that definition that I showed you, it's a very broad definition, but it's not a functional definition. So we really need to have a good functional definition. And I try to use this ASCE definition. And, the definition is given here. The essence of this functional definition is considering the triple bottom line, environmental, economic, and social aspects, so that can maintain and improve the quality of life indefinitely. So this is kind of gives us the, some framework to do something about it. And this framework can be applied at different scales, even at project scale. So this triple bottom line that I'm talking, that this functional definition is mentioning is basically environmental, economic, and social. A lot of you who have seen sustainability presentations or you read about it, you definitely have seen this kind of diagram. So it's optimizing, the positives and reducing the negatives of these three dimensions. We call this one triple bottom line. So in terms of quantifying the sustainability, we need to have indicators, we need to have metrics, and we need to have tools to calculate those metrics. So, a lot of times people just say, oh, it's good for environment, good for economy, good for society, but I want to have the numbers to prove, how much is good you're causing with your design. So for that one, we need indicators, metrics, and tools. So for environmental sustainability, what are the indicators? So energy, right? If you are using less energy, it's more sustainable. Less carbon footprint or greenhouse gases. That's again, good indicator of sustainability. Smog, all these environmental indicators. And we just not only identify indicators, but we need to have metrics and tools to calculate those indicators. So that way we can quantify and see how much difference we are making. So this environmental sustainability has been studied by a lot of people, for a long time. And then the common tool that people use is the life cycle assessment. This is a standardized approach. We use ISO 14040, and you have inputs, you have different life cycle stages, and you look at your products, but then you look at outputs or emissions that could be atmospheric, waterborne, or solid waste. So as I said, this LCA is a standardized procedure. You have these 4 phases that have to be done in any LCA that you do. So relatively, we have a good handle on looking at the environmental sustainability. So economic sustainability is, where we calculate the direct cost. Like that's the engineering cost estimate that we teach to our undergraduate students. That's not a problem. But we need to look at beyond that. When you talk about sustainability, we need to look at indirect costs, direct costs, indirect benefits. So all these things, if you are building something, it's going to cost money. That's not the issue. But what is the good that building is going to bring in, right? So the employment, all kinds of other benefits. So we need to think about all those things. And again, we need to have a metrics tools to calculate these things. There are life cycle cost estimates, cost benefit analysis. So there are some tools developed, but not as well established as environmental sustainability. The third aspect of sustainability is the social sustainability. And this is where, a lot of people are struggling, not only identifying the indicators, but how do you quantify these indicators? How do we get the tools to quantify these things? So I developed a tool called Social Sustainability Evaluation Matrix some time ago, 2013, that I use as a kind of a framework to use a kind of a rating system. At least you can rate some of these social factors and take into account in quantitative ways. So the whole idea is to look at the environmental indicators and metrics, economic indicators and metrics, and social indicators and metrics as best as you can do it. So once we have all these things, other important thing to consider is consider all these aspects not only during the design and construction or maintenance, but through the entire life cycle. We need to look at resource extraction, manufacturing of the materials, on-site construction, maintenance, demolition, everything. So a lot of times, I know in civil engineering we don't really think about all these things. We design and construct and think that we're going to take care of the maintenance, but we don't look at the raw material acquisition and emissions due to the manufacturing of concrete and steel. And so really what point here is we need to look at these triple bottom line aspects at every life cycle stage of the project. So then that will give you the holistic, holistically, what are the environmental impacts, what are the economic impacts, what are the social impacts. There could be positives and negatives. So once you have all these metrics, the decision making is not easy, because sometimes some things are unfavorable, some things are negative, some things are positive. So how do you make a decision when you have these kind of issues? So basically you need a multi-criteria decision analysis. And if we can quantify the sustainability through a sustainability index, combining all those different metrics, that would be great. So this is the methodology you can apply. You have requirements, criteria, and indicators and weightages, and then you can normalize all the metrics, and then determine the sustainability index. And one of the challenging part in this kind of assessment is applying the weightages. So a lot of times we do the baseline, assuming everything is equal, but you probably use these procedures like analytical hierarchy process or some other methods to get the weighing factors for different indicators that you have looked at it. So then you apply the multi-criteria decision analysis framework. We use MIVES. So you have environmental indicators, economic indicators, social indicators, and you have a criteria and you have requirements. You apply the weightages, and then at the end you get a sustainability index that you can calculate. So that kind of one number will indicate how sustainable it is. So this one you can look at it. If you have 2-3 different alternative designs, you can calculate the sustainability index for all those options, and then look at which one has the highest sustainability index, and you choose that one. Or if you have working only on one particular design, you can calculate the sustainability index if it is low, and then look at where the negative impacts are coming, and then try to make your changes in terms of the materials or design, and try to increase the sustainability index. So this is kind of the framework that I've been promoting. You can look at this reference for more details on this framework. I have examples of applying this one in structural engineering, transportation, environmental, water resources, and even I teach a course on sustainable engineering at a graduate level. I have students from different engineering disciplines taking this course. So they do the projects in their own, related to their own discipline. So this framework works well for any project that you deal with. So the second part of my presentation is to show you how this framework works for one example. So here I'm looking at a case study where groundwater is contaminated with PFAS, and then we want to remediate it, and we want to use the absorption process. And then if we have options for different absorbents, which one you want to choose it? So which one is the most sustainable absorbent? So question here is PFAS. PFAS is a emerging contaminant. If you work in an environmental field, you should know what PFAS is. This is the hottest topic in the US and all over the world. So if you are interested in working on this, it's the right time to do it. So just a brief intro to PFAS. PFAS stands for per and polyfluoroalkyl substances. So we have typical carbohydrates, right? Hydrocarbons, with the carbon and hydrogen. But these compounds, PFAS, that hydrogen is substituted with fluorine. So these are the compounds that have these groups have the fluorine, and then you could have some other functional groups. So it's all fluorinated. Instead of H, you have F, and then you have this functional group attached to it. So you can think about these. Here is the functional group. This is being different, carboxylate. And then here is the functional group. So it is a sulfonate. So you have these two different types of PFAS. And then you can look at in the carbon chain, some of the fluorines could be substituted by H. So you can imagine the permutations and combinations, with the substitution of fluorine with hydrogen, and then these the functional groups, and that carbon chain length. So what I'm showing here is 8 carbons, but you can have, any number of them, 4, 5, 6, 7, 8. So with these combinations, you can think about PFAS as a huge number of chemicals. So it's expected, it's stated somewhere that this 4,500 PFAS compounds are existing. And these are commonly used for a lot of consumer and industrial applications because, compared to CH bond, if you have CF bond, it's very, very strong. So, and also it forms it is repellent to oil and water, and it's very resistant to friction, degradation, and fire. So, basically it becomes a very, stubborn, applications. So you have surfactants, resins, mold, and for fighting fires, they use this AFFs containing the PFAS. So because of that those properties. So all kinds of the products are using PFAS compounds. So as I said, because of these special characteristics. But from environmental point of view, if they get released into the environment, into air, soil, water, we're going to have a lot of health problems. So you could have release of these PFAS from different sources. As I said, commonly, firefighting. We use these chemicals to suppress the fires. And industrial sites where PFAS is used or PFAS is being manufactured, so they have the waste disposal problem, and you will have release there. And landfills and dump sites and wastewater treatment plants and biosolids, they all contain these PFAS compounds. And once they are in the environment, they could infiltrate into the soil, infiltrate into the groundwater. And groundwater is found to be contaminated. Surface water could be contaminated, and you could have different pathways of exposure, and that could cause a lot of health problems to humans. Here are the problems that are identified by the US EPA, and you have problems for animals. So these are, as you see, some of them are carcinogenic. So this is definitely not acceptable. So if we have groundwater contaminated with PFAS, and you are drinking that one, definitely it's going to lead to a lot of issues. So recently, realizing this, US EPA has set very low standards for these PFAS compounds in drinking water. And if you don't meet these requirements, then you need to do the treatment. And there is federal regulations, and the state regulations are different. So what I'm sharing is, this is one site in Michigan, USA, where the groundwater is contaminated. So this is the city called Brighton. And the population is about 7,649. And they consume about 100 gallons per person per day. So so you have close to 7,600 plus add on something, approximately about 800,000 gallons of water is being extracted from the groundwater and being used for drinking water. So you extract it, and then you treat it, and then distribute it for drinking purposes. But at this location, this is the industrial facility. It's called March Coating Incorporated. It's permanently closed, but I'm showing you the building here. And this is the company that was using, it was, it's a coating company. So it was coating different kind of materials, different things, as I'm pointing out here. And obviously, in those operations, they were using, PFAS compounds in this one. And, the groundwater monitoring is done. They install some wells around, and they monitor the groundwater, and they found high levels of these PFAS compounds. So they are much higher than allowable limits in the groundwater. So if the groundwater is contaminated, if it is contaminated underneath, it doesn't mean that it's not migrating. One of the unique characteristics of these compounds is that they migrate. They have high solubility and they migrate faster. So the entire groundwater resource is being affected by this one. So really, these are the limits that state of Michigan, the environmental regulating agency, set forth. So you have high concentration levels. So the goal is to reduce to these concentration levels. So the whole idea is, the water that you're pumping, the 800,000 gallons per day, that needs, extra treatment. Right now, the treatment does not consider this PFAS. So you need to have a PFAS treatment. And in this project, we are looking at, adsorption-based treatment process. And the adsorbents that we can possibly use is, granular activated carbon or ion exchange resin. So this is the typical water treatment process that you have. You are pumping out the groundwater, getting through these different steps to take care of the conventional contaminants, and then you're adding on this granular activated carbon to remove PFAS. And the absorption capacity of this GAC is known, and you can design these units based on how much water that you are trying to pump out, how much you are treating it. So what are the typical commercial units that you have? So based on that, number of these filter units are calculated. The other option is, using the ion exchange resin. Again, this in the treatment process, you can see, the filtration that is being done using this ion exchange resin. Again, you have, the absorption capacity for this one being different. So both of them are, feasible approaches. Now the question is, which one? Again, this is the ion exchange, units, to scale up to treat, the 800,000 gallons per day. Now the question is, which adsorbent treatment method is sustainable, right? So we want to apply that framework that I mentioned. You want to look at the environmental sustainability, economic sustainability, social sustainability, and then we want to integrate all of these, and then calculate a sustainability index, and based on that, we come up with a recommendation. So the environmental sustainability, as I mentioned, if you have a specific tool for your project that you're dealing with, use that one. If not, the LCA is a generalized methodology. So we use that, and then you define the life cycle stages, assembly, operation, transportation, and waste management. These are the life cycles included in this one. So you define the goal and scope, and create the inventory and do the impact assessment and interpret the results. So I'm just showing you the typical results based on this. So these are the environmental indicators. You have metrics, but generally we plot this one for the sake of explanation in a normalized way. As you see, here is the GAC versus resin. For ozone depletion, resin is not good. In all the other cases, the GAC is good, but last one, fossil fuel depletion, then this resin is not good. So in two cases, the resin is not good, but in other cases, GAC is good. So you always find this kind of a conflicting, indicators or metrics, in this case. So this is kind of a normalized response, and then see which ones are really dominant. Here we're looking at the carcinogens and the ecotoxicity being the dominant indicators. So then we do look at, that's the first part, and they do the economic sustainability assessment. In this one, you do the direct costs and add-on costs, maintenance and monitoring costs. And then, you look at the indirect costs. And then, in this case, we added social costs. You have, greenhouse gases calculated, what is the cost associated, the damage in terms of the monetary terms per ton of, CO2 emissions. So that's accounted in this one. And looking at all those things, these are the individual cost items, but looking at the overall cost, you see that GSE costs more than the raising. Then the social aspects is important things. So this is the part that is very important in sustainability assessments, because this is where you are taking the feedback of the community and the stakeholders. So that has been lacking in our engineering practice. Is the 5 minutes time?
Sorry to disturb you, Professor, but you can
Yeah.
have say 5-8 minutes more.
Yeah, I'm supposed to be done.
Yeah.
So
Thank you.
So this is the thing that we don't address, social sustainability in civil engineering. So we think about, okay, let's say we want to build a bridge, we don't contact the local community to look at what kind of a bridge they like it, so we just go there and build whatever we think good in our offices. So this is always about looking at the community, having the meetings with the community, explaining the projects to them and taking the feedback to that one. So for this one, in this project, we looked at two things. One is called social sustainability evaluation matrix that I mentioned. I developed this one in 2013 and 2014, and it is available. It's a simple Excel-based tool. You can go to my website and download it. It has the different, individual factors, community factors, and economic factors and environmental factors that could affect the community, in the project location. And then you give the scores to different key elements in each of those, and then you add them up. There is a scoring rule. And then if you don't do anything, obviously this is unacceptable. It's a lot of negative. But looking at the assessment, so this GSE comes out to be slightly better than the raising. And then it's not only that, you could create a survey questionnaire and distribute to the stakeholders, designers, experts who have knowledge about that project, and you can assign scoring system. And in this project, we did this kind of thing, and then we got the results as shown here. And no treatment is obviously bad, and GSE is better, and the raising is second choice. So this is what we get it. Perhaps the people don't really understand the resin and how it works. GSE, that's very commonly used. So you will have the perception issues when you're dealing with social sustainability. So here is the summary of what we did. Environmental factors, economic factors, and social factors. We got all these metrics, and you apply the weighing factors. And as I said, weighing factors could be equal to start with. And applying that framework that I mentioned, you can calculate the index for environmental, economic, and social, and you can add them up, get the sustainability index. So this shows that higher the number, better it is. And you can see the resin is better from environmentally, economically, but socially, you saw that one, the GSE was better, but overall, this resin is looking better. So also you can apply, how much weightage you want to give for environmental, economic, and social. This is the equal weightage. If I say that the social is higher, still I get resin as the better choice. And even if I look at economics as my higher weightage, then I still get the same conclusion. So you want to do some this kind of sensitivity analysis before you come up with the final decision. So information on this this case study in detail is given in the paper, in this conference paper. So you can get more information about this thing. So overall, based on this sustainability assessment, we looked at environmentally, resin is better, economically resin is better, but socially GAC is better. But integrated assessment, taking into account of all these factors, shows that resin is much better. So this framework, you can see the numbers, how much is better. We can say qualitatively these things, but looking at the numbers, you can see how better those are. So in closing comments, just want to mention that we should be promoting, this kind of assessment in all the things that we do. It's called life cycle sustainability assessment. And environmental sustainability assessment is kind of well established, but when we are doing these kind of assessments, we struggle with economic and social sustainability metrics and calculations. So that more work is being done by researchers in this, and very soon we will have better tools. So currently, sustainability is not mandated by codes or regulations, but as engineers, we know that sustainability is a concern to everybody. So we really need to, whether it's required or not, we should be, thinking about doing it. And also, just the final point is, you see a lot of talks about sustainability, a lot of conferences on sustainability, but just not talk, but we really need to quantify and really prove that we are really doing the sustainable engineering. So for anybody who wants to learn more about sustainable engineering, I suggest to look at this book that we wrote like last year or a year before. And this is a great textbook, if you want to teach a sustainable engineering course. So also just wanted to mention that every Friday we have a webinar series, Friday 7:30 Indian time, 7:30 p.m. Indian time. So this website will show you all the information. So you can attend this one. So this is my contact information. Again, my presentation is a bit different than conventional presentations, but if you look at it, at a higher level, sustainability is really a major issue, and we should start doing something about it in all the things that we do on a daily basis. That's it. Thank you so much, Professor Srinivas.
Yeah, thank you, Professor. Are there any questions? I think we can take 1 or 2 questions in the chat box. I don't think there are any. Anything, Dr. Umesh, so which we can address?
In the chat box, there is no. I request the participants, please.
Yeah.
Your questions
If there is
in the
any
chat box.
quick question, yeah, you can ask.
Sir, as
Yeah.
you are talking about the sustainability, so what are the difficulties that most of the most difficult most of the authors or most of the researchers got in achieving the sustainability from all three components: social, environmental, and economic combined, sir? May I?
Sorry, I didn't get it. What is the question?
Sir, what are the major, sir? I mean, sir, major points, sir, that most of the researchers got the difficulty in getting the sustainability when combinedly social, environmental, and economic.
Yeah, I think we need to start doing it. I mean, that's one of the things is people don't do anything related to the sustainability assessments. So the first thing that I would suggest is make an attempt to do it. And second thing is these indicators. You need to identify the indicators that can be expressed in quantitative terms, and then you need to have tools to calculate those things. So that would be a challenging part. And then once you have those indicators and metrics and integrating, I just suggested one of the methods that we use is, but you can use different types of multi-criteria decision analysis. But this whole process really makes the project a better project. A lot of times we just when you do this kind of assessment, you will think about substituting certain materials that are causing a lot of negative impacts, and also making economic designs, and then also truly making the difference to the community. And if you involve the community, they will feel proud of being part of that project, and they feel really good about the projects that are being done in their communities. So my suggestion is, we just start doing it. So even whatever you're doing, even this, for example, students, if you're thinking about doing some research, just ask this question. What am I doing? What am I doing? Whatever I'm doing, will it lead to? Will it contribute towards sustainability? That's one thing. and other things, anything that doing, in consulting projects or research projects, ask this question, how am I contributing to sustainability? So I make my students to think about sustainability before they embark on a research project. So I want them to, look at the big picture. I don't want them to start with a material that's carbon intense and, ultimately not going to lead to, a material or process that, not going to lead to sustainability at the end, or, so just a cursory evaluation in the beginning would really help a lot.
Thank you, sir. Thank you. Yeah, that's a very nice
Okay.
approach.
Anything from my co-chair, if he wants to ask something? Yeah. Okay. Thank you, Professor Reddy, for a wonderful presentation. And I believe the best or the takeaway from your presentation is just start doing it rather than only talking about sustainability. It is better we start doing it so that then we can really achieve it in sustainable way. That is what I understood from your entire presentation. Thanks a lot, sir, for your presentation.
Thank you so much. Thanks again for everyone.
Now I would like to invite Professor Zulfikar Ahmed. I would just introduce him. Actually, he doesn't require any introduction because his affiliation, he is a professor of civil engineering in Indian Institute of Technology, Roorkee, the Mecca of hydraulic engineering. This is what I call it. Our Professor R.J. Garde, I'm very fortunate to be his student when he was in Pune for his last few years. And Professor Rangaraju, of course, Professor Ahmed. There are so many stalwarts over there, and he is one amongst them. So I'm very, very, very fortunate to introduce him. We met many years back in Malaysia, I believe, for a reverse conference. And then of course, in IIT Roorkee, where he was the organizing chair for Hydro, I think 2015, if I'm not wrong. Dr. Ahmed, Dean Infrastructure and Professor of Civil Engineering, Indian Institute of Technology, Roorkee. He has over 25 years of teaching, research and consultancy experience with special focus on fluvial and channel hydraulics, hydraulic structures, river engineering, computational hydraulics. He has been honored with various prestigious awards like GM Navathe Puraskar and Jalabigyan Puraskar by Indian Society of Hydraulics, Pune, Outstanding Teacher Award by IIT Roorkee, Outstanding Reviewer by ASC Journal of Pipeline Systems, Engineering and Practice, name appeared in Who's Who in the World in 2005, and many more. He is the reviewer of various reputed international and national journals like ASC, IHR, IWA, and many more. Under his belt, he completed various research and consultancy projects worth more than, which is more than 150 in numbers. He is also author of 100 plus journal papers, many edited books and conference proceedings, book chapters and conference papers as well. He is a member of various reputed professional organizations and societies. Dr. Ahmad delivered various QIP short-term lectures and expert lectures across the globe. I invite Professor Ahmad to deliver his keynote address. I would say it is all yours, sir. The screen is all yours. Thank you.
Thank you, Professor Londe. You see, one correction that I would like to make here is I am no more Dean Infrastructure. My tenure is over.
Okay, sir. Okay. Or
But
we can former Dean Infrastructure then in that case.
okay, but the CV is quite old, right?
Yeah.
Uh,
Yeah.
No issue. Let me share this slide. Hmm. So as you have already mentioned about my interest area, first two things I want to confirm. Am I audible? And could you see my PPT?
Yes.
Okay.
Yes. No problem. Yeah,
So
sure.
I have this one in the presentation mode, and I am very thankful to the organizer who invited me to deliver this lecture. And this is really my a great opportunity. to introduce something related to the hydraulic structure, which is new, relatively new, okay, and having the advantages over the conventional type of the hydraulic structure. So without killing any more time in the introductory part, let us come straightway to introduce the rubber dam. We can say this one is a flexible dam. We can say this one as a inflatable dam, right? So I will share with you the some research that we conducted at IIT Roorkee, and also the internationally the research which have been carried out. And then I will also talk about the some case studies of the execution of this rubber dam, okay, in India. Although I have seen a number of the rubber dam, because the first project that we took, that was the rubber dam across the Gomti River at Lucknow. And at that time, we were maybe in this area. Then what we did is we started some research work at in our lab, and also visited a number of the rubber dam in Austria, okay, to gain the field experience. So I will share all those things in this presentation, and I hope I have half an hour, because my time that will end at 10:30. Okay. So if we'll see here, the conventional type of the hydraulic structure, as we know that in India, we have lot of the variability, both in the space and the time of our water resources. And there is no any other way, you see, for the proper management of the water resources to store or divert the water, okay, just 1 minute. Let me put my mobile in this. Mm, Just 1 minute, because otherwise that will disturb. Okay. To conventional type of the hydraulic structure. Yes, sorry. We are talking about the variability, and there is no other ways to, you see, except that we store the water, we regulate the water, right? We divert the water. And for that, we need the hydraulic structure. And in general, the hydraulic structure for the low storage, for the diversion, for the regulation that we have, that is the barrages, head regulators, right? Small dams, and there we have the gated part. So you can see here, most of you might have seen such type of the structure. So you can see on the upper part, there is a one barrage, and in the lower part, we can see here the section. And in this section, since this is a gated structure, a gate that is being provided, this gate that may be operated manually, or that may be operated mechanically. But in both the cases, the gates are to be operated depending on what water level that we have in the upstream. There is no any automation here. What we are talking about right now is the automation, right? I mean, we have to keep a constant water level in the upstream, and we have in this particular section some flexible structure, okay, depending on the water level in the upstream, that will inflate, okay, right? Or you see, you see due to the flexibility, the shape that will change, right? The main point in this case is how we can keep a constant water level in the upstream while passing the discharge which is coming from the upstream, and that has to be passed in the, or that has to be a spill in the downstream. The concept of the rubber dam that is coming here, and we have to concentrate on this part. Rest of the structure that remains to be same. I mean, the crest, upstream flow, downstream flow, and we have to use the conventional Khosla theory, seepage theory, for the calculation of what would be the thickness, what would be the exit gradient, all those things, right? However, since the gate, depending on the gate, the flow structure in the downstream, that will be different. And the energy dissipation, that is to be looked at, right? So in the rubber dam, the flow is over the rubber portion. So we have to ascertain the energy dissipation in the downstream. So for that, some model study that is required, or you see, we can do some, you see, the physical model study or the numerical model study, right? So let us concentrate on this part. And here, this is the automation with the introduction of the rubber part. So you can see here, this is the rubber membrane, and this is a flexible membrane, right? So there will be, you see, once this will be the action, and this will be the action depending on what the water level we have in the upstream. Like the conventional barrages or such type of the regulating structure, we have the base here, right? A number of the base depending on what is the, you see, the width of the structure. I mean, in the normal two.
I think there seems to be some problem. I think we will wait.
Since.
Yeah, we will wait. I think he
Yes, sir,
will
yes, sir.
rejoin.
Yeah.
Yeah.
Yes.
Yeah.
Rubber dam, because in India we have gone only up to 3.3 meter. Gomti 3 meter, a new project which is over.
Sorry to disturb you, Professor. I think
Yeah.
some in between, for some time, you were not audible. We missed some of your lines in between. You
This
were
is
you were explaining the water will overflow the rubber dam, and
okay.
what case time, the energy dissipation, and all these things you were
Yes,
explaining at that time.
just 1 minute. Let me check my audio and all, because okay, just 1 minute. Of course, there is a
Yeah. You were at slide number 3.
okay, just 1 minute. What happens to this? Hmm. May I continue because I am unable to rectify this.
No problem. No,
Am I
no,
audible
no
to you?
problems. Yes, yes, yes. Now you are
Okay.
audible, clear. No problem. You can
Okay.
continue.
I think there may be some problem with the presentation mode. So let me go with this without any presentation
Yes,
mode.
sir. Yes, sir. The way you are comfortable.
It,
No problem. No
okay,
problem.
okay, just one
Yeah.
minute. So you can see here, this is the slide where we have the Janjavati rubber dam. Is it clear? Is it visible?
Yes, 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 yes.
Okay. So this is the first dam that is constructed in India, in Andhra Pradesh in 2005 and of the height of 3.3 meter. And we can see another dam that is in the Italy, okay, and successfully that is operating, that is functional. You see the some salient points of this rubber dam. Of course, this is a tubular type of the shape of the rubber part, okay, and that is inflated depending on the internal pressure, right? This is, of course, very useful for storage of the water, for diverting the water. As I told you, this is an automatic type of the structure that control the water level in the upstream and also the flow, right? In general, you see the one bay of the rubber dam has gone up to 100 meter in Falgu River, that is 65 meter. But with the special membrane that may be taken up to 200 meter, and also the height may be increased from 5 meter to 10 meter, right? Okay. The merits of this rubber dam is, of course, this is the flexible type of the structure, and we have the liberty here. We have a good control over the regulation of the flow and the water level in the upstream. This is a complete automatic reservoir. You see, uh, complete control of the reservoir level in the upstream. And once that is automatic, in that case, and we are maintaining a water level, constant water level in the upstream, so submergence that can be avoided because once there will be high flow, then this dam, okay, the rubber part, that will be flattened, okay. And this is a low cost and the maintenance cost. You see, no manpower here that is required. Of course, little bit maintenance, whatever is that will be required in this case. So these are, you see the merits of the rubber dam. We have the two process here. One is the inflation and second one is the deflation of this. And in this case, you can see here, once we inflate this, then this one is of course rising, right? And once we deflate this, then this one is dropping. So here the crest that is being controlled. So in place of raising the height or opening of the gate, here the crest that is being changed, and in that way the water level that is maintained in the up is constant water level that is mentioned in the upstream. And if you see the system, this is of the Hydro Construct. This is the one company in the Austria that execute the work of the rubber part. So in general, once we are going for a rubber dam, in that case, there is a two component. One is the civil part, another was the rubber part. So this Hydro Construct, and there are many more such type of the company that are providing the rubber and the complete control system. So we can see here in the control system, they see the rubber part here, okay, and here these two pipelines that is going, and those pipelines for the inflating the dam, and the one pipeline that is for the deflating the dam, means that this crest level that will be lower down. And this one is a complete automatic system. So depending on what is the water level in the upstream that is being sensed, and this control system that will work accordingly, right? In this control system is for the water field. So you can see here is a water field, right? But air field systems are also being provided. So we can see here, this is the section of the rubber part, and for the filling, we can see here the two pipes, and for the deflecting of this, we have the one pipe, okay? As I told you, in the rubber part, the filling material is concerned. Of course, we have the air inflated dam, water inflated dam, and the water and air inflated dam. In the air inflated dam, of course, this is easy for the construction, right? And you see easy for the operation also. And you see the time for the operation in the for the inflation and for the deflation, that is low in the case of the air, in the case of the airfield, right? So if let us say a flash flood that is coming, and we have to repeatedly we have to lower down the crest, in that case the airfield that will be more suitable. But airfield is subjected to buckling, right? So I will show you the one photograph, but that can be controlled by providing the more internal pressure in the rubber dam. As far as the water inflated is concerned, of course, this is very stable, right? But you see the piping mechanism and all those things, right? That is expensive, okay? And in this case, of course, the time for the operation, for both the operation mode, that is more compared to this air inflated. So you can see here in the case of the air inflated, such type of the buckling, okay, that occurs, but that can be controlled. That can be controlled by, you see, with the increasing the internal pressure. So there is a team in the Karlsruhe that is working on extensively working on the rubber dam. So this Gebhard, that is from you see the Germany, and there are, I mean, he is having a team that is working on this part. So a lot of the research work that is going on at Karlsruhe. Now, if we talk about the hydraulics of the rubber dams, so of course we are interested here because we are allowing the water to flow over this rubber dam. Okay, in particular in the deflated portion, deflated condition. Once we have the you see the water that we have to pass from the upstream to the downstream, right? So what will be the discharging capacity of this one? How, of course, we can write a very simple equation here. So this is the unit discharge CD under root 2G and H to the power 3 by 2. Here H is the head over this. Since the profile of this rubber dam that changes with the internal pressure, right? So this CD is no more constant, and the work that is being carried out internationally by the Al-Hamati in 2005 related the CD with the H by DH. I mean, the H is the head over the crest at any particular time, and DH is the height of the rubber dam, right? This is for the air-filled rubber dam, because the profile, as we know, the profile will change, the CD will change, right? And here the internal pressure is related somehow with this height of the dam. More internal pressure means more height of the dam. So CD, that is related with the height of the dam. So that is anyway that is taking care of the internal pressure also. The work that we did at IIT Roorkee for the water inflated rubber dam, we come out with a very simpler equation, okay, same as more or less same as the I mean what is reported in the literature, okay. But of course, before recommending this one, a lot of the further study that is required. So now you can see the setup that we did in the lab. So this is a channel of you see about 40 centimeter width, and the rubber dam that is being provided here. Okay, and this is water filled. So we did some, you see, some mechanism to fill the water in this rubber. So you can see here a tank in the upper part. Okay, elevated tank, and that is providing the water to this. Okay. On the right hand side, you can see a close picture of this rubber dam. And this one is a profile. So in general, this rubber dam that is being provided on the crest, okay, of the conventional type of the weir, okay. So you can see here, this is a concrete part. And how the CD that is varying with H by du, of course, that is increasing, and how that is changing with the internal pressure. So these are the things. One thing that is very important from our finding is, okay, we'll see later on the profile of this rubber portion, okay, for the different internal pressure, right? So there is a internal, you see pressure coefficient, okay, alpha that will define, that is the ratio of the internal pressure, okay, in this rubber dam divided by the depth of the rubber dam. Okay, so depending on that alpha, we have the different profile. But once there is a flow for the same internal pressure, there is a distortion, okay, in the shape of the profile of this rubber dam. And you can see here, once we have the more discharge, so due to the hydrodynamic force which is acting from the upstream, right, this is deflated, right? And if you have the low discharge, in that case, of course, the shape, there is not much change in the original shape, right? Okay. Of course, what would be the water surface profile, and in particular, the streamline that is adhering to the surface of this rubber dam part, okay, and from where there is a separation of that flow, that is a very, very important, because once there is a separation of the flow, right, then there, of course, there is a lot of the, you see the turbulence and the formation of the eddies. That is a very highly complicated. There is a variation of the pressure, and such changes in the pressure, right? That is, of course, causing the instability or the vibration of the dam. So this is really a big problem with this rubber dam as far as the vibration is concerned. But you see that is being controlled by the deflector. So you can see in this particular case, you see what would be the profile of the rubber dam for the different internal pressure. As I told you, the internal pressure coefficient alpha, which is the ratio of the internal pressure by the height of the dam. So for the, of course, for the high value of the alpha, this is in the inflated position, and for the low value of the alpha, I mean low internal pressure, this is in the deflated position, right? And from the structural consideration, what would be the tension in this profile for the different value of the alpha, right? That is being worked out, because once we, what is being done in this case is this is being bolted, okay, or this is being anchored in the upstream and the downstream, okay. So once what would be the strength of the bolt or the anchoring system, all those things that are being decided on the basis of the how much tension that is acting there. So that may be calculated by these two equations. This is well accepted, and we have used this one for the design of the Gomti rubber dam and also the Falgu rubber dam. The work that is done by the Jensen in 1998 and some more work by the Jensen later on, that is relating, as I told you, the flow which is, you see, passing in the downstream, adhering to the surface of the rubber dam, that is very important. So now you can see here, I don't know whether my pointer is visible to you or not, or my cursor is visible to you or not. But here the deflector that is being provided, okay, to deflect this jet, okay, or the nap. And what would be this angle of the deflector? What would be the profile of this nap? What would be the pressure distribution downstream of the deflector? All those things that has been already worked out, okay, right? And due to this, there is a lot of the pressure fluctuation. Even for a single discharge, there is a, due to the turbulence, there is a lot of the pressure fluctuation, and due to that, of course, what happens that there is a vibration in this land. But with the provision of the deflector, that is being controlled. So for the vibration and the countermeasures, as I told you, due to this fluid and the structure interaction, okay, the vibration that occur in this rubber dam, and that is being controlled with this deflector. I will show you this some photograph here. There is a Japan is also working on that. There is number of the rubber dam in the Japan also. They have the code. Japanese Institute of Irrigation Drainage, they have a code, right? Okay, for the design of the rubber dam. So here you can see this rubber portion, okay, and the vibration that is you see that is occurring here in this rubber dam, okay. So we have here, of course, the pressure fluctuation, we have the uplift force, right, and all those things that are contributing to the vibration of this rubber dam, and that is being controlled by the deflector. So you can see here in this photograph, the first photograph here without any overflow. The deflector that is being provided here in the two rows in the staggered manner. What would be the size of the deflector? Of course, the model study for that is to be carried out, okay, or the some numerical analysis that is to be carried out. And this is the flow condition. Flow condition here on the right hand side bottom photograph under the flow condition, right? And you can see a milky water in the downstream. So due to this deflector, of course, there is a lot of the air entrainment. So this is very good from this consideration that, okay, you see here, you see the BOD, of course, sorry, oxygen of this dissolved oxygen of this one that is increasing in the downstream flow, right? Then I'm coming to the case study here. This is the Gomti rubber dam, right? And the Gomti rubber dam, of course, this is rubber dam which is across the Gomti river at Lucknow. And here the navigational channels are also being provided. So if you can see this sketch, which is on the right hand side, there are 4 bays, each bay that is of the 54 meter, right? And there are 2 bays on the right hand, one on the right hand side and another one on the left hand side. These are the navigational. You see, in this navigational channels, the 2 rubber dams that are being provided, just like in the navigational log, right? But in this case, this is automatic. So for the passage of the vessel, for the passage of the, you see the boat, right? You see in this case, but this project that is on hold due to some political reason, right? And of course, these drawings that will be not so much clear because this is a big drawing and I have tried that one on the just A4 size, right? But you see, we can get some references out of this. So if you see here, the section that remains to be same as we have in the case of the barrages. But in this portion, the rubber dam that are being provided, rubber portion. And for the navigational channel, the 2 rubber portion that is being provided, one in the upstream, another one is in the downstream. Then coming to the Falgu River at Gaya in Bihar. So there is a religious place, and that is the Vishnu Pad Mandir. I think some of you might be knowing this is a holy religious place, right? And that is located on the left hand side of the Falgu River. And in this Falgu River, mostly the flow that is a subsurface flow. I mean, under the, you see below the bed, right? So here the, you see the proposal was to create a water body in the upstream, okay, right? And for that, for better control of the water level, a rubber dam that is proposed just downstream of the Vishnu Pad Mandir. And here this is the length of this one is 411 meter. And in this case, there are 6 bays, each of 65 meter. Okay. And of course, the piers are being provided for a thickness of, I think, 2.5 meter. But this, as far as the rubber dam is concerned, of course, controlling the water level in the upstream, that was fine. But the main, another problem here was because the most of the flow in this case was as a subsurface flow. Okay, to reduce the seepage, right? What is proposed here is to provide the diaphragm wall and the sheet pile, right? Okay, so that the seepage that can be controlled. So you can see here, this is the 6 bays, right? And on the left bank, you can see here the sheet piles. On the right hand side, sheet piles. Here the combination of the sheet piles and the, you see the diaphragm wall that are being provided depending on the strata, soil strata there. And in the upstream of this dam, as we provide the upstream cutoff, okay, the sheet pile that is being provided up to the hard rock, okay. And the grouting is also being done in this particular case where we have the loose material, right? So by that way, of course, it is being emphasized that we can store the water and we can regulate the flow while maintaining a constant water level in the upstream. So you can see this section here. Again, this section is more or less same as the barrages, but here the dam part, okay, that will, of course, that is having a rubber. I will take just 1 or 2 minutes because 10:30 is already. So this is the large portion. As I told you, this is to be bolted here in the upstream or downstream, this rubber component. Okay. And for that, we should know how much is the tension in the rubber part, right? Now, since there is a lot of the issues and that are to be addressed, I think you see, we have to conduct some more studies. I mean, some more studies that are required, whether we conduct, okay, in India or abroad, okay. So I have just summarized regarding the discharge and the flow characteristics, the nap separation and the reattachment, at the work done by the Jensen. Extension of this one is required because you see, to my knowledge, only in few cases a good scale model that is being tested. And as far as the turbulence is concerned and the separation of the NAP and ADs are concerned, it is better to have a prototype structure or to have a large scale model. The structure and the fluid interaction, profile of the dam for the internal, different internal pressure and the flow, right? Because this is also governed by the flow that we have seen in our study. This is the most important, is how this sediment that will be managed in this particular case. And I think this will be beautifully managed here, because once this dam that will be deflated, then we are coming just on more or less on the bed of the river. So sediment in the upstream that can be easily passed during the flood time, but in the other time, since we are controlling the case, there is low, and there maybe you see the siltation upstream of the rubber dam, right? So flushing of that one is to be done. Then the stability and the vibration, a special arrangement for the downstream energy dissipation, okay, because there is a fall of the water, and of course the control of the buckling in the air-filled dam. Just for the, I hope this, I will share this PPT with the organizer, and organizer may pass on this one to the potential user, okay, and the students. I have given some references here that will be useful for the youngster, okay, who wants to work on the rubber dam part. So this is something from my end as far as you see the flexible rubber dam that is concerned. I love to have some questions if you have.
Yes, thank you very much, Professor Ahmad. I think there is one question. I believe Dr. Azmatullah from West Indies is over here, and
Yes, okay,
I think,
okay.
yeah, he's asking something about what about analytical model for alpha?
Uh, Professor Azmatullah, first tell me, how are you?
I'm fine, Professor. How are you? You have shown
Yeah.
some graph, so I recognize that
Okay.
one.
Are you fine? Are you fine?
I am fine. I am fine. Thank you.
Okay. You
Thank
see,
you.
this alpha virtually some mathematically, what would be the profile of this rubber part? Okay, that is being done by the some investigators, right? If you are
Okay.
interested, I can share with you those paper, or you can download that one also. So they have used some mathematical equation, I mean some spline type of the equation, okay, and for the different pressure
1 point
inside, okay,
exactly
they have,
match.
okay.
Okay.
Thank you very much.
And
Thank
you can see that you can see this analytical, physical, and numerical, okay, which is being done by this girl Hart and his team. This profile is somehow matching. So you might have seen in one of the slides.
Thank you, Prof. Thank you.
Okay.
Okay. There is one more question, Professor, and that is from Dhauleshwar Rao. He is asking you about, do you have any arrangement for disposal of flood water?
No, this flood water that is to be passed over this dam.
Yes,
Once this
actually,
flood
it
is
is more.
coming, see, the beauty of this one is we are putting a sensor in the upstream, right? Okay. We are putting a sensor in the upstream. Once the flood will come, the water level will rise. And once that will rise, this dam that will be deflated automatically, right? But one thing that I would like to you see put before the audience, here we have to analyze because a hydrograph is coming, right? Okay, at what rate we are deflating this dam? Because if you are taking more time, okay, in the deflating of this, then the water level that will rise in the upstream. And that's why in the Falgu River, we are going for the airfield because the airfield can be, you see, that can be deflated easily, okay, and repeatedly, right? So that analysis is to be done. And the second thing is, uh, I think we have to put one more sensor much in the upstream of the rubber dam. Let us say for 4 5 kilometers, because if the any flood is coming, or we should have some SCADA system, right, where the rainfall in the catchment that is to be somehow linked with this control system. At least we can get the information, okay, this much is the rainfall and this much is the flood that is likely to come. But as far as passing the flood discharge is concerned, of course, this will be completely deflated, okay, and the water that will pass over this. Of course, we are not using because there was a proposal to have the rubber dam. The engineer in chief of Uttarakhand Irrigation Department contacted me regarding putting the rubber dam across the Alaknanda River. But you see what happens that once you have a boulder bed river, so due to the impact of the boulder on the rubber part, even though that is reinforced, there is likely to be damage. And that's why in the boulder bed river, of course, we are not going for such type of restriction.
Okay. Thank you, Professor. I think there are no more questions. There seems to be one more, only the last one. What is the necessity of grouting? It's a rubber dam.
See, in this Falgu river, once we did the soil exploration, I mean the soil investigation, we found that in the line that we had marked, where we have to put a diaphragm wall or a sheet pile, okay, we found that there is some loose material and loose fracture material, gravel type of the material. So in that case, we can't drive the sheet pile in that such type of the straight. Okay. And once we are putting the diaphragm wall also, then the depth of the diaphragm wall that will be more, and excavating those materials from there, that will be difficult. So proposal here, what finally we propose in this case is up to certain depth, I mean up to the the layer of this fracture material. Okay, we go for the diaphragm wall, and below that, okay, up to the hard rock, that is to be grouted so that we can reduce the hydraulic conductivity and we can control the seepage.
Okay. Okay. Thank you, sir. I think it is 11:40 now. There are certain other questions, but I would request the participants to mail you. I request you to answer them if there are any certain queries, so that we can go ahead with the presentations. The speakers are already there. So with this, let me thank you again for this wonderful presentation on rubber dams. Thank you, sir. And Dr. Umesh,
Bye.
yeah.
Okay, thank you. May
Thank
I
you,
sign
sir.
out?
Yes.
Thank you.
Yes.
Thank you, Ahmed sir. Thank you, Dr. Ahmed sir.
Thank you.
So I'm very happy to see Dr. Ahmed sir. I'm seeing on live after a very long time. He's my guru, my mentor. I completed my PhD under him. So after I think after 3 years, I'm seeing the face of Ahmed sir. Thank you, sir. Thank you for being there, sir.
Okay, okay, okay. Thank you. I will
Okay.
share, Dr. Umesh, I will share my PPT in PDF form. You can pass on
sir.
to the, the participants. Okay?
Yes, sure,
Yes.
sir, sure.
Okay, thank you.
Thank you, sir.
Okay. Thank you, sir. Now, Dr. Umesh, do we have an idea that how many presenters are there? Any such thing, or directly we should start?
Yes, sir. We can go by the ID wise number paper, like the
Okay.
60 is starting from there.
Yeah, that I
Paper
would
ID
do.
60,
And I would request you to make my co-chair, Professor Ruben, also the co-host, so that after certain
Yes,
time,
sir. Already made,
give.
sir.
Yeah, okay.
Already made.
So I think let me first start some 4 or 5 papers, and then I think you can do this session. You can take it from there. So I believe that the presenters are ready. I'm not cutting any time because we are quite okay. The first paper is paper number 60 from Unni Nair, VS, and Lini Chandran, who is going to present. I would request the organizers to unmute them. Paper ID 60.
Yes, sir. Paper ID 60.
Sir,
Which name you are there? Yeah, even okay.
Yeah, it is identification of groundwater
Okay.
recharge.
sir, I'm presenting. I'm Ardravi.
Okay,
Okay.
fine.
Are we giving them any warning at maybe 8 minutes or after 10 minutes? Is there anything like that? You are taking any
Yes.
timing?
Yeah. 7 minutes are given for the presenting, as rest 2 or 3 minutes will be for the question and answering session.
Okay, so all of you please listen what just he said, that 7 minutes you should present, and then 2-3 minutes you can keep for any question and answers. So I think after 7 minutes you would just warn these people, isn't it?
Yeah. Presenter status is given to paper ID 60.
Okay, sir.
Yeah. Okay. Yes, you can start. Your presentation is visible. You can start.
Okay. Good morning, everyone. Myself, Ardravi. I'm a final year UG student of Government Engineering College, Baton Hill, Trivandrum. Here, I'm presenting my paper on the topic Identification of Groundwater Recharge Potential Zones in a Steady Region of South Kerala. This work has been done by myself, Mohammad Irfan Y, through the MS and Unni Nair VS under the guidance of our Assistant Professor, Lini R. Chandran. Groundwater is one of the most important natural resources in our daily life. And due to various reasons like urbanization, population growth, higher agricultural and domestic demands, etc., the freshwater resources are being depleting day by day. and it has also led to problems like water scarcity and drought. Hence, it becomes highly relevant to conserve them for future, and thus the investigation of groundwater potential zones and recharge zones is of prime importance. For our study, we have selected the Karamana River Basin, which is one of the most populated region in South Kerala and is also one of the major source of drinking water supply, which is now facing water scarcity. And the basin is located between north latitude 8 degree 5 minute and 8 degree 7 minute and east longitude 76 degree 45 minute and 77 degree 50 minute. And it has a total area of 702 kilometers square. And there, due to urbanization, the groundwater pumping exceeds the rate of recharging, and it has led to the lowering of water level in the aquifer. So it is necessary to adopt proper water management methods in this area. So we can collect the surface water from there, and it could be allowed to infiltrate artificially into the aquifer. We have considered 6 major factors that influence the groundwater recharge potential, and they are soil, slope, lineament, drainage, land use, and geomorphology. Then the spatial analysis can be done using geographic information system, where the weighted overlay method is used to create the groundwater potential zonation map of the area. Also, we could propose suitable groundwater recharge structures over proper location. These are the steps that are involved in our study. So first is data collection. We have collected the digital elevation model of a study region and also some shape files. Next, we prepared the thematic maps using the collected data. After that, the weights were assigned to each of them using weight analytical hierarchy process. Then the weighted overlay analysis has been conducted, and finally we got the groundwater recharge potential map for our study region. So the results and discussion, as I have already told, initially we prepared the 6 thematic maps, and at first we prepared the slope map, which shows the slope of the surface of the area, and it was prepared from the DEM, which was downloaded, and we used the spatial analyst tool in ArcGIS software. This is the slope map of our study region. Here the green color denotes low sloped area and red denotes steep slope area. So lower the slope, then higher is its infiltration capacity, and thus it increases the groundwater recharge. Next, we prepared the drainage map that was also generated from the digital elevation model using raster calculator tool. And it helps us in identifying the infiltration and permeability characteristics of river basin. So higher drainage density had lower infiltration capacity, and for a proper or suitable recharge potential zones, we required areas having lower drainage density. Next is the geomorphology map, which was downloaded from the Bhugosh website. There the geomorphological mapping identifies the characteristics of different landforms. In our study region, most of the area was covered by pediment periplain complex. Then the soil map, which shows the various types of soil that are seen in our region, and it was obtained from the soil grid site. In our region, the most of the area was covered by gravelly clay soil, and it was comparatively coarser. So the coarser green soils have higher infiltration capacity, and also the chances of groundwater recharge potential increases there. Now the land cover map, which shows the purpose for which the land is being used and also the various land resources that are seen in a specific region. It was prepared from Landsat 8 images using AirDAS imaging software. Our study region was mainly covered by vegetation. And finally, we prepared the lineament density map, which was prepared from the digital elevation model using hillshade and line density tools in the ArcGIS software. Lineaments show the linear features on Earth, which provides the pathway for groundwater movement. And thus, higher the lineament density, higher is its recharging potential. Here, the red zones are the areas having higher recharge potential. After the preparation of these maps, we have assigned them weights using the analytical hierarchy process, and for that we used the software Super Decisions. There the weights were computed by creating a pairwise comparison matrix in which the rows and columns were given as the criteria. And also the metrics were filled based on the relative importance of all the 6 parameters. Finally, we got the weights for each of the map as 36 for land use land cover, 23 for geomorphology, 16 for lineament density, 12 for drainage density, 8 for soil, and 5 for the slope map. So then we carried out the weighted overlay analysis in the ArcGIS, and we got the output as groundwater recharge potential map. And that map has been classified into 5 regions. They are very high, high, medium, low, and very low potential region. The very high and high regions are more suitable for groundwater recharge, whereas low and very low region is not at all suitable. So this was the groundwater recharge potential map that we have obtained for our study region. Here 1 stands for very high, 2 for high, 3 for moderate, 4 for low, and 5 for very low. So here the major portion of our study region falls under the high category, and it shows that our study region is suitable for groundwater recharging. Here the eastern part was only having this low region, and mostly due to the steeply sloping terrain. So this study proposed the suitable groundwater potential zones for the Karamana River Basin, and we found that most of the area was suitable for groundwater recharge, and those area comprises of lower slopes and lower drainage density, gravelly clayey soil, and vegetation cover, which induces high infiltration capacity. Also, in order to improve the groundwater level and quality in that region, we could also construct artificial recharge structures. In our study, we have used the ArcGIS software, and it was found to be a very useful tool in combining different information to find suitable regions for these groundwater recharging. Also, it was found to be more economical and less time consuming, and it gave more accurate spatial information compared to other conventional techniques. These are some of the references we had. Thank you.
Okay, a very good and timely presentation. Are there any questions?
I request participant, if is there any question, you can write in the chat box also. And you can raise your hand, you can unmute yourself also.
Yes. Dr. Ruben, Dr. Azmat, any question from your side?
No, sir, no.
Okay, I have just one small query. Yeah, sure. Yeah, you can ask. Okay, there seems to be some problem. I have one small query. Is this work actually being done, or it is just an academic exercise?
Sir, actually, we have done this as our project for final semester.
Okay, and that means and that too you have used some kind of software for dividing those or giving those influences. Am I right?
Yes, sir, we have used the ArcGIS software.
Yeah. The question is, when you got those influences, like some 23, 25, something for NULC, have you checked these influences in comparison with the theory, that what really happens for groundwater potential with respect to these parameters, the influences theoretically, and what you have got using the software? Have you just checked or verified these things?
Sir, actually, those we have done based on past or previous studies. Those values using AHP, we have done it like that.
Okay, but whatever values you have got of the influence, you haven't checked it or you haven't confirmed it using your theoretical knowledge.
Actually, sir, that was in that the land use that was being more important compared to other. Yeah, yes, sir, we have also checked like that.
Okay.
Okay, sir.
Yeah.
Actually, verification is required. In fact, if there is the model, whatever the inputs you will give, some output will be there. But how much output is reliable, that is need to be verified.
Exactly.
Yes, sir.
Exactly. That is what I was pointing out.
Mm.
Sure. I think that is okay. We can go for the next paper. That is paper ID number 79 by Gayatri Mohan.
Yes, sir.
Determining the optimum groin. Who is presenting?
Myself, Gayatri Mohan.
Okay, now the screen
That's
is all
very good.
yours. You can present for next 7 minutes or so. Thank you.
Presenter status is given to you. Please share your slide. Continue.
So just 1 minute. Sir, is my screen visible? Can you see the
Yes,
presentation PPT?
Yes. Please proceed.
Okay, sir. Okay, sir. The slideshow is also visible.
Yes, all right.
Okay, sir. So, good morning, all. Myself, Gayatri Mohan, a final year BTech student from Department of Civil Engineering, GC Barton Hill, Thiruvananthapuram, which is located in Kerala, India. So here I am to present the results obtained for our research work determining the optimum growing inclination in river training works. So moving on to the introduction. Riverbank erosion is a key process in river morphodynamics which affects a wide range of physical, ecological and socio-ecological issues in the fluvial environment, as what we can see in figure 1. So in order to mitigate these kind of adverse effects, river training methods are used. So direct methods or indirect methods are the broad classification of these river training works. Direct methods includes walls, gabions, etc. Whereas these indirect methods includes the in-stream structures such as groins. So what is a groin? A groin, built perpendicular or obliquely from the bank, is a rigid hydraulic structure that interrupts water flow and limits the movement of sediment along the bank side. So here, the study has been carried out with the aid of finite volume-based software, that is ANSYS Fluent, which make use of computational fluid dynamics. Now, moving on to the literature survey that we have done, Beheldin in 2007 had developed design guidelines for shallow groins using different groin parameters. The optimum groin design parameters with maximum efficiency was obtained. Krishna et al. In 2015 had introduced coil geotextiles in the form of cockalogs to make the groin more eco-friendly. The study analyzes the effects of placing groins at different angles from 45 degree to 135 degree and also to find the most effective arrangement for minimizing the erosion. Abhay Messiwal in 2017 had analyzed the variation of velocity and shear stress over the flow field in order to identify the behavior of different groins placed in series. He also analyzed the flow around the spur and tip velocities and hence calculated the maximum velocities, maximum bed shear, and maximum turbulent kinetic energy. Vaughan and Analder in 2008 discussed about the field study conducted on River Spree near Berlin, where 7 groins were placed into a reach and their effective mean and turbulent flow patterns were investigated for submerged and immersed conditions. Now moving on to the objectives of our study, to study the influence of inclination on the flow field and consequently the flow modulation effect being induced over the bank side, to study the effect of groins on flow variables like pressure variations, velocity variations, and the subsequent advantages and disadvantages in the flow trajectory, to conduct numerical simulation using computational fluid dynamics, that is ANSYS Fluent, to study the flow and turbulence pattern and their effect on morphology. Now, moving on to the methodology of our work, computational fluid dynamics mainly have 3 phases, that is pre-processing, solver, and post-processing. Pre-processing involves geometry and meshing. So before moving on to geometry, we'll have to set the frame as 2-dimension in the project schematic, which is available in the ANSYS workbench. So first of all, we shall select the design model for geometry. So geometry is the construction of the whole structure with the required dimensions. So after constructing the geometry, we shall move on to meshing, which is the discretization of the whole structure into finer elements. Least the mesh size, greater the accuracy of the result. So after completing the pre-processing, we shall move on to the next phase, that is solver. Solver consists of setup and solution. So in setup, we assign the method, model, and boundary conditions. And in solution, we assign the solution control, solution methods, and there are certain other values in order to calculate it. So after running the calculation, we obtain the result. And these results can be further processed using the post-processing phase, that is phase 3. So that is all about the methodology. Now the input conditions that we have given. The analysis system uses fluent, that is fluid flow, and the material is fluid, and that is water liquid medium. The flume is a straight flume with 100 meter and with 30 meter. The growing length is 10 meter and growing thickness is 0.3 meter. The mesh size is 0.3 and mesh shape is triangular. The velocity magnitude at the inlet has been given as 2 meter per second. The model considered here is viscous standard K epsilon model with 2 equations. Now moving on to the geometry and meshing, which is a part of pre-processing. In every simulations, the groin is placed at a distance of 30 meters from the inlet. Inlet is taken as the reference point here. So in figure 3, we can see the inclination at 45 degree. At the right side, we can see the image after the construction of geometry. And at the left side, we can see the image after the construction of geometry, and right side after the meshing. So similarly, figure 4 and 5 indicates the geometry and meshing for inclination at 90 degree and 135 degree. So moving on to the results obtained. These are the velocity contour obtained after the simulation. So here the dark blue color indicates accretion, that is protection. So just have a look at figure number 6. There we can see that at the upstream side there is sufficient protection, but at the downstream side no protection can be seen. Also the vorticity formed has a chance to hit the opposite bank. Moving on to figure number 7, velocity contour at inclination 90 degree. There we can see that either sides of the groin we have sufficient protection, and also the formation of vorticity, the movement of vortex along the direction of flow, which means that it does not hit any of the bank side. Now moving on to figure number 8, that is 135 degree, which is an attracting groin. There it's very clear that we cannot see any kind of protection on the upstream side, but there is sufficient protection on the downstream side. But the formation of vorticity indicates that it moves to the concerned bank itself. That is, the moment of the oscillations can occur to the same bank itself. So from the contour itself, it is very clear that 90 degree is the only inclination which provides the protection in both the upstream and downstream sides. Now moving on to the graphical study, that is the velocity variation with change in inclination. So these are the normalized graphs obtained after selecting a section, an imaginary section throughout the width of the flume. So here we introduce a term called x. X is the longitudinal distance which is taken from the inlet, that is the reference point. So let's have a look at figure number 12. So their velocity variation at x is equal to 20 meters. So there we have considered a section throughout the width, and the velocity variations of each, all the 3 inclination is being shown there. The capital Y indicates the width of the flume, that is 30 meter, and capital V on the Y axis indicates 2 meter per second, that is the inlet velocity. So in the first graph, we can see that 45 degree is showing a very positive result on the bank side, but it is increasing its velocity at the midspan than that of the other 2 inclination. And the other 2 inclination shows a very gentle transition from the bank to the opposite bank. Moving on to figure number 13, that is the velocity variation at x is equal to 30 meter. That is the point of application of groin. There we can see that for 45 degree, greater amount of turbulence is formed, that it is showing 2.3 times greater than that of the velocity, input velocity. And the other 2 inclinations, 90 and 135 degree, both of them shows a very gentle transition from this bank to the opposite bank. And moving on to figure number 14, there the downstream side, velocity variation at x is equal to 35 meter. There also we can see that the 45 degree is showing a greater amount of turbulence than that of the other 2 inclination. From all these upstream, at the point of introduction and at the downstream, 90 degree shows a very positive result, and hence it can be concluded as the optimum angle. Also, the other important point is at the opposite bank, the velocity always remains as 2 meter per second. That means that the introduction of this groin does not affect the opposite bank. So let's move on to the conclusion. The simulation is done to find the optimum inclination. Attracting, repelling, and straight groin were used for the study. Velocity and pressure contours were used to study the effect of single groin in the flume. Repelling groin, that is 45 degree, it protected both upstream and eroded. It protected the upstream and eroded the downstream. Attracting groin, that is 135 degree, eroded the upstream and protected the downstream. A straight groin of 90 degree inclination protected both upstream and downstream sides of the groin. And a straight groin with an inclination of 90 degrees is found to be optimal. So that's all about the conclusion. And these are the references that we use for our study. And thank you, and you may ask for any questions regarding this presentation.
Yes, thank you, Gayatri. Very well presented, and thank you for keeping the time. Any questions?
Any question from participants?
Participants, any questions?
You can unmute yourself and you can speak.
Sir, hello. Sir, good morning. This is Coach Dr. Meru Ruben.
Sir, I cannot hear you, sir.
Hello.
Yes, sir, you're audible.
Yes, sir.
Yeah, you are audible. You please ask.
Hello. May I know the difference between graions and gabions? What is the difference between these two?
So gabions are constructed along the bank side. It will be like a wall. So it creates a separation between the river side and the what to say land side.
Right.
But groins are the in-stream structures which are transversely constructed into the river flow.
Oh, yeah. So which do you prefer for this analysis generally?
Sir, I didn't hear you, sir.
Which do you prefer that which is good, whether the gabions analysis or bryons? Which
So
are
growing, sir,
advantageous?
because these kind of on-stream structures or direct methods, since it creates a difference or a separation between the river and the land side, it creates more problem for the ecology. So the organisms has very well habitat in these kind of in-stream structures.
Another thing is you only in mesh preparation 2-dimension only you are considered, yes or not?
Yes, sir. Yes, sir. 2-dimension.
Why you have not gone for 3-dimension, which gives real pictures?
Sir, we have used students' version and also.
Because the CFD means a 3-dimensional analysis. Okay, that anyhow your analysis is good. Thank you. Thank you.
Thank you, sir.
Yes. Anybody else?
Have you studied the turbulence analysis, like the turbulence intensity, turbulence kinetic energy, as you have mentioned in your objective turbulence pattern?
Gayatri, are you there? I think.
Anyway, yeah, we can move to next one, sir.
Yeah, we can move to the next one. The next paper ID is paper number 82 from Kartika Priyadarsani.
Hello.
Yeah, are you there?
Yes, sir, I'm here. Sorry, sir, I didn't. Okay, sir, I didn't notice it.
Gayatri,
Yes,
are
sir.
you still there? Okay. No,
Yes,
I had
sir.
just one question to ask you. Whether this work was your UG work or PG work?
Sir, I am a final year BTech student, sir, UG work.
You are a final year BTech student,
Yes, sir.
and you used this CFD and Fluent and all these kind of thing, and you have solved for the velocity. Do
Yes,
you
sir.
know which equations actually you solved using the software?
Sir, Navier-Stokes equation, and also it conserves mass, moment, and energy. Mainly, the CFD is based on Navier-Stokes equation.
Are you sure that these are Navier-Stokes equations? You are solving for the Groyan and the velocity. Are you sure that these are Navier-Stokes equations or anything else?
Sir, for CFD, it is Navier-Stokes equation, and ANSYS Fluent is working based on the CFD. And also we have this K epsilon model. So there also we have certain other equations too. And other iterations like Jacobi's method, Newton-Seidel method, all these things are actually, it is presetted in the software. But by studying the theory, we
That's what
understand
I'm
that
asking. That's what I'm asking. Basically, as an hydraulic engineer, we are supposed to know which equations we are solving, because
Yes, sir.
there are hundreds of techniques and tools and softwares available. We are supposed to know what is the equation, what is that basic differential equation or partial
Yes, sir.
differential equation which we are solving. Anyway,
Yes, sir.
nice presentation. Okay.
Thank you, sir.
Yeah. So next one is paper ID 82. Analyzing and redesigning existing water distribution network of AOI Nagar, Trivandrum, Kerala using EPANET. Kartika, paper ID 82.
Are you there?
Are you there?
I think paper ID 82 is not there, sir.
82 is not there. Okay, I think if they can, if they join afterwards, we can accommodate them at the end. Maybe. Let us go ahead. Yeah, paper ID 173, Dr. Ashok Matani. IoT and sensors applications in water resources utilization in smart cities management in Indian economy. Paper ID 173. I think he was there just few minutes back.
Okay.
But it seems.
This response.
173. Paper ID
173.
173. Dr. Ashok Matani. His video was also on, but now it seems he is off.
We can move to the next one.
Okay, next paper is of my student only. paper 135, application of data-driven techniques for correlating stage measurement stations in Upper Krishna sub-basin. Who is presenting, Vaibhavi or Mohini?
Sir, myself, Mohini. It's
Mohini is presenting. Okay,
Yes.
you have about 7 minutes for presentation, and then there would be question answers. Please go ahead.
Yes, sir. Hello everyone. Good morning. My name is Mohini Ruche. The topic of my presentation is application of data-driven techniques for correlating stage measurement station in Upper Krishna sub-basin. Dr. Srinivas Londe sir, Dr. Pradna Dikshit ma'am, Vaibhavi Solanki and myself Mohini Ruche are the fellow authors from Vishwakarma Institute of Information and Technology, Pune. The outline of presentation is like this. Firstly, we will see the introduction. Secondly, the literature review and technique used. Thirdly, study area, data and methodology used. And finally, the result and conclusion. Introduction. In the hydrology, stage refers to the water level in river or stream with respect to a chosen reference site. Stage is important hydraulic parameter we use to determine discharge in the design of hydraulic structures like bridges, weirs, etc. Correlating stage measurement station is important because it provides early flood warning information of hydraulic forecasting of model, and it will help us in flood protection works. The traditional manual stage measurement methods are staff gauge, wire gauge, and automatic stage measurement methods are float gauge recorder, bubble gauge recorder, etc. Need of study is necessary because if any natural or man-made disaster occur or due to some technical reasons we are not able to record the stage measurement value in the last few consecutive years, Upper Krishna sub-basin, Maharashtra is the most affected zone by floods. In such situation, correlating stage measurement stations and use of data-driven techniques will help us for early flood warning and for decision support system, because data-driven techniques not only provide solution within less time, but also it gives a reasonable results for real-time problems. The objective of present study is forecasting of water level of stage gauging stations, Bhilaudi and Mahisha, by correlating stage measurement station using data-driven techniques, M5 model tree, random forest, and multi-genetic genetic programming. Moving on towards the literature review. Topic to 1997 model hypothesis nature of staged discharge curve for stream section using an artificial neural network and genetic programming. Bhavik 2002 used data-driven techniques such as genetic programming to model runoff based on available hydrometeorological data. Peng 2004 investigate flood forecasting problem for upper reach of Hue River by using M5 model tree application. Bhattacharya 2004 used artificial neural network and M5 model tree for modeling water level discharge relationship. Bingley 2016 compared of random forest and statistical method for application of lake water level, where random forest exhibits the best performance. For hydraulic modeling, they use soft computing techniques. So it is proven that these data-driven techniques are helpful to solve real-time problems. For real-time stage forecasting problem, it is used in hydrology. As these paper are very related to the present study of water level and stage discharge relationship, it is decided in the present study to use data-driven techniques M5 model tree, random forest, and MGGP for the case-specific study of at Upper Krishna sub-basin. Technique used. M5 model tree is invented by KLU in 1992. Model tree is a data-driven technique based on two concepts, that is conventional decision tree and regression function. M5 model tree splits data input data spaces in x1 and x2 by model tree algorithm. Each model is a linear regression model. This is the equation. This is the equation where y is the dependent parameter, x1, x2 are independent parameters, a0, a1, a2 are their regression coefficients. This is the typical representation of model tree. Model tree approach to minimize the error at each node. Standard deviation reduction is computed by taking one node at a time. This is the equation of standard deviation reduction, where T is the set of examples that reach the node, Ti is the sets, St is the standard deviation. Next one is the random forest, invented by Bremian in 2001. The random forest employs the strategy of random selection of subsets of M predictors to grow a binary tree where each tree is grown on a bootstrap sample of a training set. Principle of randomization, which is used during the tree induction process, that randomly selects the k features at each node among which the best split is chosen, which is showing in this demonstration RF methodology. It runs efficiently on large databases and it can handle thousands of input variables without variable deletion. This is the advantage of random forest. Moving on, multi-genetic genetic programming. Genetic programming is developed by Koza in 1992. It belongs to the class of evolutionary algorithm, which is based on Darwin's principle of survival of the fittest. MGGP combines modeling capabilities of genetic programming, statistical regression method. Traditional GP represent is based on the evolution of single tree expression. In MGGP, each gene is a tree expression. This figure shows a typical program evolved by MGGP, where A, B, C are inputs and into, minus, plus, log and root are the functions used for evolution process. Here is the equation of model where alpha 0, alpha 1, alpha 2 are the coefficient. GPTips is the freely available open source multi-genetic genetic programming platform written in MATLAB for data mining and model discovery. Moving on, study area and data. In the present study is carried out at Upper Krishna sub-basin of Sangli district, Maharashtra, India. Considering the nature of flow from upstream to downstream, stations are selected for this study. Bahe, Takari, Bhilaudi are shown in the yellow shown by yellow arrow, and Arvind, Ankali, Varna, and Mahsha shown by orange arrow. The yellow arrow station shows the part of first study, and orange arrow shows the station selected for part of second study. The data collected from Sangli irrigation division, Maharashtra. Their daily stage measurement data in meter from 1st June to 31st October of years 2005 to 2019 is used. Here is the data statistical analysis of each station data. The maximum, minimum, and standard deviation values are shown in this table.
Better you show your results now. You have already got a lot of time.
Yes. These are methodology for part 1 and part 2. The total 14 models are developed here. The result of
you can just show the previous slide where your models are shown and then show these results. Don't waste much time. That is what I mean.
Yes, sir. For part 1, total 5 models are developed, and for part 2, total 9 models are developed for estimation and prediction of Bhilaudi and Mahsha stage measurement stations. The result of part 1, model 2 is given best estimation for Bhilaudi, which having input parameter as Bahe. For model 4 and model 5, which is having observed Bahe Takari and yesterday's Bahe Takari stage measurement values, are giving best prediction of Bhilaudi station 1 day ahead and 2 day ahead. This is the result of part 2. which is showing model 1 which is giving best estimation result for Ankali and stage management station, and model 8 and 9 shows the best prediction for of 1 day ahead and 2 day ahead of Mahasha stage measurement value. This is the scatter plot of respective models of part 1, model 2 and model 4. Scatter plot showing observed and predicted values of Bhilodi, and this hydrograph shows the all soft tools combined hydrograph, which is showing actual versus predicted stage values of model 2 of part 1, and this is showing this hydrograph shows actual versus predicted stage values using all soft tools of model 4 of part 1. This is the scatter plot of model 8 and 9 of part 2, which is showing actual and observed and predicted values of Ankali stage measurement stations, and this hydrograph shows the model 8 and 9 actual versus predicted stage values using all soft tools. This is the typical model tree representation of model 4 and of part 1 and model 1 of part 2. Conclusion. In present study, total 14 models were developed for estimation and as well as for prediction of stages at Bhilodi of part 1 and Ankali and Mahasha for part 2. Part 2 study. In part 1, the value of correlation coefficient of Bhilodi stations of model 2, model 4 and model 5 are 0.93, 0.93 and 0.90 respectively, as they were very close to 1. In part 2, the value of correlation coefficient of estimation of Ankali of model 1 and prediction of Mahasha of 1 day ahead and 2 day ahead are 0.97, 0.94 and 0.89 respectively, as they are very close to 1. From all the result of 14 models, it has been observed that R ranges from 0.77 and above, RMSE ranges from 0.884 to 2.0663, MAE ranges from 0.664 to 1.505. The performance of all models of M5 model tree, MGGP and random forest are reasonably good. M5 model tree gives better result than random forest. The result indicates that multigenic genetic programming performance is superior than model tree and random forest. Future scope, this can be alternative method at 11th hour for flood forecasting and for decision support system. So we can use this method in aligned field. These are some references. Thank you.
Yes. Any questions from the audience? From the participant? Yeah.
Hello. Hello.
Hello. Yes.
Yes, sir.
Hello. 23 ready. Start. Paper ID 173.
Yes, sir. Just let
Yes,
us finish first, and then I would come to you.
Okay.
Some question
Please tell me.
answers are remaining. Yeah.
Okay.
Uh,
I am ready.
any questions for this paper? No. Mohini, I have one simple query.
Yes, sir.
You have presented a lot the random forest and MGGP and all those kind of thing. But for the benefit of the audience, can you tell in one line, what exactly?
I done the work for flood protection works at Sangli district of Maharashtra. This using this technique, we can.
I told you one line, only one line. What have you done?
Okay, using these soft computing tools, I tried to try to estimate predicted value of stage measurement stations Sangli district Maharashtra, so I can give pre-flood warning information using this,
Thank
and it will help us in flood protection work.
Thank you.
Thank you, sir.
Okay. Yes. Now I think paper 173 is now there.
Yes,
Yeah. So Dr. Matani is there, 173. I think it is all yours. You can start directly.
Okay, because of some network problem, probably you will not be finding PPT there, but from my side, I am reading that.
Yeah, but you are not
Okay, proceed,
audible
sir.
also sometimes.
Now it is okay.
Yeah, we
Yes,
can
okay.
hear you, but there is no PPT. We can only hear you sometimes, but that is also
Can-
cracking in between.
No, since I am presenting from mobile, and so it is difficult, otherwise it will be hang. Hence, PPT is in laptop, and that is the network issue here. Hence, I will read that. If you are audible, then I can proceed.
Okay,
Or should
Umesh,
I
what should we do?
Yeah, you can. Yes,
WhatsApp,
sir.
should I
You can,
send that
sir.
PPT so you can present or continue from that, and I will read here.
If
Umesh,
later on
what to do?
PPT is, sir, if PPT is later on available, then you can come later on for Dr.
Yeah, I think
Ashok,
that
sir.
would be better.
Should I send this PPT or should I read?
You can say send, it's better. You can present from here also. And you
I
can,
think what he said is you can send the PPTs and then afterwards you can present,
Okay, sir.
right? So that
yeah, right,
in
sir.
between we can ask others to present, and then when he is ready with your PPTs, then you can present. Is it right, Umesh?
Right, sir. Right, sir.
Yeah.
After this next presentation, I will be there. Okay.
Yeah, you
Okay,
just
sir.
please send him, and then let him. Then he will decide. Okay. Till that time, let us go ahead.
Okay.
Yeah. Now paper number 199. Noorjahan Patel and I think Dr. Tube, COEP. Okay, fine. Rainfall runoff modeling of Pauna Basin.
Yes,
Is
sir.
the author there? Yeah.
I'm giving the presenter status. And
Who is
share your
there?
slides.
Noorjahan Patel?
Continue. Yeah.
Yes, sir, I'm here.
Okay.
Please share your
I'm
slides.
sharing my
Yeah.
PPT.
Yeah. You can start.
Is it visible, sir?
Just
Yes, it is
wait.
visible.
Not now. Yeah, it is visible. You can present now.
Okay. My topic is rainfall runoff modeling of Pauna Basin using HMS model. Introduction. The movement and storage of water at watershed scales is a complex process primarily affected by climatic, topographic, soil, vegetative, geological, and land use factors. Detailed spatial and temporal information is therefore needed to address and solve water resources problems such as water availability, water supply management, operation of reservoirs, and development of water storage capacity. The complex nature of the process is inherent in surface and subsurface hydrology is best investigated by computer models that simulate this process over short and long time intervals. Here's the brief description of the HMS model. This model is a physically based distributed model designed to simulate and the rainfall runoff process of dendritic watershed systems. The model was developed by US Army Corps of Engineers. It has been widely applied for humid, tropical, subtropical, and arid watersheds to simulate and forecast stream flow.
Hello, excuse me, please press F5 so that the PPT will be enlarged. Press F5.
Okay.
It is not in enlarging. Okay, thank you.
Is it okay, sir, now?
Okay, it's okay.
Okay. The aim of my study is to develop rainfall runoff model using HMS for Pauna Basin. The objectives of my study are to develop rainfall runoff model for Pauna Basin, to calibrate and validate the hydrological model, to simulate rainfall runoff modeling, to evaluate the performance of hydrological model. Problem and theories. There's a lot of lack of hydrological data. The conventional methods of surface runoff estimations are costly, time-consuming, and inaccurate. The estimated surface runoff can be used to plan, manage, and monitor water resources projects. I have performed this study on Pauna Basin, Mawal Taluka, Pune district, Maharashtra, India. The area of study is 114 kilometers square.
methodology. I have worked on DM, which is downloaded from one website. I first created the basin model. In that, I have performed functions like trend processing and basin pre-processing. I have developed hydrological parameters. In that, I have selected the HKMS processes and developed HKMS model files. After that, I have performed the hydrological modeling. In that, I have defined the meteorological parameters. I have defined control specifications for simulation. Then have done calibration, validation, and finally got the results. The results and the result for my calibration is here in this graph. In this graph, the blue line represent the simulated surface runoff, and the black line shows the observed runoff. Here we can see that mostly the peaks are matching with simulated runoff with observed runoff. And the Nash Sutcliffe efficiency for calibration period it was 0.63, and the percent bias it was 7.9%. For the validation period, the Nash Sutcliffe efficiency was found to be 0.64%, and the percent bias was 10.31%. And again in validation period, I have used data of 9 years, out of which 7 years was used for calibration and 2 years was used for validation. I have performed the validation on unused data, and here again we can see that the observed runoff and simulated runoff are matching satisfactorily. The simulated peak discharge in 2017 is 213 meter cube per second, and the observed peak is 222.2 meter cube per second. The percent difference in observed and simulated peak discharge is 4.1%. For the same year, observed volume is 355.46 MCM, and the simulated volume is 383.55 MCM. The percent difference in simulated and observed volume is 7.9%. And the validation phase in 2013, the simulated peak discharge is 241.2 meter cube per second, and the observed peak is 250.7 meter cube per second. The percent difference in observed and simulated discharge is 3.7%, and the time of simulated and observed peak discharge is same, that is 17 June 2013, which shows that the model performed quite good. For the same year, observed volume is 395.19 MCM, and the simulated volume is 435.97 MCM. The percent difference in simulated and observed volume is 10.3%. The conclusion of my studies, after the optimization for calibration, Nash Sutcliffe efficiency is found to be 0.64%, and for validation, Nash Sutcliffe efficiency came out to be 0.58, and the percent bias for calibration is 7.9%, and for validation it is 10.31%. This study ended up with optimistic results for the simulation of rainfall runoff process, and hence the HKMS model may be used to simulate rainfall runoff process in Pauna Basin. The SCS unit hydrograph method available in HKMS model to transform excess precipitation into the direct runoff is suitable to model the Pauna Basin. The routing lag model was found to be suitable for routing the reach of the Pauna River. The SCS curve number method used for estimation in HKMS model was also successfully applied to Pauna Basin. Here are my references. Thank you.
Thank you for time-bound presentation. Any questions? Any questions from the audience, from the participants?
Yes, there is one
Nurja,
question.
I have a question.
Yes, sir.
Is this your MTech work or undergraduate work?
Sir, MTech work.
MTech work, okay. So you have used Hake HMS. Can you tell me what are the basic equations which are solved using Hake HMS?
Sir, I have used SCS CN method for loss method and SCS unit hydrograph method for.
I am asking you what are the basic equations which are solved using Hake HMS? Because you have used the software, in which you have used so many other, that is, you have used GI, DEM, and then you have used maybe land use, land cover, and discretization of the domain, and then you got the answers, in which you have also used something for evaporation, infiltration, and likewise. The main question is, you have done rainfall runoff modeling.
Yes, sir.
So which equations are solved in Hake HMS? What are the basic governing equations of Hake HMS? Okay. Yeah. Later you should study this because you are using some tools which are based upon solving some equations. So it is advisable that you first study basic hydraulics behind this, and then we are basically hydraulic engineers. We are using the tools. That is our tool. That is not our destination. Our destination is hydraulics. Okay, so first we should know the equations which we are supposed to solve. And to facilitate solution of these equations, there are finite element method, finite difference method. These days, data-driven techniques are there. So there are various techniques which are solving the basic equations. The question is which equations we are solving, right? So that we should understand. Like Hecras solves Saint-Venant's equation. Now there is Saint-Venant equation for unsteady flow. Similarly, for your Hake HMS, which is the governing equation which the software is solving, that first you should understand, read from the manual of the software, read from the standard books, talk to your guide, so that then you would understand it fully. This is my advice to you. Thank you.
Okay, thank you, sir.
Yeah. Now I request Dr. Ruben to please take over.
Yes, sir.
Further
Thank you,
session.
sir. Thank you, sir,
Yeah,
for
I
giving
would
that.
be
Sir,
there. I would be there till the
sir.
end for
Okay.
concluding. Yeah.
Sir, I have one more question to say. Hello.
Yeah. Yes.
Sir.
Sure. You can ask.
So initially in the presentation you told that surface runoff estimates are costly. What is this costly according to your point? You are
Sorry,
told
sir, you are not audible to me.
hello? Hello, in the
Sir,
initial, hello, is my voice audible?
No, sir, you are not.
No, you have given one sentence, surface runoff estimates are costly. Can you defend that?
Sorry, sir, I'm not getting the question.
Hello, you quoted initially during the start of presentation that surface runoff estimates are costly. Hello? So what do you mean by that?
Sorry, sir, I'm not getting the question, sir.
Yeah, Nurja, can you hear me?
Yes, sir, I can hear you.
Yeah, what he is saying that in your presentation you said that surface runoff predictions are costly. What do you mean by that? That is what he is asking.
Sir, it was conventional methods are costly. Like we have to go and perform over and perform the surveys if we are following the conventional methods, and if we are following this software based rainfall runoff modeling, then it is not costly, sir. And if we have to go over there, then we need the instruments, we need forces, man forces, and we need so many things to go over there and perform the surveys and get the data and collect the data from there.
Okay. Thank you.
That's
Thank
okay.
you.
Okay. Dr. Ruben, please continue. I am there only. Yeah.
Yes, sir. Thank you, sir. Thank you.
Sure. Okay.
Now, okay. Now the next presenter is 200. Paper ID is 200. Sir, am I correct? Sir, am I correct? Paper code is 200.
Paper ID 173 is ready as it's written in the chat box. He is ready with the PPT. So It's better to move for 73 right now.
Okay, sir. Now I will invite. So, 173, Dr. Ashok Matani, Dr. The title of the paper is IoT and Sensors Application and Water Circulation Smart Cities Management Industry. So, I request the presenters to present. Thank you. Over to the presenters.
Presenter status is given. So, sir, you can kindly share your PPT.
Hello.
Yes, sir.
Hello.
Yes,
Voice is
yes.
breaking.
Your voice is audible. Present, please share your PPT.
Dr. Matani, sir, is there any issue? Dr. Matani, sir, can you hear me? Sir is not responding.
What shall we do?
Sir, we can go for the next one. It's better.
Okay, sir. You only please invite, sir. I'm authorized. Who is the next? Who is ready?
Next is paper ID 200.
200. Okay.
Let me see 200 paper IDs there. I request all the participants, please rename your with the paper ID. It is easy to recognize you.
Yes, sir, I'm there.
Right. Paper ID 200. Huh?
Yes, sir.
Please present.
Yes, I'm
Share your
sharing.
PPT. Yeah.
Yes. Is it visible, sir?
Yes, it's loading.
Yes,
Yeah,
yes.
now it is visible.
Okay. So good. The topic for the presentation is reliability analysis of existing water distribution system of Sai Enclave in Pune, under the guidance of Dr. N.M. Mohte, Assistant Professor, College of Engineering, Pune.
Okay.
As we know, what aspect of our life. Generally, it is expected that the clean water with the right quantity will be available by turning, but it is not that much easy. It takes a lot of technology and science advances for that. In certain developed countries, this may be true, but developing countries in India, the majority of population clean water that time. So it is necessary to construct a suitable water supply scheme using the advances that we have achieved in the technology. So in this particular study, we have to simulate the water distribution system. So the focus for the study is whether to see the whether existing distribution system is we can rely on it for future or not. So we can plan for the future.
Voice is a little bit
So the
low.
problem is, as we know, there is a population boost in last some decades in India. So due to this increased population, the demand of water is also improved. So the existing distribution systems are not giving the satisfying results, or not giving the that require water output. So to check the reliability, in theory part, I considered the head reliability and demand reliability, that is the reliability of discharge. Then the head reliability I have calculated like, first it was divided into 5 slabs. If the head is about 20 meter, then head between 15 to 20 meter, then 10 to 15 meter, and 5 to 10 meter, and below 5 meter. So the number of the head reliability was calculated like this formula. The number of heads above 20 meter, then number of heads above 15 meter into respective head, the summation of all, and divided by total number of nodes into the 20 meter. Also the reliability of water demand, that is the reliability, the water rate of water to the water required for 1%. So this is the sample calculation I have shown. The minimum nodal demand was considered 0.1 second. From that, what is the quantity of water available for 1%? So it 65. So the demand reliability was 65.6. It is considered as LPC 38.2. And when
Voice is breaking.
So it was shown all the nodes are about 20 meter, so 100%. The study area I was selected was the saline area. These are the salient features of this study area. Then it was initially divided into 4 zones. The present situation there is the water is 3 hours in the morning and 3 hours in the night. And in falls there are 3 pumps, but presently there are usually 2 pumps. They stand by. So this was the network was imported into the EPANET. Then the map of the like, and when the network system was adjusted, the backdrop was unloaded. Then this was shown like a large format. The head is about 20 meter, it will give a blue color. If it is between 15 20 meter, it will show sky blue color, and likewise. So these are the results when I make a interface of 50 meters of water per plot, and according to that, these were the results I got. From that we can see that we can provide the water up to 156.25 liters per person per day only, whereas our demand is 172 LPCD. So if we go above that, at certain points we are getting negative pressure. So, and these are and last column, these are the zones affected. And in RH and RQ column, we can see that how the head reliability is decreasing if whenever the with the increase in nodal demand, and how the demand reliability is increasing. And same analysis I was done using the all three pumps working or running. It was a very small improvement was shown. Initially, water supply system was able to pumps are in, I have compared the RH and RQ variation for 2 pumps and 3 pumps running. Very small farthest node. On farthest node also a little improvement is showing when all 3 pumps are running. Now the also population was forecasted, and what would be the nodal demand in future was determined. So we can see that the nodal demand was in the next 4 decades is increased up to 1.73 liters per second. So to find out the problem, I first checked the about the pipe diameters. For that, the node at pump head pump house itself, and the first node after the pump was checked and compared. It was shown that the head at 2 points were different. So it shows that the diameter was not sufficient. But to suggest the changing the pipe in existing water distribution system is a little uneconomical, and also not a good solution. So it was decided to decrease the nodal demand. To decrease the nodal demand, it is necessary to increase the pumping hours. So this is the comparison. The pump when pumping hours was 6 hours, then 8 hours, 10 hours, and 24 hours. So in this we can see that the nodal demand is decreasing. If the nodal demand decreases, we know that the reliability, both the head and discharge reliability, are going to improve. So from this, I have particularly taken the continuous supply, that is 24-hour supply, and I have checked what will be the corresponding reliability. So I have seen that the when 24-hour supply is there, the 100% reliability we will get up to 2031, and up to 2041, 90 above 90%, and 51 above 70% reliability we can get. So from that, we concluded that when two pumps were running, the water that can be provided to per person per day was 156.25 liters only. When all three pumps were running, it was improved up to 160.25 LPCD only. But then when we forecast the population and got the present situation, that is in 2021, the demand was 0.68 liter per second. So the in zone 1 and zone 2, people were getting a good head, but in zone 3 and zone 4, people were striving for the water. So if this same particular system is extended in the future, it won't have ability to
Now, please, I
give.
request you, please conclude.
Yes,
Time is over.
yes,
Conclude. Now,
yes,
go to final.
yes. These are the references, and thank you. Hello.
Please. There are conclusions. Over, huh?
Yes, sir.
Hello? Over, okay. Okay.
I come to thank you slides.
So, thank you for the presentation. Now it is open for discussion from participants, from experts. Please, any queries? Please ask. Thank you. Anyone?
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 Participants or does anyone?
If no one is there, I have one question. Hello, Mr.
Hello. Yes, sir. Yes, sir.
Okay. Very good that you have used like earlier one tool we have used. Yes. What
Yes.
is that tool name?
EPANET supplies.
EPANET. Okay, good. Like how earlier our chairs are asked. So what was the basis of that tool? Which method the tool has followed? Okay, you have used the tool. Okay.
Yes, sir.
EPANET invented by US Army. What is the method?
So basically, the equations that were used were
Equation. That is what equation. Method means equation finally.
yes, sir. We can use their Darcy-Weisbach equations, Hazen-Williams equation, also for velocity, Manning's or Chase's formula.
No. You are telling that okay, Darcy-Weisbach equation.
Yes, sir.
By that we can get different parameters, fraction like that. Okay, even Manning's everything. No. I'm
Yes.
expecting one good answer from you. Okay. Have you heard this Hardy-Cross method?
Yes, sir. Hardy-Cross method.
Yes. That is the
That is
basis.
summation of
okay. I told the method. Notes. How many notes you have taken? Maybe I think 4
total.
notes. Many notes have come.
Yes.
One simple. As per that method, each node has to satisfy one important condition. What is that condition? We tell, we will finish the section. Each node it has to satisfy one equation. What is that equation? Many nodes, yes, compulsory it should satisfy. As per that equations, these values have come. Okay. Okay, thank you. This is my just. Please, like how Professor told, please dig, not only just giving input, getting output. What is happening? What is happening? As this many assumptions are there in IPANET. But in IPANET, we cannot use in real field. Many assumptions are there. They are using different types of parameters. Okay?
Yes,
Hello?
sir. Yes, sir. Actually.
There are some advanced which please go through the basics. Thank you.
Okay, sir. Okay, thank you.
Yeah. Next, sir, we can go for paper ID 205.
Sir, next sir, who is ready, sir?
Yeah, 205. I have given the presenter status to 205 paper ID.
Yes, sir.
Yeah, please present your slides.
Two not five. Sir, is it 205, sir?
Yes, yes, right, sir.
Yes,
Sir,
yes,
once again, 10 minutes, sir. Once again, I was not there initially. 10 minutes only, no, sir?
Yes, yes, yes.
2 minutes for discussion. Okay, thank you. Start.
Sir, is it visible, sir?
Please, sir, carry it. Visible, carry.
Going on, my name is Gujalar Abhishek, and here I am presenting a presentation work on analysis and redesign of 24/7 water distribution network using WaterGem software. Here is the introduction. Contained water supply systems has been generated significant interest in India due to its many advantages. Also, it is useful for the conserving water and its quality. As we know, nowadays the demand for drinking water is increasing day by day due to corresponding increase in population. This continuously increased demand can be fulfilled by the designing efficient water distribution networks based on advanced computing tools systems such as various softwares, IPANET, WaterGems. In order to deliver adequate service, the system must be carefully planned, designed, operated, and maintained. Need of the study, water distribution network is crucial parts of city's infrastructure that conveys treated water from the treatment plant at the consumer end. With the help of hydraulic modeling, the process variation in the pipe network can be monitored. It helps to check the adequacy of pipe network, that is diameter and the number of valves and its operation. Here is the aim, analyze and redesign of 24/7 water distribution network for steady state conditions, and the objectives are to skeletize the hydraulic model for the study area, to identify the location of critical points in existing water distribution network, to modify the existing network into continuous system. Here is methodology adopted: selection of the study area, collection of data, data analysis, validation of network using WaterGems, assigning the distribution network parameters and results. Here is the study area. Study area is the Pimpri Chichwad, which is located in the northwestern city limits of Pune, and there is a 4th distribution network. Here is the current status of existing distribution system, that is, as you can see, every factor lags from the standard benchmark which is set by the CPHE manual. And problem of the existing water supply is uneven terrain, high non-revenue water, contamination due to intermittent supply hours, large number of hours, and huge coping costs. Okay, here is the solution for this problem, that is roadmap for the continuous system. For shifting to intermediate to the continuous, we have to consider the 5 aspects: that technical aspect, organization, commercial, policy, and budgeting. Okay, here is the existing water supply of the study area. The whole city is divided into 4 administrative zones, and further that into the number of water districts of the city. Okay, the basic principles are adopted. Fundamental concept is saving the normal water by plunging of the leakage in deep division pipe system. Also, the saved water will be used to the boost supply for the 24 hours. Model scenario represents sets of models that describe characteristics of hydraulic models and different work. A typical model scenario requires analysis of number of alternatives and analysis of each alternative's data. Okay, we can prepare n number of models for the various inputs data. Hence, to solve this problem, alternative sets are kept with single model data file. Okay, alternatives are adopted. First is active topology, distant drawing of just about all water networks showing the places tank in intermediate nodes as well as pipe positioning of Pimpri City is taken through the IPANET file which is prepared already by the municipal corporation, and the demand for the all junction of design period is allocated by considering projection factor which is mentioned in development plan by Pimpri-Chinchwad city. Okay, here is the demand allocation. The demand for the all water district is allowed by considering the 2011 population and multiplying the projection factor which is mentioned in development plan. So the demand is allowed to the all water districts, and here are the results of discussion. Inadequacy of network. The primary network is checked for the demand of 2051 and inflow of 23 hours and outflow 24 hours. The distribution network is checked for this demand, and it is seen that velocity of distribution means is exceeding 1.8 meter per second, which is guided by the CPHE manual, and pressure in some pipes which is 0 and negative. Here the 4 junction is taken, that is junction 226, 264 and 311 and some sector, and the pipe between is exceeding the velocity, that is 1.8 meter per second square, and the pressure is below the 7 meter, which is guided by the CPHE manual. And here is the pipe abstract, that is exceeding the velocity and the pressure. Total the 93 kilometer pipes need to be replaced. Modification: pipes within the critical junction are need to be replaced by new one, making steady state condition, and new pressure valve has to be added to maintain the pressures. Here are the pressure valves to be suggested in the 105 network system, and after the adding this pressure valve, we can see the velocity that is decreasing by the 1.8 meter per second square, and the pressure is increasing by 7 meter. That is fulfillment of the guidelines. Here are the conclusion. By using strong hydraulic model and optimal water distribution network design, and can also help the obtaining goal of minimizing general cost while fulfilling the water need specification during satisfactory pressure. The initial pipeline is not sufficient to fulfill the demand throughout the design period, as 10 pipes between 182 junctions exceeding the velocity and the pressure restriction. By this study of remodeling the current water distribution network, switching 24/7 water supply, demonstrate results that are required to fulfill the desired boundaries of the hydraulic and also water qualities as per CPHE manual. These are my references. Thank you. Hello, sir.
Yeah, thank you.
Okay. Thank you for the presentation. Now it is open
Yes.
for discussions. Any queries from participants? Please ask quickly. So you completed the presentation within time.
Yes.
So if at all, from myself as in charge of co-chair, I have some queries. Hello?
Yes,
Is my voice
Yes, sir.
audible?
Yes, sir.
Audible, sir.
Right. Now, really, I'm very sorry to say that, okay, you have done a very good, but the presentation values, it is not visible to us even to study what is going on. The tables, everything is clumsy. Please, the next maybe, see, that is actually work where we could not able to see the table, what is going on inside. Okay, we have used some water gems and everything. So pressure variation, I'm more interested. Okay, because I could not able to see pressure variation. You are telling extreme in every aspect. Okay, so
Yes, sir.
in general pressure variation, okay, if at all, if it is negative,
Yes,
maybe
sir.
some nodes there are some negative pressure variation. You told,
Yes, sir.
maybe it gone below 0. What is going to happen? It's gone below negative. What is going to happen at that moment?
Sorry, sir.
What
I
is
didn't
going
get your question.
so some pressure variation, some place you are telling extreme. There are
Yes, sir.
more high pressures in some places and very negative pressures in some places. So,
Yes, sir.
okay. Understood. Negative pressures if occurs in pipe. What is the negative effects?
Okay, sir. The negative pressure will burst the pipes.
Okay.
Yes, sir.
Now, okay, have you found those type of points in your total system, and what are the precautions have you taken to avoid that bursting?
Okay, sir. For that, sir, we have replaced the pipe. That is, by increasing the diameter pipe, the pressure is
Okay.
liable within the range.
Will increasing the diameter really avoids this negative pressures? Is it correct?
Sir, by considering the whole system, that if some pipe is replaced, then the pressure will be within the permissible range.
No. Have you worked out that thing? So have you increased the dia? And
Yes,
have
sir.
you checked yes in that places the negative pressure is maybe negative pressure gone from negative to positive. Have you found out those things?
Yes, sir. Yes, sir.
So initial dia how much? Okay, initial dia how much generally in the pipe system you have chosen?
Okay,
How
sir.
much dia of the pipe you have chosen?
There is a n number of diameter pipes, sir. For the
Okay.
high density polyethylene pipes, the minimum dia is 110 millimeter.
What is that? 110 millimeter. That is 10 centimeters hardly.
Yes,
So now you have increased the dia. Understand? From 11 centimeters to how many centimeters you have increased?
Sir, 160.
160
to
mm.
160. Yes, sir.
So found that everything is safe.
Yes, sir.
See, even laying a pipeline is very difficult. Changing is more difficult. Understand? You need to start. So there are some more pressure reducing valves are there. Have you tested those valves? Pressure reducing valves.
Sorry, sir, your voice is breaking, sir.
Pressure reducing valves are there.
Yes, sir.
Why can't instead of changing the dia, why can't you use this type of which takes negative like air valves, we call air valves. Do you know air valves? Have you done that type of analysis? Installing air valves where the pressure gone. That is what analysis is required instead of total changing pipe. Very difficult. Okay, you please.
Yes, sir. Yes, sir.
That is the air valves
Yes, sir.
are there. If at all this is big transmission
sir.
means there are some big air vessels we generally use to avoid this thing. Instead of always keep on changing. This is all. Please take care and thank you. Good presentation. Please keep on working. So, sir, from my side, it is okay, sir. Please carry on.
Okay. Yes,
Thank you, sir. Thank you for the presentation. So now we can move to the next paper. So next paper ID is 206 from Suraj Chaudhary.
Yes, sir. It's 206.
Yeah. Given into the presenter status, kindly share your PPT.
Share the slide.
Yes, it is loading. Voice is breaking.
Sir, may I know the paper ID, sir? What is paper ID?
Paper ID 20206, sir.
Okay. Thank you. Please, Suraj, carry on.
Voice is breaking. Still, I'm not able to see the slides.
Yes, there's some disturbance. Yes. Mr. Suraj, your voice is breaking. Maybe you check it.
College of Engineering, Pune. My topic for the presentation is
Hello. Your PPT is not shared correctly. Please once check. Share your content first. Mr. Suraj.
So is it visible now?
Now it's
Okay.
yes, sir, it is visible. Please carry on. Thank you.
Okay, like this, I will carry on. So the textile industry involves a long chain of complex activities, which leads to water pollution.
One more request. Please press. Hello, excuse me. Please press F5. Enlarge the PPT. F5. Press F5.
Okay, sir.
Enlarge the PPT.
So I have enlarged it now. Is it visible?
Yes, please carry on. Start from the title.
Okay.
Start from title. Start from the title.
Okay, sir. So my name is Suraj Chaudhary. I am a MTech student from COB from College of Engineering, Pune. My topic for the presentation is removal of color from textile industry wastewater using hybrid reactor. The textile industry involves 38% of water which is used in the bleaching process, 16% of water is used in dyeing process, 8% of water is used in printing process, 14% of water is used in boiler, and 24% of water is used for other purposes. This textile industry involves a long chain of complex activities which leads to water pollution. So the aerobic biological process is incapable of treating the wastewater. So there is a need of anaerobic and aerobic reaction phases. My aim is to remove the color from textile industry wastewater using hybrid aerobic anaerobic reactor. The objective of the study is to study the existing available treatment processes and to find the effective depth and contact period for the filter bed. The material used for the filter bed is sugarcane bagasse and coconut husk media. The sample is collected from the textile industry from Solapur district. This sample was allowed to pass through different depths of filter bed ranging from 10 mm to 40 mm each. And later, the time period for the sample to pass through the beds was noted down. The color change in the sample was also noted down. Here in the first figure, you can see the powder of sugarcane bagasse, and in second figure, you can see the powder of coconut husk. Here is a typical filter bed. The contact period of sugarcane bagasse was 70 minutes. The contact period for coconut husk was 84 minutes. The effective contact depth was 30 mm for sugarcane bagasse, and the effective contact depth for coconut husk was 35 mm. The temperature was kept constant, that is 27 degrees Celsius. The removal efficiency was 40 to 45% of sugarcane bagasse and coconut husk media as a filter media. Also, we can use the sawdust to increase the efficiency of the treatment. Here are my references. Thank you, sir.
Okay, thank you, sir. Now it is open for discussion. Any queries? Any queries from the participants?
If any query, please unmute yourself. If anyone is having any query.
Okay. So I have one query. Hello? Hello, is my voice audible?
Yes, sir.
sir, audible.
Right. So, okay,
Yes,
somebody,
sir.
somebody, please, anyone, please. Okay. So, I think, so we have taken sample from textile industry, yes? Hello?
Yes, sir.
From textile, yeah, okay.
Yes, sir.
So what you have done after that? After taking the sample?
After taking the sample, I have passed through it through the filter
No.
which consists of.
Okay, that is also. So generally, whenever if you take the raw sample, there are some properties first we need to test. What have you tested those properties, like what is the pH and what are the important properties of wastewater? Can you define some of the important properties of wastewater parameters?
Yes, sir.
What are
Properties like pH,
okay.
pH, the COD. So we have not calculated the BOD because it is a textile industry wastewater, so chemicals are present in it.
Okay. So COD, how much you got it?
It's it's around 350 mg per liter of CaCO3, sir.
So okay, so that is initial before the treatment start. That is initial parameters. Now, have you checked after this thing, after using some spectrometer? Have you checked whether they are in as per the standards of as per the standards of American Water Works Association? Like that? Have they been standards? That COD
Yes, sir.
has come down like
COD,
that.
yes, sir. COD was decreased to 220 mg per liter, and the
220.
color change was observed to be 30 to 40% decrease in color, sir.
So now, okay. And so you are telling that all are in standard. So can I use it for a minimum gardening? A minimum gardening, because that is wastewater. Can we use it for a minimum gardening if provided many other, or is there further treatment is required?
Yes, sir. We can. So further treatment is necessary, sir.
Necessary. Okay.
Yes.
So what is
So
the
using
pH
like
value?
sawdust, etc.
See, that is what we must aim, or we must now presently Modi also 2020 to 2022 he put it all please come with good ideas to convert the wastewater into usable water. A minimum here in India, minimum gardening. You have to aim not only remove color. What is the purpose? Removing color, removing all this minimum. See, agriculture in Israel, they are the first people they are using for agriculture. So India, who is blessed with many water resource rivers, yet we are facing shortage. So not only removing color, keep it. You make a aim to convert that type of wastewater. How much we don't know. How much? What is the discharge? You are not mentioned how much discharge. Actually, that is basic parameter. How much discharge from that? What is that? From the textile industry. How much have you quantified the discharge? How much it is coming? No?
Discharge.
Hello?
We have.
Yes,
sir.
maybe you have taken only by
We have
sample.
not collected the discharge, but we have only collected the raw water sample.
Raw water sample, okay, like laboratory you have done, but engineer's work I am expecting you to do for the betterment. Thank you.
Yes, sir. Thank you.
Thank you for the presentation. You have to include before the going for the test and after the test, what is the characteristics of that wastewater and how much your result is efficient with compared to the other methods.
Your voice is not audible, sir. Sir, your voice is not audible, sir.
Yeah. Okay. Thank you. Now audible, sir.
Okay, sir.
So please include and consider them. Yeah. Thank you.
Thank you, sir.
So, we are moving to the next paper ID 207.
Yes, sir. I am there, sir.
Yeah. Yashwant. So I'm giving you the presenter status. Now you can share your slides.
Yes, sir. Is it visible, sir?
Yes, it is visible. Yes.
Good afternoon, everyone. My name is Gite. I'm presenting on hydraulic modeling of water supply network using by pressure device and guided by Dr. N.M. Mohde, Assistant Professor, College of Engineering, Pune.
Please carry on.
Actually,
You are not audible. Yes, Shivan.
is it visible, sir?
Yeah. Yes, please continue. Yes, yes. Please continue, Yashwant. Yashwant, you are not audible. Are you there? Is there any issue? I think. If there is any issue, you can proceed to the next one also.
Next one, sir, please.
Next one. The next one is paper ID 211.
211.
Moini. Are you there?
Two double one. Please
Yeah.
respond. Please respond.
Respond. So no response is coming from 211.
Okay, sir. Next will
We
go,
are
sir.
moving to next one, 233. Professor Ashram, sir.
KLU ICACE.
Yes, I'm here. 233, no?
Yes, sir. Please,
Sir, yes,
Yeah.
sir. I'm giving the presenter status, sir.
Yeah.
Yeah, you can select, you can share your slides, sir.
I'll share my. Yeah, इसमें Screen is visible now?
Yes, sir.
Yes,
Please
sir.
continue.
Yes, sir.
Yeah.
Please
So, yeah. So good afternoon, everyone. So this is a part of ongoing research work. So it's related to a research project, and especially the focus is on about characterizing the impact of saline ingression in a part of coastal district in Kasaragod, Kerala State, India. And here we have the focus is in this presentation mainly about the implications of land use land cover mapping, which covers a study area. So here we have done image analysis using sentinel data, and we try to link with the changes which has been taken place. And this area, the main problem in this area is especially in pre-monsoon season, and there are a lot of saline inflow, especially in a very low-lying river, and that is one of the major rivers called as Chandagiri River in Kasaragod district, and a lot of water quality issues are there. And here, but if you see in various angle with a various perspective, the impact of land use has got some role to play. And here we are trying to link with the land use and cover change with respect to the water quality. And you can see this is India and this is Kerala state, and this basin comes in northernmost district of Kerala, Kasaragod, and this is a study area. And here you can see that this is highly matured in the lower reaches, and we have taken only lower portions of lower basins of this river Chandragiri. And this area, parts of this area represent the district headquarters, Kasaragod, and and this since this area is falling in a tropical region, and there is not much variations in terms of vegetations or when we visually see from the satellite image. And here, the methodology what we adopted is we have used the Sentinel data too, and for the year 2018 to compare the pre and post monsoon seasons and its variability in terms of land cover. And again, in the recent development, government has completed the check dam in the upper reaches where this area started here. So they have constructed a small check dam. It's not check dam, a small reservoir. We call it as bund, and afterwards, and you can see the impact on the land use cover, especially on the upper reaches. So this has to do with something with respect to the water quality, and we have made some kind of comparisons. And this is the land use land cover map which I have done for 2019 and for April and October. And we have taken only 5 classes: vegetation, built-up region, barren land, and along with barren land, within the river itself also we have got several sandbars. Now, since it is in a smaller scale, it is very difficult to see, but you can see that a lot of sandbars are present available in the lower parts of the river than water bodies, and this covers nearly about 60 kilometers square area. And we have compared the rainfall as well as temperature for month of April right from 2014 2019, and this study was carried out for 2019 just to have a overview about the behavior or trend of temperature and rainfall which is occurring in this region. We have made this comparison, and now, as I said, when this reservoir was completed in 2018, and if you just compare the uh, impact on the vegetations on the upper stream, that's the reason we have zoomed out that particular region. And here you can see that in the year 2018, if you just here actually is getting hidden over here. If you just compare the vegetation thickness or in terms of healthy vegetations which were there in 2018 and whereas that is there in 2021, this reservoir was fully operational since 2020, almost 2 years after this analysis what we have done. And you can see that in terms of NDVI, so we have find out the normalized difference vegetation index, and this has given a clear-cut picture about the scenario which was there in 2 years before and at present how it is. And you can see that this has got a lot of impact on the vegetation. And now thereby when we compare about the water quality with respect to the land use land cover changes, and that is also clearly visible. And now for the year 2021, the analysis is not yet completed, but whereas for this previous year it has been completed, and you can see the next slides. And here, if you just compare the pre and post monsoon pH, And you can see that in pre-monsoon time, before the onset of monsoon, and because of the inflow, you can see that there are, even at this place, upper reaches also, because of the inflow, we are getting the limit of pH is not desirable as per the BA standard, and whereas this will be diluted during the post-monsoon season because of the high recharge taking place. And this with respect to pH. And again, if you just, and apart from that, we have conducted vertical electrical sounding geophysical studies, and just to characterize the aquifer properties with respect to the contaminations. We don't say contamination with respect to the saline water ingress, and we have categorized into three classes like saline, then brackish water and freshwater pockets. And we have conducted more than 30 locations, and these places have been shown over here. And you can see that this circle represents the saline, the pockets where we have detected the salinity ingress, and and this rectangle represent the pure pockets of fresh water, and in between we have triangular zone. That is what we call, that is what is represented for the areas which are brackish in water. And but if you just compare the pre and post monsoon for the same year, and you can see that the changes that is taking place because of the rainwater recharge, and many pockets where we can clearly delineate. And this is an ongoing project, and the outcome what we are expected that we can delineate and we can identify the locations wherein we have to focus for maximum recharge structure, so that we can minimize the impact of saline ingress. And this being one of the highly matured river, especially in this region, and you can see because of the, based on the geomorphologic setup which I have shown before, along with the land use classes. Okay, now and to sum up, I think my time is getting over. So to sum up, so we can clearly link the seasonal variations of vegetations in terms of the availability of water and geological setup. And after the construction of this check dam, this reservoir, and to some extent the administrators, they could prevent the inflow of saline water, and this will help us to have other strategic planning by the district administrators. I think this is my conclusion. So my presentation is over. I stick on to the time. So yeah.
Thank you, sir, for your time-bound presentation. Thank you, sir. Now I request the participants. It is open for discussion. Please.
Any queries from participants or others?
Any queries from participants?
I think someone has raised.
Please.
Okay, it is about some other comment. Okay.
Comment, sir. Sir, okay, very good presentation. Maybe through satellite image also it was proved that there is a vegetation improved. Yes, sir?
Yes, sir. Yes, sir.
What is the vegetation there, sir? That area?
Here we have mostly like a plantations and a natural vegetation. It's a tropical region, and rainfall is more than nearly 2,700 millimeters per year. So apart from the normal plantation and cultivations, the normal plantations are like coconut trees and arecanut trees. And arecanut trees, that is the cash crops here. And we have lot of timber plants, then other natural vegetations.
Sir, you are plotting parallelly check dam or reservoir. What is this? Is it check dam or reservoir? Is it both are different?
It is a small reservoir. It is called it as bund.
Small reservoir in the sense, you tell me in quantitatively how much reservoir is based on the height. How much it is? Height. Height of storage.
Height
How
of
much?
storage.
Because that only defines is small. Because check dam you are telling generally.
No, it is not check dam, sir. Actually, it is a bund. It is constructed across a river.
Bund, sir, bund. Which material that is? Bund means which material?
Cement only.
Like concrete dam.
Concrete structure, yes.
Like we call it concrete dam.
The main purpose is the purpose of this construction is to prevent the inflow of saline water, and this also will enhance the recharge on the upstreams, and which was clearly visible from that health vegetation which we are noticing in that NDVA analysis.
Sir, saline water actually, how the saline water is coming from the middle of the Kerala, because saline water intrusion from ocean to it comes from ocean.
Yes, it is. It is from ocean only. It is comes in
the dam is directed towards ocean.
Yes.
Okay, because of that, upstream will grow. Okay, good, sir. Right, sir. Thank you. Thank you, sir.
Thank you.
Thank you, sir.
Thank you,
sir, for the nice presentation. So moving to the next one. So next paper ID is 238. Sanjay, sir. Paper ID 238. Sanjay, sir, are you there? Paper ID 238. In this form. Okay, we are moving to the next paper ID. 153 is there. Paper ID 153.
Sir, it's 153. I'm here, sir.
Okay. So, answer giving the presenter status.
Sorry.
Hello, sir.
Sorry.
Yes, sir.
Please carry.
Am I audible, sir?
Audible. You're audible, sir.
Okay, sir. I'm sharing the PPT. I think.
Yeah, please, sir.
The PPT is visible, sir?
No, sir. It's not visible yet.
Sir, not visible, sir.
It's not visible?
Not visible,
Not
sir.
visible. Your voice is audible.
Okay, just hold a moment, please. Screen.
Sir, may I know the paper ID, sir? What is paper
153.
153.
Okay. No. Water log.
Is it visible, sir, now?
Yes, sir.
Okay, thank you, sir. Okay, sir. Good morning, everyone. I am Dhavaleshwar Rao, retired from Irrigation Department. Since then, for the last 10 years, I am in teaching profession. I did my BTech from NIT Warangal and ME Water Resources from Roorkee IIT. I have a lot of academic interest since inception, but I could switch over to that academic inspection after my retirement only. My life ambition is to do my PhD. The problem which I have chosen for PhD topic is based on water logging. I have come across with this problem when I was working with the irrigation department. Because it's a state government department, I could not make any research. Subsequently, I got transferred from that place. Now I have an opportunity when I'm in this teaching profession. Actually, I wanted to do this solution for this water logging also. So I have taken up this problem in Sri Ram Sagar project, It was constructed during 63 to 77. So the area, combined area is 0.67 billion hectares with catchment area of 91,725 square kilometers. So it is observed the waterlogging 42,729 hectares is already waterlogged, and it is prone to waterlogging is 55,180 hectares. The land was prone to waterlogging. Uncontrolled application of water and ignorance of the farmers, it has caused this waterlogging has caused so many problems. So the salinity and alkalinity has increased here in this case. When the salinity and alkalinity has increased, so the magnitude of say, saline water got increased. Subsequently, what happened? The yield got reduced. Reduction, the 2.6 tons per 3.5 tons per hectare has got reduced to 2.6 tons per hectare. So, to come over this, we wanted to study the socio-economic consequences of the farmers living there. What is the status? How they have economically downtrodden, and mismanagement also we have to come. So suggesting some logging, water logging, and the final remedy is leaching and drainage. If we come over with this leaching and drainage, all the above three problems, 1 to 3 will automatically will get solved. So in this research method, what farmers are doing, even with less yield, they are using more and more this usage of fertilizers also. So you see nitrogen, potassium, and all these things have been used, increased from 2015 to 2018. 16 out of 69,469 tons, it has been increased to 88,520 tons. So the case study, so there are several causes. In addition to these fertilizers, in addition to mismanagement, in addition to over irrigation, there are several causes. So recharge of your groundwater recharges, and cropping pattern also, they are not properly using the cropping pattern. The soil characteristics have also changed. So that has caused the increase of your profile in the soil profile. So the increase of your EC and pH values got increased here in this case. So which has caused, normally we know that the pH here in this case, I told you, when the pH and EC value got increased, it is seen that the yield rise stages 3.5 tons per hectare, as again you see 2.6, it has been decreased to 2.6 tons per hectare. This is only due to your increase in the change in variation of the EC and pH values and soil texture also in the villages also. So the soil samples, the water samples have been taken into the laboratories, and it has been tested also. It has been tested in this thing. So since 2018, we are working with this soil waterlogging problem. This waterlogging problem, we are working with this waterlogging problem. We have hired 1 hectares of land. In that 1 hectares of land, we are doing the experiments. I think 2018 and 19 we could do some. So open drains we have excavated. In 19 we have excavated the perforated pipes also. Actually, final our cheese submission, we wanted to go for composite proposal of your pipe and open drainage. So that we cannot do, that I cannot do that. Only we could do that open drain excavation and pipe excavation, perforated pipes drainage we have done. So the last one is left over. I think due to this pandemic situation, we could not even go to the Jagichal place. In Jagichal village, near about 24 villages are there. During that, 6 crops I have taken up. How it is getting reduced, you can see the 1 crop I have given here in this case, bar diagram also. The crop
excuse me, sir.
Sir.
Sorry for disturbing you, though. So what is this y-axis, sir? What are these numbers? 59, 51. What are those numbers?
Sir, which one, sir?
In this bar chart, you mentioned what is the y-axis. You have not mentioned what is y-axis.
59 quintals per hectare, sir. This is 59 quintals.
Quintals per
hectare.
That is okay, because you should have mentioned that is
Yeah,
okay.
sorry, I think I made a mistake. I think okay. So this is 59 hectares per quintal. It is being reduced. This is Kharif. This is for Kharif and this is for Rabi. It has gradually it is reducing due to this saline and alkalinity problems. Increase of your EC and pH values also it is increasing. Here you can see this 0.5 actually it is the crop is tolerable for 7.6 or 7.2 even 6.8 also it can be tolerable for EC. Now it has been increased to 8.6 here in this case. Even in for this pH value it has been increased in this case. Even EC also it has increased now to 4.4 millimoles per millimoles. Okay, here you can see the 4 crops I have taken in this case. Soil pH, increase of soil pH. So maize, rice and groundnut chilies, the crop decrease due to salinity of the problem, time in years here. Yield quintals per hectare here I have given here. Maize and rice, time in years 15 to 16, 17. So the decrease of crop yield is decreasing year by year. So this is the case how the crop is being decreased. So to overcome all these things, we have taken this about 80% of the this saline water and all the gypsum, organic materials, all the fertilizers, all salts have been accumulated day by day, and it is causing day by day. It is causing the decrease of your yield, sir. So what we did here in this case, 1 hectare of land has been, I told you already, 1 hectare of land has been leased. So for 14,000 rupees we have paid to the farmer and we have leased for this 1 hectare of land. So we have excavated the drains, the drains we have excavated. So furrows, for near about 6 furrows, after 6 furrows, we have taken one this cross drainage work also. So distributaries also we have taken. So all after 6 furrows we have linked this distributory channel to this each 75 meter span we have taken. So 1 meters. Some places we have excavated 1 meter deep, and some places we have excavated 1.2 meters each. This is really it is great achievement for us. So the trail run was success, and it has increased the yield from quintals per hectare to 55 quintals per hectare also. This is the thing we have achieved in this case also. So you see here the water table here in this case, the water table has been nearer to the ground level. So these subsurface drainages have been excavated. These subsurface drainages. This here we did for this perforated pipes also we did it, but that yield increase the data has to come. We did not get the data for pipe perforated pipes. I think we may get. I think we came to know that after perforated pipes also, drainage also, we got the increase in yield, but the perfect data we did not get. The last one is the last here you see this is the result of the paddy crop we have taken for all these things. So 30 centimeters to 60 centimeters to depth of 0.9 meters. Finally, we want to go for your composite pipe drainage. Composite pipe drainage means here we have to just I will explain you here in this case. Yes, sir. Here we have this is crop row. We have here in this case. We wanted to lay here the pipe, composite pipe, and we want to link these composite pipes here. These composite pipes to here to the open drain here. This is the open drain. So this has to be tested. So this we could not do it because of this pandemic situation. We could not do this one. I could not do all these things. It is proposed. So I think this could not be achieved due to present pandemic conditions. I think I have presented in this thing last international also, even in NIT Warangal also. I think. Okay, sir. So this is the acknowledgements I did it. So all these things we have done. The references, administrator CADA manuals I have taken. Central Soil Institution I have taken. Journal published in Chief Engineer SRSP, a general principal scientist, and Indo Judge also. All these things I have taken, sir. I think. I think if you can ask me something, if you can ask,
Yes.
fine, sir. Okay.
Thank you, Dhavaleshwar Rao garu. Thank you, sir, for your good presentation.
Thank you, sir.
Okay. Now it is open for discussion. Any participants, any queries, please ask.
Is there any query from participants?
Any queries?
Any suggestions also, it is welcome, sir. Because I'm academically interested. You are all people, those who are participating. So I want suggestions also.
If there are no queries, I have one query, sir. Hello?
Sir.
Sir.
Yes, sir. Yes, sir.
Okay, you have shown first one graph where vegetation is gradually reduced. Yes, sir?
Sir?
Vegetation means the quintal per hectare is reduced.
Yes, 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 sir. Yes, sir.
Okay. Simply, please define what might be the reason from your study. Simply one word. What might be the reason? Why vegetation? Okay, you are telling many things are causing. So simply from your findings, what might be the reason of decline of the production?
Sir, this is simple, sir.
Due to water logging.
This is mismanagement and non-providing the drainage.
Okay.
In India also, sir, in India, most of the projects have been not accommodated with the drainage facilities. So that is one reason. The second reason is mismanagement, over-irrigation. This is also one of the reasons, sir.
Now, I'm coming to the basic question, sir. Basic question. In the study area, what causes the water lagging? What causes the water lagging actually? Okay, solution is drainage. What is causing that water lagging? Why water lagging in your study? What is the reason?
The reason is accumulation of salts, EC, the increase of EC and pH values, and over-irrigation, accumulation of water, salts accumulation, saline and alkalines are being accumulated.
Yes. Okay, accumulation means in the sense there is increasing in groundwater level, yes?
Yes, sir.
So, first of all, the basic study is actually, have you gone for this groundwater studies? That is,
yes. Groundwater observation wells are there. 52 observation wells are in previous even in my previous paper. I have presented how many observation wells are there. How much increase in groundwater also it is increasing the groundwater also. Those data also because of lack of time and space, and we are restricted with only 10 slides. I could not.
That bar graph. You please go, sir. Bar graph.
Okay.
First slide, bar graph, you go.
Okay.
Now, see, now, right, okay. Here in 2000, what is the 13-14, okay. 2013-14, maybe the yield is very good. And
yes,
so now yield has decreased from somewhere. So it should accompany, yes. How can we know? You are telling because of groundwater increase. So at that period, what is the groundwater level? Now at this period, 2017-18, how much groundwater increase? Thereby, this all will come. Maybe like that study, if at all.
Yes, sir. All the static. All the data is with us. Yes, we got the data, sir. Increase of groundwater, observation wells are also there. We have observed the wells increase in groundwater data.
Okay. Present, how much groundwater is there, sir? As per you, now present, now at this moment, what is the groundwater level in this space? How much?
Yes, sir. It is below near about 5.5 meters below the ground. Present.
5.5 meters below. Very okay. Because that is near to the Sriram Sagar present. Maybe
yes, sir.
The situation.
Jagdish.
Okay, thank you, sir. Thank you for your.
Thank you, sir. Very kind of you, sir. Very kind of you for encouraging me and asking me the questions to improve my knowledge also. Thank you very much. Thank you very much, sir.
Thank you, sir. Thank you for the nice presentation.
Anyone, sir, still?
Sir?
Okay, thank you, sir. Thank you. You can close it. You can close the PPT.
Okay.
Sir, we are now moving to the next presenter, paper ID 207. Dr. Wilson, please note down this paper ID.
Sir, what is the paper ID, sir?
Paper ID
153.
No. Yours is over, sir.
Okay, sir. Okay.
So now it is 207.
207. Wait. Okay.
So Yashwan. Please, I have given you the presenter status. Now you can share your slides.
Okay.
So please continue. Your PPT is visible.
Success.
Excuse me, Mr. Dhavaleshwara, sir. Please mute yourself. Dhavaleshwara, mute yourself.
పోయించావా ఇప్పుడు
I think he is unable to connect.
Yeah, I think,
Is there,
again.
if anybody else is still remaining, you can give him a chance.
So paper ID 235. Swati Singh, are you
Yes,
there?
sir. Myself. ID number 173.
173 is ready. Right.
Sir, I am also ready. 240. ID number 240.
Okay.
Sir, when my time is 12:40, sir, but still I am waiting. When?
Yeah, actually, a request came from your one of the author to give you in the last. That's why.
Okay, sir. Okay, thank you, sir.
So now I'm going to for 173.
I think let us ask somebody else to present.
Yes, sir.
Because
Myself.
173, yeah.
Yes, sir. I'm presenting my paper.
Yeah, please.
Yeah, what is your ID?
ID 173. Dr. Shamal Doifode and Dr. Ashok Matani.
Please go ahead.
Yeah, just.
Presenter status is given to you, madam. You can share your slides.
Sure. Hello.
Yes, ma'am. Please share, please share your
Hi.
PPT. Yeah.
Can you see, sir?
No, ma'am.
Sir, is it visible?
No, not visible.
Not visible.
Not visible.
No.
Sir, is it visible?
No, ma'am. Still not. You can find the share option at the bottom. The bottom bar, there will be the share option.
एक Sir, I will join after 10 minutes, sir. Please.
Okay, please.
Sorry, sir.
So, yeah.
I'm
so,
trying.
moving to the next paper ID 240.
I think we can call paper ID 240 now.
Yeah.
Yes, sir.
I'm giving the presenter status. Yeah.
Yes, sir.
So now you can share your PPT.
Visible, sir.
No, it's not visible.
Wait. Sir. Okay. Tab. Okay. So yeah. It is visible, sir.
Yeah, it's loading. Yeah, now it's visible.
Okay, sir. Yeah. Very good afternoon, sir. Myself, Pappu Kumar. I am assistant professor, Department of Civil Engineering, KK University, Bihar, Nalanda. Today I am going to present my paper, Groundwater Contaminant Transport and
Please
Lifeline
enlarge.
Numerical Solution.
Hello. Please
Hello.
enlarge your PPT. Please enlarge your PPT.
Make it full screen. Yeah,
Make
please.
it full screen.
Yes, sir. Yes, sir. I have made full screen, sir.
Slideshow.
Yeah, it is
very
visual.
good. Yeah.
Full
Make it slideshow so
Yes, sir.
it will automatically comes.
Yeah. It is visible full screen, sir.
No.
What? I have already shared in slide mode.
You can
But
press F5 also.
one more time I will try full screen. Why not Windows? Okay. Yeah. Sir, it is visible full screen, sir.
Okay, we go ahead.
Why? Kumar.
Coming full
Yes, sir.
screen, however you go.
Papu, one second. Kindly send me your PPT in WhatsApp. I will share. Then you can present. Kindly send me. Again, your PPT.
Okay.
In meantime, anyone is remaining, please write in the chat box with paper ID. If anyone is remaining and would like to present, please put in the chat box. Yeah, 207 you have written. So at the end of towards the end of this session, a feedback link will be provided. So all the participants of the sample will be there. So please be there at the end of the session. Yes, please continue. Now it is visible on the screen.
Okay, sir. Okay. So today I am going to present my paper, Groundwater Contaminant Transport, Analysis and Numerical Solution of Diffusion in Saturated Aquifer. So I have written this paper with my friend Dr. Sunny Agarwal and Dr. Megha Syam. So first thing, content. First thing, introduction, subsurface fate and transport, literature survey, objective, uh, conclusion and references. Then first thing, introduction. As we know, groundwater are the most important source of water on the earth's surface. And it is also known most extracted raw material with withdrawal rate 982 kilometer per cube per year. And it is the primary source of drinking water. And with the help of management of groundwater resources, including both quality and quantity, required ability to establish a regional groundwater balance. So it is a very important source of water. Then come to know the water quality. In term of groundwater quality, means water quality is the vast and complex issues. Water quality is term here to express the suitability of water to sustain various uses or process. It is the customary to define water quality by several parameters like physical, chemical and biological. We can measure in terms of physical, chemical and biological parameter. Then come to know the what is a storage of groundwater. There are three types of a storage. Means the storage is known as aquifer. It is the geological formation of Earth's surface that store the water. That is known as aquifer. It is the three types: aquifuse, aquitard, and aquiclude. If water transmission is possible, then that is known as aquifuse. And
Sorry for interruption. It's better to come for your work and outcomes rather than the introduction and literature.
Okay, sir. Okay. Then come to know the next problem with groundwater. We know that the many problem related with groundwater like water logging, seawater institution, and groundwater contamination. I have done my work in groundwater contamination. Then come to know that these are the groundwater contamination sources like a storage tank, septic system, landfill, atmospheric contaminant, and trichloroethylene, tetrachloroethylene, and benzene. These are the contamination sources. Then these are the how the dangerous of groundwater contamination. We know the groundwater contamination. When any people drinking the groundwater, they have becomes serious health effect like hepatitis and dysentery, and may also it also affect the wildlife of the groundwater. Contamination is also affect the wildlife of the when it is. Then come to know the what is the how the groundwater contaminant transport. There are four processes like advection, dispersion, and diffusion and absorption. We know the advection is the process by which groundwater solute transport with the help of water velocity or average velocity of water in the groundwater. Then come to know the advection. Dispersion it is known as the when the contaminant transport with the difference of velocity in the groundwater. When higher velocity to lower velocity, then that phase that phase also that thing the groundwater solute transported. These are the flow chart of my analysis. First we formulated the numerical analysis, and after we simplified the numerical problem, we have applied FEM and analytical solution, and after that we have finally we compared the result with the numerical problem. This the diffusion we have only focus in this slide, in this presentation we only focus the diffusion process, means the solute transported with the help of diffusion. We know that diffusion is the process molecule transported due to the molecular motion or concentration gradient. This slide show the concentration gradient higher to lower with respect to time. These are the plot of concentration versus. Then what the governing equation for diffusion? The one diffusion governing equation is known as Fick's law. F, that is the flux of solute, or we can say flux equal to d dc by dx equal plus q. D is the diffusion coefficient, and q is the c is the concentration of solute. Then we have, these are the analytical solution in term of time or diffusion coefficient. C is the concentration gradient with respect to time. C is the concentration gradient, T is the time, and D is the diffusion coefficient in x and y direction. These are the diffusion coefficient vary with Arrhenius equation, or we can calculate diffusion coefficient with the help of this equation. These are the diffusion coefficient of different like water with air, water with carbon dioxide, water with different parameter. We have taken the diffusion coefficient. But in this slide, in the result and discussion part we have taken three cases, like in the sand case, silt case, and sand, silt, and clay case. We have taken the coefficient of diffusion in the silt case and sand case and clay case. This shows the how the solute concentration transported with respect to time. Means the concentration is in the sealed case low, in the sealed case lower velocity flow in the sealed case, and higher velocity the in this figure. First one shows the concentration or contaminant transport higher velocity with distance, means in the sand case higher velocity and sealed case lower velocity. This thing we have formulated in MATLAB software and plotted the graph with taken the different case of diffusion coefficient. Then we have also formulated temperature variation, means the transport process, what the effect of temperature. I have formulated, I have taken different temperature cases like 188 degree, 185 degree, and one, means as a numerical problem. I have formulated the equation and taken as a numerical problem and formulated with different cases. This means temperature, higher concentration, lower temperature, lower concentration. This thing happening with my numerical analysis. Then in the conclusion part, we can say the numerical analysis is easier to analyze the contaminant transport modeling, and analytical solution is too complicated and time consuming. So that's why we have formulated the FDM model and formulated in MATLAB software, and after the plot and analyze this numerical problem. This is the conclusion of my research work. And after that these are the my whole research work.
Okay,
Thank you.
Thank you.
Yes sir, thank you sir.
Thank you.
Is there any query from the participant?
Any queries? Any queries, please?
So if you see your figure number 2,
Hmm.
now you have not said. In figure number 2, what I see there, you have given one colorful some mark indication, but in the graph it is not there.
Yes, sir. In figure number 2, what, sir? Again, sir? What?
You go to your figure number 2, you share it. Data from.
Okay. Figure number 2. What the figure number 2, sir? Sorry, sir. Actually, I am not sharing. One of my colleagues are sharing. That's why they have
Okay.
disconnected, and
Okay.
I am not able to share again.
So what the graph you made in figure 3?
Yes, sir. Figure 3. Actually, sir, in figure 3, I have taken temperature variation. In the means the solute concentration.
What is the reason behind that trend? That trend is decreasing.
But in the figure 3, they shows, sir, the figure shows when the temperature is increasing, the solute transport means concentration is also increasing with the distance.
What is the reason behind this?
Reason behind it, sir. Mm, Actually, I am not thinking what the reason is happening, but I am analyzing this thing with the help of solid concentration, with the in the case of silt, sand, and every take different case, sir.
You have just put the data, whatever the output is coming, you are showing that one, but you have to go the inside also, so that can conclude something. You have to go inside
Okay,
that
sir.
one.
Yes, sir. Okay, sir. Okay.
That is from my side. Any other question from any participants? This is okay, sir. Have to answer.
Sir, okay, na? Okay.
I'm going to the next one. 20.
Yeah, we can take the next paper now, please.
Okay, sir.
Yes,
Thank
sir.
you, sir.
207, sir.
Yeah, I've given the presenter status. Kindly share your PPT.
Yes, sir.
207. Okay.
Yeah, right.
Yeah, say the book.
If anyone is remaining, would like to present, please put in the chat box your paper ID. They are using through the mobiles, that's why that is the reason.
Yes, sir. Yes, sir.
So can you paper ID 2 not 7, just 1.
I think still he is not able to present. Let us give
235
time to
just came.
paper ID 235 because that is the last one who is waiting for a lot of time.
Yes, yes. So I've given the presenter status to 235.
because these people, they are unable to present.
Yeah, I've given three, 4 times.
Sir, already 205 is completed, sir. Hello?
Yes.
Paper ID
235.
235.
Paper ID 235.
Good afternoon.
Yeah.
Yes, good afternoon. I'm Swati Singh Parmar. Am I
Yeah, you
audible?
please present. Yeah, you please show your slides and present.
Thank you. Good afternoon, everyone who's present here. My paper is titled Sovereignty and the Law of Transboundary Aquifers. Is screen visible?
Yes, ma'am. It's visible. Please proceed.
Thank you. So, I'm Swati Singh Parmar. I teach international law at Dharmshash National Law University, Jabalpur, Madhya Pradesh. And this is a doctrinal study which touches upon a very important facet of water policy. And this is about transboundary aquifers. So, aquifers are subsurface freshwater resources. And as we all know, fresh water is a rare water resource amid the industrialization that we've seen since last century. And there are certain areas where the aquifers are located between two states. Here, by states, I mean political states, that is, two countries. And water sharing, especially drafting a water policy in regard to such transboundary aquifers which lie with some of its portion lie in one state and some of it lie in other state. It becomes a very complex issue for the water policy. Now, in such situations, politically, if we speak, we have seen such transboundary aquifers and the water sharing of those transboundary aquifer water has been an important site of political tension. Now, such political tensions can be addressed, and water policy can be meticulously drafted if we understand two important um, uh, ideas that I'm discussing in this paper. One is sovereignty, the sovereignty of the state, the idea that the state is sovereign, independent, and supreme. And that is why it has supreme authority over its territory and everything that is lying over and above the territory, including the subsoil, which will include the freshwater resources, which are subsurface. So by this idea of sovereignty that we have had since 1648, which is the year when Treaty of Westphalia was signed at the conclusion of 30 years of European War, which was essentially an ideological war between the Roman Catholics and Protestants. That was the starting point of the idea of sovereignty, and that's where we started attaching the idea of sovereignty with territory, and the amalgamation of both tenets gave rise to an idea of territorial sovereignty. Now, this territorial sovereignty gives states complete authority over its land, internal waters, territorial waters, air and space over these territorial waters, and seabed and subsoil. Now, when it comes to transboundary aquifers, most of the states which have the larger share of these transboundary aquifers, they are disproportionately at an advantageous position in drafting their water policy, while the other state which has lesser portion does not have any such upper hand. Now, this creates a lot of problem because there is another a customary rule of international law, which is all the free resources being treated as common heritage of mankind. So water, by that argument, water will also be treated as a common heritage of mankind. So there are juxtaposed positions of sovereignty that a state claims over its transboundary aquifers, and between water being treated as common heritage of mankind, and that's why two states or more states where transboundary aquifers are located should have an equitable resource sharing, water resource sharing. Now, why I'm discussing this issue is that there is still no international convention or an international treaty on how to regulate the water sharing in these transboundary aquifers. So we have had a 1997 convention, which was on the non-navigational uses of international water courses, but it dealt with the fresh waters in general, and it did not deal with transboundary aquifers. Now, as we know, the transboundary aquifers, by the very nature of it, they are situated subsoil, and that is why most of the provisions of 1997 Convention on the non-navigational uses of international water courses are not squarely applicable on law of transboundary aquifers. Now, there was another attempt by international community. It's one organization, International Law Commission, which is the drafting commission of the United Nations. It, in the year 2006, adopted first reading of draft articles, and then finally it came with draft articles on the law of transboundary aquifers. Now, again, this is just draft articles. This has yet not been executed in a treaty format or a convention format. So from 2008, where we saw some initial steps in making law, in arranging some law on how to use the waters of transboundary aquifers, still it's 2021 and we don't have a convention to date on dealing with transboundary aquifers. And this, yes.
Sorry for interruption. So please,
Yes.
by your work within 4 or 5 minutes.
Yeah.
You are
Maybe
already
you can now conclude. You can propose your, because you're
Yes,
already
yes, yes, I'm just concluding. So through this study, I have there are a lot of other issues that I'm not being able to put in the arguments right now. So through this paper, I am pressing the need of actually bringing the draft articles on the law of transboundary aquifer into a convention, so that the political tensions are eased and water policy can be drafted clearly in relation to transboundary aquifers. These are my references. Any questions, any suggestions?
Is there any query from any participants?
I think now those two papers which are remaining, we can give them last chance if they
Yes, sir.
can.
Sir, yes, sir.
Ready.
ID number 173. Now I'm sharing, sir.
Thank you, ma'am. Thank you for your nice presentation on the water policy. This is very, very different from the technical issues. So thank you for the nice presentation. Thank you.
Thank you. Thank you so much.
Next presenter, please wind up your work within 5 minutes.
Sir, is it visible?
Yes, it is visible.
Yeah, sir. IoT and sensor application in water resources utilization in smart cities management in India economy. Myself, Dr. Shamal Doifude, head of the department in Government Engineering College, and my colleague, Dr. Ashok Matani, professor in mechanical engineer. So according to the United Nations, more than 50% of the world population will be living in a water stress region by 2050. Therefore, we should reduce the 126 million cubic meter of water lost annually due to the leakage, poor metering, and theft, and not just for the good of the planet. The cost of lost water.
Hello, I request you to please enlarge the PPT. It is not in slide share mode. Please enlarge. You can't able to read actually. Thank you.
It is not read. Sir,
No.
Is it visible, sir?
Visible, but 3 slides we are seeing instead of 1 slide at a time. So you make it a single slide. Okay, now please carry on. Thank you.
IoT smart water management system exists to help us to optimize the water use. Challenges that we face in the water management is know how much water we are using or knowing if there was a problem. With the Internet of Things, these challenges are eliminated through the remote monitoring and the use of various sensing technologies and quick response times. IoT smart water management system uses a lot of connected devices in the field that how it communicates remotely with the landscape irrigation system and weather station. It allows us to pull data back and command out the very quickly. Water systems are becoming more challenging to the manage as assets are spread across the physical footprint spanning miles. And infrastructure is updated, utilities can implement the Internet of Things, that is the IoT technology, throughout to help them make water management more efficient and safer for the consumer and worker. These smart devices and sensor can help with the real-time data collection and alert to prevent the issue from occurring and reduce the workload on the worker responsible for the physically checking every inch of the infrastructure. Creating the smarter water system. Smart water system based on Internet of Things sensor, big data and analysis can reduce the amount of water that is wasted during the agriculture and manufacturing processes.
Sorry to interrupt, but if you better you give your proposal of the research, because already it is 13:30. Next session is at 2 o'clock. So
Yes.
what are you suggesting actually from the research paper that you only present?
Conclusion.
Giving you are just teaching in the class. Please don't do that.
Yes, sir. With the help of this
That is
IoT.
okay. I understand, ma'am. But now you should present your research. This is a conference paper, isn't it? So please give just what you have done.
Yes, sir. With the help of this, we can lose the water. And nowadays, it is used in a Mumbai Municipal Corporation for knowing the how much garbage is present in a drainage water. So, with the help of this, we can improve the how much losses.
You please present what exactly you have done. That is what I am just saying you, rather than giving complete theoretical description of IoT and sensors and their. You please present what you have done and what are your results.
Yes, sir. With the help of this, we can leakage detection, then reduce the water wastage. So this is help for the.
I understand. I am asking you. You show what you have done. Don't tell that what we can do. You show us what you have done. Because this is a research conference, no? So you should present the work which you have done. You are just presenting whatever is there in the books or what is possible. Just show what you people you have done. Actually.
Yes, sir. Actually, IoT can be used in a water meter. And IoT walls is also used.
Thank you, ma'am. Okay, thank you.
Have you used it? That is, I am asking you. If it is used, that is okay.
We are using this IoT technology in water system.
You show us then that results rather than telling us it can be used here or it can be used there. Still, you are not getting my point. Okay, this is not a classroom lecture. This is a conference presentation. So you should present your research. Right? So you tell us what you have done and what are your results and what are your observations. That is what is expected in a research paper. I'm very sorry to say you have to give what is the work done in your research paper.
Okay. Okay, sir. Sorry, sir. My colleague, Dr. Matani, will give explanation for this.
Hello.
Okay, thank you for the presentation. Dr.
Hello.
Srinivas, sir, we can move the last one paper.
Hello.
Already exceeding the time.
Hello.
Yeah, hello. Hello. Yeah,
Hello.
Dr. Matani, sir. Yeah, hello. You're audible, sir.
Sir, yes. I am speaking. Hello.
Audible, sir. You're audible.
Hello. Now it is okay, sir?
Please, sir.
Hello.
Please, audible, sir. Speak, sir. Speak. What you are going to?
Yes, yes, yes. Sir, we have done this because we want to popularize these IoT applications in water resources, since majority of the researchers here are young researchers, and we want to give them some input so that these IoT can be used in that. Even IoT applications are used by water supply authorities for water mapping, 3D mapping, and accordingly, even water sensors are used for detecting the water leakages on the pipelines, even oil and gas industry, water pipeline, drinking water. Even Maharashtra Irrigation Department in Pune region, they have done these IoT applications in agriculture, and they have saved 13% area with the help of cultivation area with the help of this IoT application. This concept we have taken so that the young researchers should take this as the new emerging area, and moreover, it is also used in agriculture, also in a drip irrigation system. Smart metering we can have, intelligent pricing is there, water quality testing is used, even smart irrigation controllers they are used. So these are some of the areas where IoT applications in water resources are used. We want to invite some.
Okay, sir, we have understood. Yes, because there is another session, people are waiting for that session. Some have already joined, and that too, you are telling us what others have done, and we have understood that. That's fine. So I think now the last person is 207. He is saying that he can present.
Yes, sir. I can. Sir,
This is your last chance. This is your last chance. If you can't present, then just leave it, okay? Because otherwise, the next session would get delayed because of us. Already, we are delayed by half an hour.
Yes, sir. My topic is hydraulic modeling of water supply network using a finite by pressure driven approach. Next slide. The two methodologies used for analysis are demand driven analysis and pressure driven analysis. And the demand driven analysis is can't be used because it can't give the actual situation time every time, because it gives negative pressures sometimes. That's why we have to use pressure driven analysis. Next slide. Because of increasing worldwide population and rapid industrialization and also urbanization, they are threatening the water resources and also adding organic water systems under ever increasing stress. That's why we have to design a water distribution network by systematic manner. Next slide. These are water distribution network problems, which shows that poor service, low willingness to pay low tariffs. It leads to no cost coverage and leads to lack of reinvestments and leads to high water losses. In the methodology, the main purpose of the study is to run water distribution network steady state and extended period simulation, and we evaluate and decide on which procedure is better than the others are. In this, two models are existing in pressure driven analysis to solve the water distribution network using one PDA method or all PDA methods. Next slide. This is the flow chart showing the procedure of pressure driven analysis using graphical user interface. This shows inserting the WDN and checking for its steady state or extended period simulation, and run demand driven analysis. And if the pressure is not met, we have to run the pressure driven analysis, and finally checking the results. Next slide. In results and discussion, it is necessary to explore the capabilities of recommended graphical user interface. So within design period, it is necessary to analyze the potential failure scenarios in fairly smallish simulation time. So we have taken 3 benchmark networks. First is steady state single source water distribution network as shown in diagram, and we have analyzed, next slide, we have analyzed it by using 7 different methods of pressure driven analysis and 1 method of demand driven analysis, which shows the calculation time for each method. And next slide. Second network is steady state multi-source water distribution network, and we have next slide. We have solved this network for pipe 3 failure with different methods and compared the results of all these methods and calculated the calculation time for all these methods. Next slide. Third is extended period simulation of this water distribution network as shown in figure, and we have carried out this analysis for this network and compared all these 7 methods. Next slide. This is the graphical representation of that 7 methods analysis comparison. Next slide. To conclude, the mentioned software is a real proof to how the pressure driven analysis using graphical user interface can deal with any water distribution network in just few seconds, and it is very useful when trying to solve the WDN under pressure deficiency conditions. The main advantage of this program is that it could compare between different PDA methods in steady state or extended period simulations. Next slide. These are my references, and thank you.
So thank you for the presentation.
Okay, sir. Thank you, sir.
I think sir, all the presentation is completed. If there is any query, otherwise we will move further.
Yes. Should we conclude the session?
Yes, sir. Yes, sir. Yes, sir.
Yeah. Dr. Raveen, should we conclude?
Sir. Yes, sir. Yes, sir. Yes, sir. Please, sir.
Yes.
Yes.
Okay. So, on behalf of my coach and myself, let me first thank the organizers for giving us an opportunity to chair and co-chair this session. It was a very nice experience. I think we are a bit late. Many people must be very hungry, and at 2 o'clock there is another session. So, without taking much time, let me declare that the session is over. Few papers they could not be presented, and there were some technical glitches. But still, overall, whatever presented was of fair quality. I would not say it was great, but it was fair quality. Students are working, that is for sure. But I would advise all those who are using different softwares that our basic is civil engineering, in bracket hydraulic engineering or environmental engineering or whatever, that we should never forget. We are solving these equations by using different techniques. So our base is that which we should never forget. And then there are various tools available in the market, and of course we use them and we should use them, but never leave your basics. That is what I would suggest to all of you, and all the best for your future.
Yes, sir. Thank you, sir.
Yeah. Okay. Thanks a lot,
Thank you, sir.
everybody.
Srinivas,
Thank
thank you, sir.
Yeah.
Thank you. Hello, thank you.
Thank you, sir. Thank you.
Okay. I will send the mark list by email only.
Yes, sir. By email, yeah.
Yeah.
Just to
I
share
have
and
completed that.
question.
I will just reply to your email which I received
Yes,
earlier. Right?
Yes, sir.
Okay.
Yes, sir. Yes, sir. Yeah, yeah.
So can I take your leave now?
So I'd like to say thanks for having the chair, Dr. Srinivasa sir, co-chair Dr. Ruben sir. They have given their valuable time, sir, and they have given suggestions. That is this is the motivation as well as the authors can incorporate. They are where they are lacking. Mainly they are lacking in the insight. So thank you for your valuable time and suggestions, sir. And also thanks to keynote speakers who have given a very nice presentation, Dr. Krishna Reddy sir and Dr. Jed Ahmed sir. I would like to thanks to all the presenting authors along with the participants who participated in this event. So thank you to all. Thank you organizers, and thank you to management of KLU. Thank you all. Thank you, sir. We are concluding the session
Thanks a lot,
here.
respected sir, for your precious time. Thank you so much.
Thank you.
Well, good afternoon. Thank you so much, Umesh sir. I think you have rightly completed the session well within the time of just 2 minutes left over for the next session. Thanks a lot. Let us begin with the proceedings of the next session, which is Environment, Water Resources, and GIS. That is track 4, and this will be the last session of this track. Okay. So right after this track, we will be moving ahead to the valedictory ceremony. All right. So without any delay, so I would like to invite chairs and co-chairs, and we will have the keynotes as well. So welcome all of you for this track 4, session 4, Environment, Water Resource Engineering, and GIS. So basically we have with us as a chair Sir M.A. Muhammad Aslam, who is the Dean of Department of Geology, School of Earth Sciences, Central University of Karnataka, Gulbarga. I wholeheartedly welcome you, sir, to be part of this session as a chair. So let me introduce his profile. So he has done his PhD and he has got first rank with four gold medals and 1 cash prize of MSc Geology from University of Mysore. His professional profile includes experience in teaching, research, and academic qualifications of higher education. So he has also got fellowships in UGC CSIR, SRF, postdoctoral fellow in Sultan Qaboos University, Oman, and advisory academic visitor, Cambridge University, UK. And he's also a faculty mobility member in Tartu University, Estonia, which is a part of European Union Erasmus Plus program. So he has also authored and edited several books, published many papers in peer-reviewed and indexed journals, and also presented papers in national and international conferences. Sir, with this, I wholeheartedly welcome you on the behalf of the Third International Conference of Advances in Civil Engineering. Thank you for being with us, sir.
Thank you, Hamid.
Yeah. So now I would like to invite the co-chair for the session, Dr. A. Sivashankar Garu, who is the Professor, Department of Civil Engineering, Vignan University. I also welcome you wholeheartedly, sir. Thank you for joining with us as a co-chair for this auspicious session of Environment, Water Resources Engineering, and GIS, track 4 in this third International Conference on Advances in Civil Engineering. I would like to introduce his profile. So Dr. Sivashankar Garu, who is a professor in Department of Civil Engineering, Vignan's Foundation for Science and Technology and Research, deemed to be University, Vadlamudi, Guntur, Andhra Pradesh. Received PhD in Environmental Technology, MTech in Remote Sensing and GIS from JNTU, Hyderabad, and MBA from Annamalai University. He has more than 24 years of teaching and research experience in environmental technology, remote sensing and GIS, resources management studies. Published more than 300 research papers in many international and national journals and 5 patents besides undertaking national projects. He has presented and participated in more than 100 international and national conferences, seminars, workshops, guided research work of 8 PhD degrees, more than 100 students gained the award of MTech and BTech, authored 6 academic books. Received 3 national awards, life member of 13 professional bodies. Sivashankar sir, thank you for joining with us. I wholeheartedly welcome you on the behalf of Third International Conference on Advances in Civil Engineering. Thank you, sir. Thank you for being with us and joining the session. Sivashankar sir? So, Anil sir, is Sivashankar sir is there? Is he joined?
Sir, he said he has joined already. I will check, sir. Anyways, you continue with the proceedings.
Anyways, well, sir, thank you for being with us, sir. So we will without any further delay, we'll move ahead with our first keynote. But before that, I would like to inform all the participants that after the keynotes, we will be having paper presentations until 5:50 p.m. At sharp 6 p.m., we are going to have valedictory ceremony. So before that, we'll have to complete the whole session. and this is also a sincere request to the chair and co-chair to take over the proceedings and kindly follow the time, because we need to finish off it well before the times. And also a sincere request to the chairs and co-chairs that you are already been given with the rubrics wherein you are going to assess the presentations of the papers, research papers. So you will have to kindly do this procedure carefully, sir. Thank you so much. So right now we have with us Dr. A. Raju Garu, who is a professor, civil research scientist, Kumamoto University in Japan. I wholeheartedly welcome you, Dr. A. Raju, sir. Thank you for being with us for this keynote session.
Thank you, sir.
So, yeah, so let me introduce your profile to our fellow participants. Dr. A. Raju graduated and post-graduated from JNTU, Hyderabad, India in 2007 and 2009 respectively. PhD from National Institute of Technology, Surathkal in the area of remote sensing in 2014 and postdoctorate from Kumamoto University, Japan. Co-founder and Secretary General of CAFET Innova Technical Society, established in 2007. He is an editor for 4 international journals published by CAFET Innova Technical Society. And he is also adjunct lecturer at Kochi University of Technology, Japan, visiting associate professor at Linton University College, Malaysia, and international fellow at Geotropic Center, University of Technology, Malaysia. He is a visiting faculty of Department of Civil Engineering, Andalas University, Indonesia. He has also received Green Environment Award during ICE TE 2020 by Sri Rajendra Singh, popularly as Waterman of India, and also received 2 Young Scientist Awards in 3rd WCSET 2014 and 3rd ICEE 2016. Sir, we are really honored to have you with us. Thank you so much for accepting our invitation in delivering this keynote lecture. Thank you so much, sir. So now I will be giving it up to you so that you could able to share your screen and go ahead with your keynote lecture, sir. Thank you. Thank you so much. And Professor Aslam and Professor Shiv Shankar, sir. So it is also, I am also giving it over to you. From now, you can take over the proceedings of the session and do it wonderfully. Thank you so much, sir.
Thank you, Dr. Hamim. And I take this privilege and honor to thank KLU University for giving this opportunity. And since we are going on time, so I won't take much time, and thank again for the organizers. And we can go ahead with the invited talk now. And the speakers are informed to stick on to the time, and also the participants, they are informed to stick on to the time. And who will be monitoring the time, Hamim? Who will be giving
if you need, we will do a reminder, sir, or you can also do that. I mean,
I think if you can take that task, that may be better.
Oh, okay, okay, sir.
We can start now. If anything a co-chair has to say, over to co-chair.
Shiv Shankar, sir.
Okay, I mean, then we can start. Let us.
Sure. Raju sir, you can now start. Let's do it. Thank you.
Okay, thank you, Dr. Hamim, and session chairs, Dr. Aslam, and my professor Shiv Shankar, sir. And thank you so much for introducing to me. Am I audible to you?
Yes, sir.
Yeah, go ahead.
And my screen is proper to you?
Yes, sir. Yeah.
Okay. Thank you, and good afternoon to one and all. I'm very thankful to the organizing committee members, Professor Hanumantarao sir, Professor Paul Raju, and other organizing committee members for inviting me to deliver the keynote talk in the 3rd ICAC 2021. Today I am here to present on satellite UAV image processing and remote sensing techniques with ongoing projects. Presentation is going to cover the processing stages of remote sensing satellite data, image enhancement techniques, in that mainly I concentrated on the contrast enhancement techniques, and targeted research area is histogram equalization models, and developed histogram equalization based coastal application models like automatic shoreline detection, suspended sediment transport, land use land cover assessment, and ongoing projects at Kumamoto University in the laboratory of Professor Takashi Watanabe like AI, Internet of Things, UAV based smart agriculture system and rain plant resources, like developing geospatial models for rare plant distribution and mapping, developing Internet of Plants, IoT-based devices, fusion of multispectral camera and spectrometer data for the UAV, developing hotspots or cultivation areas using UAV IoTs, an integrated plant or crop monitoring system using UAVs, artificial intelligence, Internet of Things, smart aquaponic system architecture using IoTs. Coming to the processing stages of remote sensing data, after acquisition of the remote sensing satellite data from the ground station, based on the project, the satellite images will be radiometry collected by calibrating the satellite images and convert the pixels into the real surface reflectance values, and then geometrically corrected the satellite images by assigning the proper geographic reference system. After completing the pre-processing, still if the image needs some enhancement, then we will apply the image enhancement techniques under processing stage like contrast enhancement, edge enhancement, principal component analysis, and filtering techniques. After the researcher or academicians or industrialist find sufficient enhancement in the image, some enhancement or clarity in the satellite images, then the images will be classified using supervisor classification and unsupervised classification. In the supervisor classification is a pixel based classification techniques. It has three main algorithms like maximum likelihood algorithm, minimum distance to mean, and parallelepiped classifier. Maximum likelihood is the well-known supervisor classification algorithm which provides efficient classification output. After proper classification, to check the accuracy, the accuracy assessment will be done in the post-processing stage, and change detection analysis will be used under the post-processing stage to identify the changes between two particular periods. Image enhancement. Why we have to do the image enhancement? While image acquisition, the sensors will detect the reflected energy from the surface features. During this reflectance, some particular feature will reflect more amount of energy, and the neighborhood feature will reflect less amount of energy. This creates low contrast in the sensors while detecting the reflected energy. Sometimes one material will reflect tremendous amount of energy in the certain wavelength, and another material will reflect the same amount of less amount of energy in the same wavelength, also create the low contrast in the satellite images. And different materials will reflect the same amount of energy in different wavelengths like visible, near infrared, mid infrared, also create the low contrast in the satellite images. So in these cases, we will apply the image enhancement to improve the pixels intensity in the input image. There is a well-known image enhancement techniques like contrast enhancement, which is the difference in the gray level values of an input image. There are two well-known methods like linear contrast enhancement and nonlinear contrast enhancement, or under the contrast enhancement technique. Coming to the linear contrast enhancement, by using the pixel values, we will change the output image enhancement. In the nonlinear contrast enhancement, it is based on the transformation function like y equal f of x. Histogram equalization is the most useful nonlinear contrast enhancement method. If you see the basic principle of these two contrast enhancement techniques, like this is a linear contrast enhancement. Imagine this is the input image with the pixel values like 15, 10, 60, 18, 25, 50, 58, and so on. And when we apply this equation, digital number output is equal to digital number of the input image minus minimum value of the pixel number, and by maximum pixel value minus minimum pixel value into 255. We use that is 255 based on the bits data. If I take the 8-bit data, is the 2 power 8 is equal to 256. So I use that the values between 0 to 255. So I use the 255 for the 8-bit data. So when we apply the minimum pixel value as a 10 in this equation, and maximum is the 60, when we apply these values, the minimum value 10 will be stretched to the 0, and maximum value 60 will be stretched to the 255. 0 will be completely dark and 255 is the completely white. So with this equation, with this lean method, we are losing the information in that particular pixels when we use this linear contrast enhancement techniques. When we come to the nonlinear contrast enhancement, imagine this is the continuous histogram of the input image, And then after equalization, by applying the probability density function and cumulative density functions, after equalization, the output histogram will be like this. So maximum portions will be stretched to the lower case, and lower portion will be stretched to the maximum portions to the certain level. So based on this method, we can enhance the low regions and compress the higher regions. But this method also has some drawbacks. It is like sometimes it stretches the high histogram regions and compress the low histogram regions. It also extremely pushes the intensities towards right or left side of the histogram. It does not preserve the brightness in particular regions where we exactly need it. For example, building shades and tree shade areas. Those areas it does not preserve the brightness properly, and also it introduces some unwanted noise in the output images. To overcome these drawbacks, there are many histogram equalization based method techniques has been proposed, like bi-histogram equalization, multi-histogram equalization based methods, and clipped histogram equalization. Just I will go the brief introduction of these methods. Bi-histogram equalization method. In this method, the input histogram will be divided into two sub-histograms based on the general statistical methods like mean, median, standard deviation, and then equalize the histogram individually so that we can preserve the brightness and contrast in that particular output image. Multi-histogram equalization. In this method, the input histogram will be divided into several sub-histograms or more than two sub-histograms, and then apply the classical histogram equalization process individually so that we can preserve the more brightness and more contrast enhancement in that particular output image. And clipped histogram equalization is an interesting concept. We first identify the particular plateau limit or threshold limit, and by using that limit, we will clip the input histogram, then equalize the remaining histogram. So then we will receive the sufficient contrast enhancement and brightness preservation. Still we need sometimes more brightness in the output histogram. Then we reintroduce the clipped portion into the final clipped histogram image. So there are many bi-histogram, multi-histogram, clipped histogram equalization methods. To understand the better performed models, so we tested the 46 well-known histogram equalization based methods with 120 sample images by using this flow method, like satellite images, camera images, and then we tested for the increasing contrast, brightness preservation, and removing the annoying artifacts that is nothing but noise. Then we received the final enhanced image, and then we will check for the quality measurement. For brightness preservation, we use the absolute mean brightness error method, and for checking the contrast enhancement, we use the peak signal to noise ratio method. Then after receiving the sufficient contrast enhancement, brightness preservation, we use it for our applications. So brightness preservation has shown undesirable artifacts and not proper the contrast enhancement and brightness preservation. But multi-histogram equalization methods also shown better brightness preservation, but introduced unwanted noise. And clipped histogram methods shown better brightness preservation and significant contrast enhancement, and shown less amount of the noise in the output images. So we checked the well-known 46 algorithms with 120 samples. Here we shown the 12 sample images with 11 algorithms. In that brightness preserving dynamic histogram equalization and gain controlled clipped histogram equalization, these two methods has shown better absolute mean brightness error, and it is nothing but brightness preservation, and better contrast enhancement results as shown. So by taking the advantage of these, we have shown this output results here. J and L are belongs to the clipped histogram equalization methods. This is the image of tire with snow. In this method, J and L has given better clear top of the snow on the tire, and it also for the same for the matches. And the same thing when we were observed with the satellite images. So here we selected two satellite images like list 4 band 4 image and list 3 band 4 image. For these two satellite images also, the clipped histogram equalization based methods has shown better contrast enhancement and brightness preservation. So this is G and I has given better results compared to the other images. So by taking the advantage of this clipped histogram equalization, we came out with research objectives to develop automatic methods like automatic shoreline detection, sediment transport and dynamics, and land use land cover assessment. So for this, we selected the study area as the west coast of India, part of west coast of India from Talapadi to Mulki, around 40 kilometers stretch. So the reasons behind to select this study area are, the study area is very dynamic with 2 river mouths and 1 port. There are 2 river mouths from the 4 rivers, and there is an active NMPT port. So there is a Ullal, at Ullal we have a Netravati Gurupur river mouth from the rivers Netravati and Gurupur, and here the Mulki, at Mulki we have the Mulki river, Pavanji river mouth from the rivers Mulki and river Pavanji. So these are the data sets we have used for to develop these 3 models. And coming to the first method, automatic detection of shoreline. So first we run the input image, satellite image with the clipped histogram equalization method to enhance the coastal features. Then we applied the mean of the histogram. So this is the input satellite image. Then we went for the image histogram, input image histogram. Then we applied the median filter to remove the null pixels in the satellite image. Then we measured the mean value of the filtered histogram. Then we segmented the input histogram into the 2 sub-histograms. Then we identified the local maximum values of each sub-histogram, and based on this local maximum value, we measured the mean threshold value. So based on this mean threshold, we equalized the sub-histograms. Then we normalized the histogram. Then finally we received the contrast enhanced image. So this enhanced image is like this from the proposed method. So this is the input image. So histogram equalization and bi-histogram methods has given complete noisy images. So finally we received the clipped histogram equalization based method of the satellite, complete satellite images. So this is the proposed from the proposed method, list 3 image. This is the list 3 2005, list 3 2010 satellite images. So this image has been used for the automatic shoreline extraction algorithm. So the clipped satellite is image is used here. Then threshold that image, and we made the region grouping and labeling. Then we removed the we applied the region of interest. Then we applied the image dilation and erosion. Then we applied the edge detection. Then we applied the coastal extraction method to extract the 2 intersection lines, that is between the water and beach and the land. So finally we received the shoreline image. The shoreline image will be applied by the digital shoreline analysis system to extract the shorelines and also compare the shoreline with the other years shoreline change analysis. So finally we made the shoreline change rates. So this is a clear flow of the method. This is the input satellite image. So we made the input histogram. Then this is the after equalization with the clipped histogram equalization method. Then we segmented the input image into the 2 parts. That is the black and white. So when after segmentation, the images will be like this. So we extracted the only beach area by converting into the binary. So when after converting into the binary, we identified some unwanted regions like here. So to remove these unwanted regions, we applied the region of interest, and then we removed the unwanted regions. So for smoothening this ROID image, so we apply the image dilation and erosion for smoothening the 2 intersection lines. So at the end, we received the 2 intersection lines like this. The intersection line between water, sea, and the beach and the land. So this is when we overlay the extracted shoreline on the satellite image, it will be like this. This is the Mulki Pavanji river mouth area. This is the Netravati Gurupur river mouth area. So when we see the complete 40 kilometer stretch study area, so this is the Mulki river mouth area. This is the Netravati Gurupur river mouth area. So when we compare this with the GPS tracking on the same day when we acquired the satellite image from the NRSC, so we received 99.27% of accuracy. The remaining percentage we are thinking we lost because of that there are some inaccessible areas along this coast. So due to the sea wall or there is some strong bushes. So due to that we couldn't track the GPS properly. So we are feeling that we missed the remaining accuracy due to these reasons. So when we compare the shoreline change rates, we applied the SAS method, shoreline method. So this is the Mulki River mouth area. So we compared with the 4 years shoreline changes. So when we compared, most of the sediment accretion will be applied appeared on the Hejamadi Kodi beach and Hejamadi Kodi sand spit. And Sasitulu and Sasitulu beach has shown the less amount of the sediment accretion. So when we compare with the Netravati Gurpur river mouth area, so Bengre spit has the most amount of the accretion, and Ullal spit is completely under erosion throughout the year due to the continuous seawall over here. And there's a Bengre spit, there is around 750 meters of the breakwater system is constructed to control the sediments transportation from this river mouth to the NMPT port area. So that was observed over here. Accretion has appeared only on the Bengre sand spit, and the erosion is completely on the Ullal sand spit. So coming to the suspended sediment transport. So first we applied the false color composition for the band 5, 6, 7 of the IRS-P4 ocean color monitor satellite images, and then false color composite 2 for the principal component analysis images. So we consider the PC2, PC3, PC4 images, and from these images we generated the FCC2 image. So FCC3 was generated from PC1, PC2, PC3 images. So these are the principal component of the ICP4 OCM data. So this is a 8-bit data, so 8-band data. So 8-band images information will be compressed into the 4 bands. That is only in the first 4 principal component images: PC1, PC2, PC3, and PC4. PC1 represents the Iceland spits creeks, PC2 represents the distribution of sediments, PC3 represents the current movements, PC4 represents the coastal geographic features. So by using these 4 components, we generated FCC2 and FCC3. So FCC1 was directly generated from the OCM data, OCM satellite image. So with this, we used the flow method. So first FCC1 generated from the ocean color monitor data. Then we applied the median filter and the filtered histogram received. Then we identified the global maximum values, and we measured the mean of the global maximum values, considered that as a threshold value, and equalized the histogram. And then we normalized it. The normalized image is added with the FCC2, which was generated from the PC2, PC3, PC4 images. Then we used this merged image for the suspended sediment distribution estimation. So this is the, based on the color and tonal changes, we measure the movement of the sediments along the west coast of India. So the main drawback from this method is this satellite image is a 360-meter resolution. So the confluence width of this Netravati river mouth is around 290 meters. So the complete river mouth is covering in the 1 pixel. That is the main drawback. Now we want to convert this entire method in for the drone multispectral satellite images. So when we compare the sediment concentrations in the in situ data collection, so we received around 98.83% of accuracy from this method. So next one is land use land cover accuracy assessment and cover assessment. So we use the first principal component analysis method, and then we use the clipped histogram equalization method for this. So first we generated the false color composite for the land use land cover mapping. So first we generated the PC1, PC3, PC4 from the IRS satellite image. So histogram of each PCs, then global mean of the each PC, threshold we measure, identified, then equalized the histogram, and we generated the contrast histogram of this image. We done the layer stacking of all the PCs, and that will be for the FCC. False color composite will be generated from the layer stacked principal components images. Then that images will be used for land use land cover. We applied the maximum likelihood classifier under the supervised classification algorithm. Then we measured the accuracy of the classification. For easy understanding, we divided the study area into 3 areas, that is Mulki Pavanji river mouth area, NMPT area, and Netravati Gurupur river mouth area. When we come to the Mulki Pavanji river mouth area, this is the general classification method direct from the satellite image. This is the after clipped histogram equal classification to the clipped histogram equalization enhanced methods. So we identified most of the misclassification when we used the enhanced image. So when we see in the beach area, there is a complete sand here. So but the sand area has more in the enhanced image, and there are the white portions and the open areas are identified in the enhanced image. So there is more misclassification appeared in the NMPT area. So this is the most of the industrial open area identified in the enhanced image, but that was misclassified in the general method. So same thing in the Netravati Gurupur river mouth also area also. This is the almost the mixed vegetation area. So here most of the misclassification appeared. So this was overcome by the enhanced image. When we compare with the accuracy assessment, the normal directly supervisor classification on the satellite image, it was 75%. With the enhanced image, with the supervisor classification, it is 85%. Almost 10% of accuracy has increased in almost all the 3 areas. So this is the achievement from this model. So there are some concluding remarks. So now I would like to go to the list of ongoing projects at Kumamoto University. The first one is developing geospatial models for rare plant distribution and mapping, developing Internet of Plants devices, fusion of multispectral camera and spectrometer data, developing hotspots and cultivation areas, an integrated plant crop monitoring system using UAV, artificial intelligence and IoTs, smart aquaponics system architecture using IoTs. The first one is developing geospatial model for rare plant distribution and mapping using NDVI sensor, UAVs, environmental data and field data. So this is the general flow diagram of the developing geospatial model. Like we use the environmental data and field data, NDVI sensor data and base maps, field survey data like a UAV with multispectral data, and we create the geo database, and then we apply the statistical analysis to generate the final distribution map, and also vegetation indices to measure the plant growth estimation, disease identification, chlorophyll estimation, nutrient estimation, yield estimation, and biomass estimation. So we use the Inspire 2 UAV with Parrot Sequoia, one multispectral camera is a 4-band multispectral camera. The reason behind to select this multispectral camera is this camera has the special band that is called red edge band. It is between the red and the near infrared region. So there's a reason we selected this multispectral camera and fix it to the Inspire 2 drone image, and we make the automatic flight through after selecting the field area. Then we generate the maps like this. Is a green band, red edge band, and NRI band. So these are the specifications of this camera. So another one we use the Centera multispectral camera. So this gives the this has the 2 bands. There is a red edge and infrared. So mostly to generate the NDVI NDVI and other indices, we use these 2 images. That's why we selected this Centera multispectral camera. So this is the plant monitoring using UAV. This is the flow of the how to process the UAV data. Like first we go with the drone platform, image acquisition, plant post imagery process, selection of area of interest, plant features extraction, and vegetation indices. So we have all the softwares, the license in our laboratory. So I am the head of the remote sensing center over here. So we selected these softwares based on the our research. So we are using all these softwares to measure these indices. So this is an image acquisition in the different locations, mainly for the medicinal or rare plant or useful plants in the mountain regions. So this is another area. These are different areas. So this is the processing of drone image. So this is like a flow diagram. So this is the one plant called Lily. In Japanese it is called Ubayuri. So this is our target plant. So this is the area of interest we selected from the orthomosaic image. So we extracted this plant surface feature, only surface leaf morphology for we selected by using the area of interest. Then we applied all the vegetation indices to measure the chlorophyll content and biomass yield of this plant leaves. We identified and measured the applied the various vegetation indices to measure the parameters. So this is the way we use the drone images for the medicinal plants. So this is the NDVI sensor. So this will give the incident energy and the reflected radiance. So this has the two sensors. So we use the two, and with a particular 30 seconds interval or the 1 minute interval, we select, we measure around 100 to 120 readings in the particular plant. Then we average of that readings with 30 seconds or 1 minute interval. Then we compare that with the UAV images, which were calculated from the NDV, UAV multispectral images. So then we will check how much the difference between the sensor data and the satellite images data. So this is the field data collection with the different soil, pH, hardness of the soil, moisture, like that. So these are the different plant features to measure using the drone. This is the one plant called Cyosagin. This is the different, very difficult to identify this plant in the normal days. After flowering only we can identify this plant based on the flowers. So we survey this plant when it is flowering that season only. So second project is developing the IoTs based on Internet of Things. So we developed the IoT device based on the 5 sensors. pH, EC, temperature is the one sensor, and solar radiation, pyrometer, and photosynthetically radiation, and rain gauge to measure the rainfall. And one other sensor is temperature humidity sensor. So by combining these 5 sensors, we developed the IoT device, and we connected to the cloud server, and we received the 30 minutes interval. We received the data in our PC or our iPhone. Initially, we collected this to the battery, so that is only for the 25 to 26 days duration. So later on, we connected into the solar panel for the continuous 4 months or 5 months to monitor the complete crop duration. So we connected with the solar panel and we succeeded in that, and this was the data we received continuously for the different parameters like pH, electrical conductivity, soil moisture, soil temperature, humidity, pyrometer, parameter, atmospheric temperature, and rainfall, like this. So this is an interesting project. So instead of using the spectroradiometer to measure the reflectance of the plant features, so we came out with an idea. So anyway, we have a good multispectral cameras like Parrot, Sequoia, and Synthera, and there are new multispectral cameras also coming for the drones. So why we can't measure the reflectance, physical reflectance of the data at the same time when we acquire the aerial data? So with this concept, we came out with this project proposal, and we submitted this project to the Hirata company. Generally, they made the robots and drones in Japan. So they agreed, and we started this project. It is under development. So this is the multispectral camera. We fix it generally to the drone, and in the front side, we started fixing to the spectroradiometer to measure the complete spectral reflectance value of that particular image or particular capture, we can say. So developing hotspots and cultivation areas for the conserving rare and useful plant resources, the project 4. So here also we are using the UAVs and field data and IoT devices. First, we investigate and collect the data of the different plant features, and we will do the data analysis and we start the area cultivation. So we selected some area for the cultivating, that is in Miyazaki, Hyuga city. So first we go for the personal investigation of the habitat plants. Then we identify the targeted plants, and we will we collect the soil data and the environmental data of that particular location, and we also collect the soil samples from that location, and we install the IoT devices in the natural habitat, and we receive the data for 1 year or 1.5 years. Then we prepare the samplings for the those particular plants, and we select some area near to the city or near to the village, and then we start developing that area with the same environmental conditions and soil conditions, and we start the cultivation. And after start cultivation also, we install the IoT devices for monitoring the environmental conditions and soil conditions with the same natural habitat. So this is the IoT device installing. This is the before, and this is the after starting cultivation. So this is the habitat suitability for complete geospatial model we follow. And this is the results we received. This is the drone image, and after image acquisition, we orthomosaic, and then we also prepare the surface model. So we are not used in this case study. We have not used the surface model. We directly extracted the study area, and then we checked the reflectance characteristics. So then we identified some the density plant resources and plant locations. In the densile plant locations, we collected the soil samples, and then the same soil characteristics were introduced to the entire study area, and then started the cultivation. After started cultivation, also we installed the IoT device to continuously monitor the field information. So the fifth one is the integrated plant crop monitoring system using UAV AI IoT for sesame cultivation and barley cultivation. So this is the complete flow model we use for the plant monitoring system, integrated plant monitoring system. This is a UAV data. So we received the multispectral images and RGB images from the UAV. So we prepare the vegetation indices. From the vegetation indices, the data will be used for the machine learning processes, and then we measure the plant height, count, health, leaf coverage, biomass, chlorophyll distribution, and analysis. Here we use the IoT data also. So all the same parameters we use, and we will process through the machine learning techniques, and we will measure these parameters. And this is where just we use sometimes for the selecting the suitable land for developing the cultivation areas. So this is a general model. So just I want to show the sesame cultivation project. So we selected 4 different kind of sesame within the 4 different plots. It started in last year. So it is a 3 years project. I cannot reveal all the results of this project. I will show you some of the results of this project. So this is a selection site 1, site 2, site 3, site 4 from the drone images. So this is after preparing the NDRE, VARI, and the TGI vegetation indices for measuring the different parameters, height, biomass, like that. So all the 4 locations we've done this, and these are the soil samples we collected, and these are the soil parameters. Chemical analysis we did, and these are the chemical analysis data of the soil. And these are the growth of the growth profile of the every month in the 4 different locations. So everything is in the centimeters. So almost from June, we started samplings in May, and we ended in September. So almost every month, 2 times we measure the growth stage of the plants. Almost 8 times we measure the growth of the sesame. So finally, we estimated the yield by using the AI techniques and from the satellite images. Sorry, from the drone images. And next one is the barley cultivation project. So for this, we selected the 4 locations again, 4 sites, and the Koshi city, just 1 hour distance from our campus. So these are the 4 locations we have selected for the cultivation of the barley. So these are the data collection in the different months, to different growing stages. We also collected the NDVI data around 1.5 meters to 2 meters height. We measured the NDVI sensor data, and we also collected the aerial data using the UAV drones. So these are the complete field investigation using the UAV, and these are the specifications of the sensors we used for the spectral reflectance sensors and Centera sensors. And
Professor Raju.
Yes.
I think
yeah, I'm going to wind up in another 2 minutes. I think 1 minute.
Your talk is quite interesting, so we also just get along with that. So, but looking at the time.
Yeah, just 1 minute I can wind up. Yes, almost. Yeah. So these are the different vegetation indices we measured from the drone images, drone multispectral images to measure the height and biomass, and here we measured mainly the biomass and chlorophyll from this barrel. I'm not explaining all the details, all the other devices we used, because it is an ongoing project. I have some restrictions from our laboratory. So the final project was this, developing the smart aquaponics system based on the IoTs. So this is we have the aquaponics system at our laboratory, at our campus next to our laboratory. So this is a very small 3 columns and just around each column is 3 meters, around 9 meters of this 9 meters length of the aquaponic system. But I visited one of the aquaponic system. It is around 50 acres to 100 acres, around between 50 to 100 acres between. So it's a huge aquaponic system, and it's very difficult to monitor this aquaponic system manually. And the plants they grow is very sensitive. If any parameter of water will change in this case, so the entire aquaponic system will be, and the plants will be get damaged within no time. So for sensitive monitoring of this kind of aquaponic system, we came out with an idea as that smart aquaponic system with IoTs. So here we used various sensors which are very useful to continuous monitoring system. And we also started using the drones for monitoring of this kind of aquaponics. So we started using the drones with 2 more times in a month with the fixed height and fixed path every time. Just I go to the place and open the door and start the drone with the same fixed path, and then after that we connected to the PC and we measure which plant is has some damage, and within no time we can do everything with our PC. So that is with the UAV. This is with the IoT sensor. So each corner we started fixing the 2 IoT devices to monitor the water quality for in this entire aquaponic system. Around 15 devices we fixed so far, and we succeeded in this project. And this IoT is already submitted for the patents. And but before that only we started marketing these IoT devices. I'm very happy that I am the one of the principal researcher in this project, and I'm very happy to share this with you. And also the coastal models also we applied for the copyrights. We are going to receive the copyrights very soon. And now we are going to improve those models with the UAV images, and in collaboration with ICACE in Hyderabad. So soon after that we are planning to make a software tool for identification of the automatic shoreline models. Then after that we may think of the patenting of that. Thank you for your patience and time. Thank you. If you have any questions, you can have the time. Please proceed.
Yeah, thank you, Professor Raj. It was excellent presentation, and you started with the very basics and took us to very latest emerging areas where the research is being happening. So quickly, I think there may be several questions, but we'll restrict 1 or 2 questions on the forum. If at all, we can allow 1 or 2 questions, and later, and they can have interaction with you. So, any questions on the platform from the participants?
Sir, co-chair Sivashankar sir is also joined.
Yeah.
So we welcome him also.
So welcome, co-chair.
Professor Sivashankar sir. So well, sir. Well, in that case, thank you so much.
Dr. Aslam.
Yeah.
Dr. Sivashankar.
Yeah. Okay, now I think he's doing excellent work. And
how are you, sir? Guru Garu, how are you?
Fine, Raju. How are you? So I'm very proud
with all
to
your
say.
blessings.
Yeah. Okay, no, I think we have to
say. Sir, I'm proud to say. Now the Raju is my student. So I'm proud to say now he is giving for the excellent advanced techniques, explaining for the all the discipline, coastal disciplines and current aquaculture, this agricultural sector also, how to using for this space technology. So Raju, how are you?
Doing good, sir, with all your blessings.
Right, fine.
Sivashankar sir, I think we have to stick on to that time. So I think there are no questions.
Yeah. Okay.
So let me invite the second speaker, Dr. Ajit Singh.
Yes, sir.
Yeah, he's here now.
Yeah, he's already here, sir.
Yeah, please.
So I take the privilege of inviting the next keynote speaker for today's session, Dr. Ajay Singh, who is a professor at CWM, Central University of Jharkhand, India. I welcome you wholeheartedly, sir, for this session. Thank you for joining with us. So before that, I would like to give a small briefing about his profile. Professor Ajay Singh is an accomplished agricultural engineer and pursued MTech in irrigation and drainage engineering from GB Pant University of Agriculture and Technology, Panat Nagar, and received his PhD degree from Shiats, Allahabad. Currently, he is a professor in Department of Water Engineering and Management, Central University of Jharkhand, Ranchi. He has made immense contributions in the areas of irrigation water policy and governance, modeling of hydrological processes, application of water irrigation model, urban drainage design, micro irrigation, and groundwater hydrology. He has published many research papers, written books, and edited many books, and he is the recipient of Distinguished Services Certificate in the year 2012 and conferred by ISAE India. He is the editor-in-chief of Journal of Water Engineering and Management Journal. He has been Dean Students Welfare and Chief Proctor and demonstrated his leadership quality. Sir, we are really honored to have you with us. Sir, you can now start sharing and kindly go ahead with the presentation. Over to you, sir.
Yes, is my screen is visible?
Yes, sir.
Okay, fine.
Sir, can you make it a full screen, sir?
Full screen slideshow?
Yes, sir. Yeah, slideshow.
Oh, okay. Is it fine?
Yes, sir. Yeah.
Okay. First, let me thank the KL University for giving me this this opportunity to present a topic on the water policy and governance before this great audience. I must appreciate the effort of especially the young professors of the Department of Civil Engineering of that KL University. It's really a very hard work to organize any such programs. That today my topic is that water policy and governance. We have started working on this this aspect for the last 2-3 years, because this any initiative towards change in the water policy can be of a great help to just manage the water resources. And as we know that India is suffering from a worst water resource crisis in its history, and almost billions of livelihoods are under threat. Currently, 600 million Indians face high to extreme water stress, and about 2 lakh people die every year due to inadequate access of safe water. The crisis is going to get worse. And as per one estimate, by the year 2030, country's water demand is projected to be twice the available water supply, implying severe water crisis, scarcity for the hundreds of millions of people, and eventually a loss of 6% of the GDP. As per report of National Commission for Integrated Water Resource Development of Ministry of Water Resources, the water requirement by 2050 in high use scenario is likely to be around 1180 BCM, or where the present day availability is 695 billion cubic meter. Therefore, there is a need to deepen our understanding of water resources and uses, and put in place the interventions that make the water use efficient and sustainable. There are several techniques which are used to manage water sources, and water policy initiatives or any change in the water policy can also affect the water use scenario of India. So let me go through the slides. That my voice is clear.
Yes, sir.
That's fine. So screen and the voice side, there is no issue. So this is a report of CWC, which was published in 2013. And if you see the last two columns, your agriculture water demand is going to be reduced by the year 2030, but industrial and the domestic demand are almost going to be double, and the remainings are around 7%. So this is the scenario of this water, and especially the urban areas are facing a strict crisis during a particular month of a year. This is quite obvious. So with less amount of water available to the field of agriculture, so agriculture water management is one of the most important area where lots of intervention is required. And yes, we are doing that. And if you see the water availability in India, that has fallen from 5177 meter cube per year in 1951 to 1463 by the year 2014. And if you see the current status, this has gone down further. So immediate intervention is required. Niti Aayog, they have developed an index. They have developed an index to just bring awareness in the field of water management. That is called Composite Water Management Index. And if you see, they have developed 8 to 9 indicators, and based on that indicators, these rankings have been done. This is for the year 2017-18, and Gujarat is ranked number 1 with a score of 75. This score is out of 100, and there are a number of things in which water policy and governance is also one of the theme to just rank the states on different points. So 15% weightage has been given to water policy and governance. If you see the lowest state in the northeastern India is Arunachal Pradesh with 22. So these figures are shared with all the state governments just to think about the existing water management approach or the way how they are creating the water resources. The key findings are that these states, Uttar Pradesh, Bihar, Jharkhand, Odisha, Delhi, Rajasthan, they are on the lower side, but 48% of the population they are sharing, 40% of the agriculture produce, and 35% of the economic output are um, shared by these states, and all these states are very low in the ranking. If you see, okay, I don't know how to go back. So the report cautioned that urban hubs are likely to witness severe water shortages in the future, and this can hamper the growth in the urban areas. So urban water management is also that another aspect where we need to intervene. Since I have been, I'm supposed to talk on water policy. So water policy domain deals with the governed and the public action in water governance regime. So these are all the basic definitions of what water policy can address: formulation and implementation of interrelated top-down and the bottom-up policy instruments for the management and development of water resources system. So basically, what I will deal in this lecture is all the three national water policies and their main provisions, how they have deviated over the years, and then in which area almost all the states we have studied the eastern states and the any states. So I'm not having any idea of this southern states, how they are implementing the different provisions of national water policy. But we observed that almost all the states have failed to implement different provisions of national water policy. In this lecture, I have taken three main areas of recommendation, and then we will try to see why we have failed to implement the different provisions. So in the next slides, now if you see that national water policy was initiated in the year 1982, and the first water policy was adopted in 1987. Actually, a draft is prepared in which few academicians from the IDs were there, and this draft used to go to the National Water Resources Council. This council is chaired by the Prime Minister, and then in that meeting, our national water policy is approved and adopted. So you see that first national water policy was adopted in 87. This was severely criticized because almost all the state governments complained that there was no consultation with the stakeholders which are going to implement the different provisions. But later, NWP 2002 accommodated the idea of water as an economic good. So this happened that because World Bank started taking that water as an economic good in 1992, and then it was included in our national water policy also. Now, if you see the main difference of national water policy 2012. So 2012 did not mention about the water allocation prioritization, because earlier in 1997 and 2002, if you read the national water policy, which is available in the Ministry of Water Resources website, there are 5 the different areas which have been prioritized. So of course, the drinking water is at number 1. In 2002, one more priority was included, that is environmental flow. And in 2012, it was removed. So the NW National Water Policy 2002 did not mention about the water allocation prioritization, which was the key provisions of 87 and 2002. But again, it was emphasized that water should be treated as an economic good. So now I will go to three main provisions of national water policy and then see how. So I have taken that water pricing. So water pricing, if you see it critically, then drinking water pricing and that water which is given to the industry are priced fairly. But if you talk about irrigation water pricing, so lots of deviations are there within the states, because though all the national water policies recommend that there should be a fair that irrigation water pricing that should include the cost of the water, but if some states have implemented it, it's not been revised appropriately. So there are so many issues, but somehow even if you see that any states, northeastern states, they have adopted even national policy very late. Some of the states have adopted NWP in 2017, 2019. So almost the main provisions of NWP was as such incorporated in the state water policy, because the water is as such is a state subject. So state government is supposed to evolve, to formulate its own water policy, and national water policy is just a broad guidelines. They have the freedom to include the local needs of water issues. So 2012 indicates that water pricing would ensure its effective uses and would encourage efforts in water conservation. It was 2012 that envisioned the need for an independent statutory water regulatory authority to be set up by each state. Now here also we found that only Odisha government has set up a regulatory authority which is responsible to fix and revise the water pricing for different stakeholders. But even if you see in Odisha also for irrigation water pricing, the last revision was made in 1992. Now you can think we try to get the data that how much revenue they are generating against the bill raised, but this was not available on the website also, and very few state governments were willing to share those data. Now, if you talk about the Jharkhand adopted the national water policy in 2011, and till date they have not formed any statutory water regulatory authority who will look into the water pricing. They in 2015 or 16 they made an ad hoc committee just to look into the different aspects of the water pricing. So that's very unfortunate. But we studied Odisha, Jharkhand, Bihar, and then all the any states. We found Odisha has done fairly well. There is a considerable deviation in the norms and practices followed for the collection of irrigation water charges also. This differs from the states to states. In some states, assessment as well as collection of irrigation water charges are managed by the irrigation department. In some states, this was done by the revenue department, and in few states, this was done by both two departments. Irrigation department used to raise the bill, and revenue department used to take the charges. So there are also states where no irrigation water rates are levied, and so no mechanism for collection of water revenue exists. So this is what about the water pricing. Now the average revenue realized assessed during 2001 to 2007 to 8, it was around 0.86% to 92.14%. Assam was found to be 0.86%. Bihar 7.73%, and Odisha was good 61.66%. Maharashtra is good as far as this revenue collection is concerned. Okay, so the rates of flow irrigation is, in respect of non-cash crops are fixed at roughly 6% of the gross income from these crops and about 12% of the gross income from cash crops. Now the problem is that how you will ascertain the gross income of the farmers. If the farmers sell their produce at a local cooperative, all the produce are accounted, then only you can ascertain the gross income. Otherwise, it's very difficult. It's up to the farmer to declare their income, and based on that you can take the charges. So that may not be a very sound practice unless the farmers are motivated to sell all their produce to a designated center where the account is maintained, that what is this income, and accordingly you can charge the prices. In 2002 and 2012 National Water Policy, all the time it was mentioned that we should replace the area-based or the crop-based water pricing system by this volumetric system of irrigation water pricing, but no such visible steps have been taken by any states in this direction. Though we can understand that to develop a full-fledged volumetric pricing system in India, we require huge investment. That's fine, but that my point is that if the task is used, if we have not so much fund to invest, then why to include such type of recommendation in the national water policy? To me, it seems that if we manage the revenue collection mechanism in some sort of that mechanization we can introduce into that system itself, I think we can generate lots of revenue from that area. So as far as volumetric system of irrigation water pricing, this can be implemented to the area which is irrigated by the ground. This I got recently. This is not the work of our part. Now, if you see it on the y-axis, there is the recovery. This is the gross receipt from water tariffs. This includes all the tariffs, not only that irrigation water price, that irrigation pricing. So nationwide is the black thick line indicating, and we see that Haryana, Karnataka, and Andhra Pradesh, they have done fairly good. Now the first provisions of national water policy we discussed, it was water pricing. They have very clear-cut recommendation regarding water pricing, that it should be charged on this basis, or it should include the cost of at least operation and maintenance. OM cost should be included in your water pricing structures. But as far as irrigation water pricing is concerned, there are lots of issues, and there is lack of will to implement those provisions also. The reason may be the political, maybe the lack of proper infrastructure which are not in place, maybe the lack of expertise in the revenue department or the irrigation department, or how to raise the bill, how to receive the bill. So to me, it seems that some sort of computerization or the mechanization or the use of mobile can be thought to be implemented in these areas. Second important provisions of the national water policy is integrated water resource management. This is a very kind of a buzzword that everybody talks about, integrated water resource management, even integrated effort also. But we find it very, I don't find any integrated effort even within the university or the institutions. Everybody works in isolation. And the idea is good. We need a very strong leadership which can bring all the good people at one platform. But normally this doesn't happen. So National Water Policy 2012 encourages to apply the principles and practices of integrated water resource management to transform the nature of overall water governance and management. Actually, this idea was brought by Europe, and even in Europe also, I think there is a few, one or two river basin where this IWRM has been implemented in total. There also they are not able to implement it. Now the approach considers watershed as a basic unit, watershed or the catchment or the river basin as a basic unit for this managing available water resource system. And IWRM offers a mechanism for coordinated effort for the planning of water resources, which aims to allow effective, equitable, and sustainable use of water supplies available in the river basin in order to ensure water health, environmental protection, and the ecological sustainability. So this complete implementation of IWRM approach, I'm not saying that this is not being practiced in any part of India. Maybe one or two or few river basin, this has been implemented. But practically, this is absent in all the eastern states of India. Odisha made an effort. Odisha made an effort to implement IWRM, but that was not implemented due to interstate dispute. They tried to make a body for this Baitarni River Basin, and Baitarni River Basin is interstate river basin which is shared by Odisha and the Jharkhand. So,
Professor Ajay, sir, I think
yes.
your time is almost getting over, and we have speakers
Yes.
waiting also, so you can.
Time is over.
It's almost over, I think. Half an hour is allotted.
It's in half an hour now.
Ah, yes.
Okay, fine. I will just take 5 minutes more. So complete IWRM approach is missing. The only thing is that government of Odisha, they made an effort, but just because of the river basin was shared by the two states, and there was lots of problem. Setting up of river basin, that organization, this is the third provisions of national water policy which I have taken. This was advocated by all the three national water policy. To elaborate, see, 1987, it was mentioned under clause 3.3. In 2000. In 2002, it was again mentioned in class 4.4, and again in NWP 2012, that the provision of RVUs were mentioned in class 2.3 that appropriate legislation is required to be brought up, which could pave the way for establishing the basin authorities. So this was passed in 2012. Today is 2021. So nothing considerable steps or the improvement we are seeing. But you say initially after independence, we had the concept of river basin organization, but that was known as river authority. So that was largely dominated by the engineers, and later these were mandated to initiate the irrigation projects, and then it was said that holistic concept of river basin development will be promoted, but that didn't happen. That didn't happen. Even the Odisha government, they have made an river basin organization, but again, there was an issue with the two state governments. Yes. So the reason for this is very important. The reason for non-formation of RVUs, this was shared by that one of the very able engineer of Water Resources Department of Government of Odisha, that there are public resistance, not understanding the basic principle of RVU, acute lack of political will, administrative know-how, limitations, and lack of expertise to handle large river-based organization activities. So these are very important points. To my side, there are a few main points. Number one is revenue collection records are very poor except Odisha. Water pricing has not been revised frequently, and no water pricing regulatory body is constituted as per the recommendation of NWP of India in 2012 by all the standard states of India. Odisha has formulated a good water policy document and is aligned with national water policy. Jharkhand has a policy, but rarely being implemented at the ground level. West Bengal state water policy could not be accessed on its website. All the northeastern states have adopted their own state water policy, but have not implemented yet. Major recommendations of NWP like River Basin Organization, IWRM, and implementation of a structured irrigation water policy are yet to be realized at field level. So there is no progress in the adoption of volumetric water pricing system. So I think this is all from my side.
Thank you, Professor Ajay.
Thank you so much. Thank you so much.
And actually, other speakers are waiting. That's why Jay.
No issue. Actually, I thought that 30 minutes time is less. I thought that's why I have prepared only 12 slides. So I thought each slide I will take 2 minutes. So it will be finished by 25 minutes. Then 5 minutes we can have some interaction. So I would be happy to get 1 or 2 questions.
Thank you, Professor. It was a really an enlightening talk. So just to give awareness, importance for the best management of water resources. I think now we can, since the time is already exceeded, maybe we can allow 1 or 2 questions from the participants. So you can interact with the Professor. Any questions?
Also, I request co-chair Sivashankar sir to give your observation notes in case if there are any.
Professor Shivshankar.
Yes. So the current what is the importance of the irrigations systems and water resources policies is so the professor is well explained. So thank you, sir. Thanks a lot.
Thank you. Thank you, sir. You may
Thank you so much. Thank you so much for giving this opportunity to be before you people, and all the best.
Okay, now I think we can. Yeah, thank you, Professor. I think we can invite the next speaker, Dr. Juri Plado from University of Tartu, Estonia. He'll speak on the short list of Indian meteoritic impact craters.
All right, sir. Just 2 minutes. Let me take a privilege of introducing him. Dr. Juri Plado, who is also a mentor to me and very close associate. I've been really close associated with him from the past 2 to 3 years. Sir, we are really honored to have you with us, sir. Wholehearted welcome on the behalf of Third International Conference on Advances in Civil Engineering. So to brief about his profile, Dr. Juri Plado graduated his bachelor in geology, University of Tartu, 1987 to 1993, and MSc in Applied Geology, University of Tartu until 95, and PhD in Geology in University of Tartu until 2000. Started his professional career in the year 1993-1994 at University of Tartu, Faculty of Biology and Geography, Institute of Geology. Currently, he is working as Associate Professor in Geophysics and Petrophysics, University of Tartu. So he has about more than 200 publications, funded projects, and research and development related managerial and administrative work as well. His areas of interest are ET's classification, natural sciences and engineering, geosciences, Flex classification, P500 geophysics, physical oceanography, and meteorology. Sir, with your profile, it is really understood that you are really excelled in your own field. Thank you so much for joining us, and I will be giving up to you so that you could able to share the screen, sir. Over to you, Juri. Thank you.
Thank you for your very kind introduction, and I hope that my slides are visible from this far distance. No, that is
Yes,
something.
yes, I see your slides. Perfect.
Do you see?
Yes, I see that.
Good. But do you see no?
Now it's gone again.
Now it's gone?
Yes, I
I'll
see
try it once more. Is it there?
Yes, it is there now.
Okay, good. Well, I'm not going to talk about details of the Indian meteorite impact craters, but just highlight them and discuss the possible reasons why there are only 3 proven impact craters in India. Impact cratering is actually a very violent process. So this is why we should keep our eyes on sky and be sure that there are not any bodies approaching the Earth during our lifetime. But the impact craters, which are the results of collisions, they are also economically important. They may host water reservoirs, also energy reservoirs. They are important in tourism, important for the local communities. Some of the craters host economically important ore bodies and precious minerals. Also, studying the process would give us hints for the history of Earth and history of biosphere. Also, on the history of hydrosphere by one of theories. All the water that we have on Earth nowadays has been delivered here by comets, and it takes only about 100 comets to 100 big comets to deliver water here to fulfill all the oceans. The idea that rocks fall on the Earth, the first written idea of that was by Ernst Chladni, who was a German researcher, German professor, and he published a booklet on falling rocks in 1794 already. However, it took about slightly more than 100 years when Barringer in United States proved the impact origin of the meteor, or nowadays it's called a Barringer crater. The impactors, or as we call them here, projectors, they originate from the asteroid belt. Most of them are coming from the asteroid belt, but a few have definitely approached. A few visitors are originating also from outer areas of the solar system, from the Kuiper belt and Oort cloud. The meteorites are well, they may be quite nice. Their composition depends on the origin. There are rocky, stony meteorites. There are iron meteorites and stony iron meteorites. Nowadays, the classification is tending towards the source bodies of meteorites. What happens if the asteroid or comet approaches Earth? very small asteroids with sizes of less than 1 meter in diameter. They decelerate in the Earth's atmosphere and vaporize fully, meaning that, well, happy us, we don't see the impact on the Earth's surface. And by this way, it is told that about 1 ton of extraterrestrial material is colliding with Earth's atmosphere per day. That is a quite big amount. Bigger bodies with a pre-entry diameter of 1 to 10 meters, they fracture it during their flight within the atmosphere. They lose their mass. They may create a cavity in the surface, but they may not. Well, these guys are, we call them meteorites then, once they are found. If the body is more than 10 meters in size, it does not decelerate significantly during its flight. And reaching the surface, a crater-forming explosion takes place. And most important, the meteors, the impacting body itself, does not survive. So it means there is absolutely no sense on drilling or searching the crater floors by for finding a meteorite, for finding a big iron body. That was actually a mistake Barringer made in Meteor Crater. He wasted a fortune to drill the crater. Spent there 20 years and found nothing. It is just because the impacting body gets the highest pressure in the moment of contact, and it almost fully vaporizes and melts, and is thrown apart from the crater. The cratering process is, I told it's a violent process, but it's also, yeah, it's very fast process. So this is a slide of one of the Estonian craters. What happened 0.01 seconds after the contact. There is also cavity forming. In 0.1 seconds, well, the cavity is already significantly enlarged. Half of the second, the crater is ready. So it has its rims, it has its cavity, and after a second, well, some ejecta is still flying apart, but the crater form does not change anymore. Size matters also in this way that well, there are various morphological types of craters. The uppermost one is a small bowl-shaped crater. It does not modify much after the shock wave has run away. But if a diameter of crater grows, if the impactor was bigger and the diameter of the crater grows, the bottom of the formation is not stable anymore, and the material runs from the rims. It runs into the crater and upwards, and forming a feature what we call central uplift. So the size difference between the first one and second one is about 2 to 4 kilometers. It depends very much on the target. So meaning that all craters less than 2 kilometers in diameter are simple bowl-shaped craters with diameters more than 2 to 4 kilometers are complex craters. Another limit is in between 70 and 100 kilometers. So if the structure is bigger than that, the central uplift itself is not stable under the gravity of Earth anymore, and it collapses, forming a ring or several inside the crater structure. So that is called a multi-ring structure. So the multi-ring structures are definitely more than 100 kilometers in diameter, and of course it's impossible to photograph these features from surface. Well, only the aerial photographs, of course, for photographs from outer space may illustrate these structures. For example, this one, Schrödinger crater on Moon, with a diameter of 312 kilometers. A beautiful multi-ring structure with an inner ring showing the collapsed central uplift. Yeah, how about on Earth? Coming back. We have about 210 proven impact craters nowadays on Earth. They are distributed unevenly, as you see from this map. Most of them are located in North America, in Europe, especially in Northern Europe and Australia. In India, they are in this database, which is considered as a best and the most reliable. Actually, there are only 2 craters marked, but actually there are 3 nowadays. So these are Lonar, Thala, and Ramgarh. And compared to the area of India, this number is very low, extremely low. Well, I compare it with my homeland, which is there. Area of Estonia is 72.7 times less, and we have 4 craters. Meaning that there are still many structures to be found in India. They may not be possible. They may be not directly observable, but there are indirect methods to identify them. So why there are so few of craters in India? First, we have to consider resurfacing of the area, erosional processes, sorry, tectonical processes in northern India. Some areas are under the sedimentary cover, meaning that any structure are under the sediments nowadays, or within the sediments, and also burial. Well, for example, Deccan traps have been covered. All the old pre-Deccan features. Well, they may have survived there, but they are out of direct observations. Also, compared with Estonia, our studies of impact craters have been very intensive. There are there are many there have been many enthusiasts in the history who have been enforced or well been enthusiastic, especially after the Haringer's works in 1910, and teaching. Well, in our university, and as I know, it's very few universities in the world where we have a special course of impact radaring to teach young people how to recognize them. Well, shortly about the craters, you definitely know them better than me. The first one, which was proven, was Luna crater. It's really a fascinating structure. I guess it's one of the most beautiful craters on Earth, and deserves much more attention from the touristic side. Its age is still under the discussion, which is definitely quaternary. It's a very young structure, but it can be few tens of thousands of years up to few hundreds of thousands of years. So there is no good material to date the impact. And there is a alkaline lake within the crater as it has been formed into the basaltic rocks. Hala structure, surprisingly, it's a positive form. But here we see the central uplift on this Google Earth photo. Its age is also discussed. It's very old, and its diameter is also not well known. So various diameters are suggested, but it has beautiful outcrops. So there is a hill there representing the central uplift of this complex crater, and various brecciated rocks containing some melt particles have been found around. The impact origin of Thala has been proven by mineralogical features. These are planar deformational features, which are originating only because of very high pressures, and which are not taking place during the ordinary metamorphic events. Ball and quartz. Well, this is not indicative, but it's just a clay mineral within the impact melt, showing that immediately after the impact, hydrothermal processes were active. And there are some shatter cones which are only macroscopically indicative, macroscopically visible indicative feature of the impact. Well, they are not well developed here because the lines are too straight. Well, this one is a classical example of a shatter cone. So it's a cone surface. People often tell that, well, this is a horse tail reminding surface. And only the impact, only the high pressure shock waves are able to produce such features. The last one, which has been proven just a year ago, is in Rajasthan. It's Ramgarh, the crater. There we have a negative form again, but recent studies show that this is also kind of central uplift. The crater has been much wider. Relatively recent, Middle Jurassic, formed into shallow water, and the diameter of this one is about 10 kilometers. There are various fractures within and around the structure. Around the structure, there are concentric fractures. Within the structure, there are mostly radial fractures taking place. That is a cross section of the crater. So the rim walls actually are not well visible anymore as they are eroded, and this lower ponder sandstone has been much more resistant against erosion. And the proof is here. PDFs, planar deformational features along the crystallographic directions. They are represented here. The distance between these fractures is really low. It has to be less than 10 micrometers to prove the impact, and also their directions are usually measured and precious. I guess these are from the rim of the central uplift here. So and the last part of my presentation is going to concentrate on diagnostic criteria. So what do we need to prove the impact? So the first proof would be, of course, if we found fragments of meteorites. They cannot be found around big craters. They can be found around small craters with diameter less than 1 kilometer. Mostly iron meteorites are found because they are most resistant against weathering. The stony meteorites are usually weathered fastly. There are chemical and isotopic criteria. Compared to crust, meteorites contain more metallic minerals, more platinum group elements, and once we measure content of these or any isotopes within the brecciated rocks or impact melts, we see they are different from the composition of meteorites and different from the composition of target rocks. Catacombs, as I told, the only macroscopical evidence of the impact. If you see anything like that, there should be an impact crater nearby. High pressure polymorphs and diaplectic classes. These are mineralogical criteria, can be studied by microscope or scanning electron microscope only. This is coesite polymorph of quartz occurring here. Impact diamonds, yes. If there is carbon around in the target, the pressures are high enough to form diamonds. Well, they are small, but still, girls like them. Micro deformations, PDFs in 3D. As shown here on the right side, and so-called ball and quartz, which is also very indicative, found in this one has been from the Hala crater, found already in 2009. And indicative features. These are features that we should take care, but of course, not all the, for example, circular features are by meteorite impacts. For example, volcanic necks, volcanic craters are similar if you look from upside. Some of the craters are created by human. This is made in 1965 by Russians in Kazakhstan, by Soviets. in Kazakhstan. It is a nuclear crater, which was created just to collect and store water, drinking water. Of course, no one is drinking this water, yes, even nowadays. Any pressures? Well, they can be tectonic as well, but we should pay our interest on these. Melts. Well, a beautiful example from lunar crater. Just an impact melt, melted basalt. Melt fractures here in Sudbury. From biggest crater in Canada, and that's it. Of course, if you see something like that, it deserves attention. Thank you thank you a lot, and thank you for inviting me. I hope there was some good out of this short overview.
Thank you, Dr. Jury. I'm very happy to chair this session, being our collaborator. And it was a very wonderful talk. And you have taken us from craters to extraterrestrial materials. A really inspiring talk. And the floor is open for discussion. The participants can ask any questions, and we can allow questions.
Excuse me, sir.
Yeah.
Hello, Dr. Yuri. I have a question.
Hello.
Actually, hello, sir. Yes, sir. I was hoping if you could shine some light on the theory which suggests that the presence of water on Earth is actually the result of all those meteorite bombardment that have happened in the past.
Yeah, well, just send me your contact, and I will send you the articles which are claiming that according to theory, according to distance of Earth from the sun, there should not be water on Earth. That is a problem now, and well, we should be deserted like Mars. But also it's very difficult to study water in its historical sense, because it does not carry any memory. Yes, well, that is a suggestion, and it has not been proven yet, of course.
Okay, sir. Thank you, sir.
You're
welcome.
Yeah, Suraj, I will help you out in getting the Yuri's contact.
Yes, sir. Thank you, sir.
You could write to him if in case you need some more information. Yeah. Thank you so much. So, Professor Aslam, shall we go ahead?
Thank you, Dr. Jury. So hope we'll meet again soon. And it was really nice, inspiring, very powerful talk. Thank you, Jury. And now I think we'll go for the next speaker, or shall we call the...
Yeah, so the next speaker will be joining in a moment, like in another 1 hour. So meanwhile, we can start up with the paper presentation, sir.
So you can call the respective paper code,
yes.
or...
Yeah, I will be calling upon serial wise. So if they are present, they will be raising their hand. So dear participants, we are going to start the paper presentations right away from this moment. So to begin with, we have paper ID number 24. So is Kirti Priya Kasturi. All right. Kirti Priya Kasturi, paper ID number 24.
Are you there? 24.
Paper ID number 24. If you are there, please respond.
Otherwise, you call upon the next one.
Yeah, paper ID 108.
Call
Anand
them.
Raju.
If not respond, then call the next candidate, and at the end we'll give time.
Yes, sir. Yes, sir. Yeah. So Anand Raju.
Yes.
Anand Raju, are you there?
Looks
I can
like
see Anand Raju. Yeah, I can see Anand Raju here.
maybe he muted his mic, I think.
Yes, yes, yes.
Please
Anand Raju, I think right now you can able to speak and present. Start your presentation.
Please unmute and you speak.
Mr. Anand Raju.
Yes, sir.
Yeah, yeah. So are you ready with your presentation? You can start sharing.
I please stick on to the time. We will not give any extra time. Okay, kindly adhere to the time which is allotted.
Sure, sir.
The next in the list will be paper ID 46. So I request you to be ready, paper ID 46, after Raju's presentation. So Anand Raju, please share your screen.
Yes, sir.
Is audible?
Yes.
Hello.
Please.
Yes, sir. So good afternoon to one and all. I'm going to present my paper on the topic GIS and network analysis based tourism asset mapping for Ambo and surrounding town Ethiopia. So myself Anand Raju and I have my colleague Haptamu Atoma. Hello. Sir, could you see my introduction slide?
Yes, yes. Please start.
Hello.
Yeah. Please go ahead. Please go ahead.
Yes, sir. Okay, sir. Thank you. So, yeah, so tourism is one of the major industry which contribute to Ethiopia's economy. So here we have taken the study area. Mainly our objective is to provide tourism asset map to the visitors of Ambo town and its surrounding town through the Ambo municipality. So here we are providing guiding route with direction and time. So the problem statement what we have identified is in the existing map of Ethiopia, there is one of the famous crater lake which is in the place named Wanchi. So in accessing Wanchi from the Addis Ababa city capital, the existing map doesn't show the exact facilities available. Since it is a volcano region, there is no resort or hotel exactly in the Venchi Lake. So our challenge here is how to reach the hotel nearby if the tourist is going for Venchi Lake. And actually the crater lake area is 4 kilometer by 4.5 kilometer wide area. So that is that much big, and so definitely it's a challenge for the tourist people to stay nearby if there is no information available. So these are the challenges listed here. And the study area here is from Africa. The chosen area is Ethiopia. In Ethiopia, the study area is totally 4 towns. Here it is Ambo, Godar, Ginchi, and Wanchi. So the here when we take the 4 towns, one of the nearest town is Godar and Ambo from Wanchi. So here Godar is not that much. Godar town is not having that much facility. So Ambo is
Slide is
taken
not
as
moving,
the.
Raju. I think you are in the.
Sir, sorry.
Your slide is not moving. Slide is not moving. I think you are in the first opening slide only.
Oh, sorry, sir. That's what I was asking because uh, slide. Okay, but. So 1 second, sir.
Yeah, now you can come on to the slideshow mode. Then you go ahead. Okay, we could see some slides.
Yes, sir. Sir, now could you see the slide?
Yeah. Go ahead. Go
Is it
ahead. Go ahead.
visible?
Visible. Go ahead. Yeah.
Yeah. Okay, sir. Yeah. Thank you, sir. So this is the study area, and here is the 4 selected towns: Ambo, Godar, Ginchi, and Wanchi. So you can see the existing tourist map of Ethiopia here. This is for the complete Ethiopia. But if one of the tourists want to visit the Wanchi Lake, Wanchi Crater Lake, which is at the total elevation 3,000 meters from mean sea level. So in order to reach that place from Addis Ababa city capital, there is no proper information available at present in the existing map because it is covering huge area of Ethiopia. Since Ethiopia is famous for many historical sites, religious places. So here, Wanchi Lake, this is the Wanchi Lake, the caldera, which contains hot spring, waterfalls, valleys, and other sceneries. So the elevation is 3,450 meters. And Ambo town is also shown here, the nearest town. So things to do in Ambo, in the trip advisor, there is no information available at this time. And also in another website, you can see there is no information available in tourist website. So here, this literature study is the base here for asset-based community development, which was done in Tibet. So their aim is they have taken ABCD approach, which is asset-based community development. So here, what they have done is they have taken world heritage sites, religious sites, traditional Tibetan yards, daily life and customs like that. So this is the methodology what I have followed for preparing the tourist asset map for both Ambo town as well as the surrounding towns. So we have prepared, we have taken field data using GPS, Garmin GPS, and the data sets were collected using field study. Network analysis and ArcGIS software was used. So coming to the results and discussion, in this community service based research study, major tourism places were selected from Ambo and its surrounding town. So to promote tourism. Already I have discussed the existing gap between the Vanchi and the tourism area. So the final output of tourism asset map was prepared on a scale of 1 in 20,000 for Ambo, and the entire town, 4 towns, on a scale of 1 in 2 lakh, which serve as a local guide map. So here is the tourism map available for the entire surrounding town. You can see here, sir. So this is the map prepared, including Vanchi Crater Lake, the second, the first volcano region, and in Ethiopia, first biggest volcano region, and the second one is Dundee Lake. So which is at a distance you can see, sir, from Ambo, Godar, Ginchi. So this Ambo is at a distance of 1 hour journey, but it is not that much over. So here you can see the nearest town which has the facilities. So we have prepared the map in terms the assets considered here is the palace, masjid, religious places, ATMs, hotels, like that. So using network analysis, the time taken to access the location and the distance is given in the form of direction map. So this is a network analysis extension used in ArcGIS 10.3 version. And here the picture shows the destination between one particular center and the other one. To be clear, this is the place. For example, Dunamis Hotel is one of the famous restaurant here in Ambo. And from the main campus, which is our institute, how to reach that particular place. This is just an example I have shown here. So similarly, there are many reports generated between two places. So this is one of the swimming pool area in Ambo town, and you can see the nearest Ginchi town also we have a recreation spot, which is not available in the existing map of tourism map of Ethiopia. So our aim is to fill the existing gap by providing the valuable information related to tourism to the tourist people who are visiting Ethiopia, and also identifying new spots, such as you can see this bird, sir. Right now this bird is not yet identified, I mean the origin. It may be either North America or China, because this bird actually it is a crane, whooping crane, which is available, which is found in these two countries only. So coming to the conclusion, this map was prepared, the existing maps with emphasis and given due consideration towards Vanchi Lake. So in order to facilitate the tourists, these customized maps is provided, and right now it is not even available in online. Even in the Google, the information is not that much there. What we have included, it is not there in the Google map. So the scope of the study is it can be extended further either online or offline, which we are doing in the next project. This is an ongoing project, development of web mapping for spatial ecotourism information using QGIS and ArcGIS for the West Sheva zone, Ethiopia, which includes Ambo, Gudar, Ginchi, and Vanchi. So this is the future project for which already fund granted and it is ongoing. So these are the references, sir. Thank you. Yeah, any questions?
Now it is open for discussions or any clarifications. I think we can go to the next student, next candidate, I think.
Yes, sir. So paper ID 46.
Thank you.
Thank you so much, 108, Anand Raju. Which is a good presentation. Yeah. So next paper ID 46, Raghavendra Kumar and his team.
Yes, sir. I am available, sir. Am I audible to you?
Yes, yes. You can start presenting. Anand, you can stop your presentation.
I will go and pick him up. He should not mistake me.
Anand, please.
Is my screen visible, sir? Hello, sir.
Yes, yes, you are visible. It is visible. Okay.
How should I remove this, sir?
No, you can just minimize it.
Okay, okay. Yeah, fine. Okay. Good evening, everyone. Myself, Raghavendra Kumar. Now I am going to give my research topic, presentation on my research topic titled Stability Analysis of Directional Tunnel in Sandy Soil. And currently I am a research scholar under the supervision of Senior Professor Rajiv Gupta, and we represent Department of Civil Engineering, BITS Pilani. Is my slides moving, sir?
No, it is not moving. Can you recheck it? Yes, it has moved. Yeah, that's fine. Yeah, absolutely.
Okay, fine. My research work is basically on the water management part, and especially rainwater harvesting in the rural areas and its storage structures. Before going into it, let's check what is the background of the water management scenario in India, where we have a population around 1.4 billion, and we have an expected water demand around 910 billion cubic meters for the year 2025 and 1072 billion cubic meters for the year 2050. Regarding based upon all these things, and also we have improper water management because of the human activities, around 97% of the overall population face at least 1 month water scarcity based in our country. And also, depending upon the different water management practices implemented or the policies implemented in India also, still we are not able to attain total water surplus in the rural areas. And even in the Jal Jeevan mission, which is started by the central government policy in the 2019, only around 34% of the households are getting the water infrastructure. If we see the water storage practices in the rural areas, it is basically of the types like surface water collection, where we collect surface runoff and the groundwater. And the other one is river water storage, where we construct structures like subsurface dams and the water towers. And also policies like accelerated rural water supply program and national rural drinking water program, where the installation of piped water supply, mini water supply and hand pumps has been done in many of the rural areas in India. And also people individually or privately go for rainwater collection by the methods like rooftop rainwater harvesting, percolation wells, and community tank. Since I mentioned earlier, this paper is with respect to the rainwater harvesting and the storage structure with respect to it. Let's see what are the main rainwater type of constructions being followed. That is, the rainwater tanks are basically constructed above the ground and under the ground. And the types of research work which have been carried earlier were the vertical underground tanks with surface which is open to the atmosphere, and with the tanks which is having manhole, and the other one is the ground tank which is laid on the ground below the surface. And also with respect to this, the main disadvantages are basically, first, if you see, when the water is getting exposed to the atmosphere, the evaporation start place. So one after the another, evaporation takes place and the whole water tends to get evaporated, and evaporated water is not good for consumption or domestic usage. And also other disadvantages are like, if you want to construct a big community tank which is focused on any community, you need to dig deeper, and it will obviously tend for the deeper excavation, and also in turn it will lead to large energy requirement to extract water. So in order to avoid all these disadvantages, current research work proposes an innovative method called as directional tunnel, which is located below the ground level in a declined position in such a way that the evaporation can be minimized and also the water can be extracted easily. How this method can be followed, we will see in the next slide. We will see in this presentation. So in this, rainwater harvesting is initially practiced in multiple houses in some selected group, and after the selected group will after the individual tanks will be provided a transmission pipelines. After the storage cap is surpassed, the water from all those individual tanks will be reaching this directional tunnel. Simultaneously, the runoff water can be also collected. In this way, this can be operated. And these are all the parts with respect to it. So this is the plan of it, which is created in order to store 150 cubic meters of water. And this is the schematic plan of the rural water management setup with the directional tunnel installation in one community. This plan is for 6 houses only. It can be even many more houses as it is focused. So before installation of this, we have checked the practical viability, how to install the directional tunnel in the sandy soil. Why we have selected here sandy soil is because this project we want to, this innovation we want to implement in Rajasthan. So Rajasthan is an area where we have most of the sandy soil. And this community was selected in the village Ramnathpura, and based upon that, the numerical analysis for the stability of the directional tunnel has been done by the using software Plaxis 3D. As I mentioned earlier, the directional tunnel is in a declination position below the ground level. So here we are checking for what declination the directional tunnel behaves in an optimized manner with the less parameters of the total displacement and the total principal stress and the total principal strain. We have checked it for the different angles. Here we have taken did the static load, created a static load condition based upon the soil condition for the two layers created, and run the simulation for the different angles. And here I am representing it for the 10-degree declination, and these are the results. First one was the total displacement, and in the previous slide the first one was the total displacement, and this is the total principal stress, and this is for the total principal strain. Based upon all these five declination angles, the values have been interpreted. From these values or these results, we can come to a conclusion that the declination with 30 degree has a moderate total displacement compared to the other declination, and the 30 degrees is having the least total principal stress and the total principal strain. Even though the other total displacement is lesser than the 30 degrees, but the principal stress and principal strain are more for the other values. So we are neglecting it, and through our study, we are recommending as 30-degree declination for the directional tunnel is more suitable for implementation in the sandy soils. So hereby, I want to conclude that rainwater harvesting by directional tunnel is used as the innovative method through our research, and disadvantages like evaporation and runoff water storage can be overcome, and the stored water can be used for both the agriculture and household purposes. And for the sandy soil medium, 30 degrees is the feasible implementation. And this is the case study work carried out where we have done in the selected community in Rajasthan. These are all the assembling of the individual panels, and this is the construction of the individual tank, rainwater tank. And this is the earthwork for the laying of the pipeline. And in this method, the directional tunnel can be installed in the sandy soil for that community. And these are all the references. And I thank BITS Pilani and DST for helping in the research, carrying out this research work. And I finally thank KLU University for giving me the opportunity to participate in this international conference. Thank you.
Okay, thank you, Raghavendra. And now the floor is open for discussion or any queries. I think mostly all are silent. I don't know. Okay, I have one specific question. You mentioned somewhere in your slide that in India, are you audible? Yeah, you
Yes, sir. Yes, sir. You are audible to me.
You mentioned that in India, everyone in India are facing water scarcity problem at least 1 month in a year.
Yes, sir.
But how far it is true?
Sir, it is the statistics data which I acquired, sir. It has been added in the reference in the paper also.
See the genuineness of that report. So that is one
okay,
thing.
Sir. Okay,
Second,
sir. I will check for that.
What
okay.
constraints like here you mentioned about directional layout of pipes, and here but that may consume lot of space now. The other way, we need more larger
It is
space.
below the ground now, sir. It is below the ground, sir.
Below the ground, but it should be wherever we are installing such structures. So the premises should be sufficient enough to accommodate that space now.
Sir, even though we, yes, sir, after that, we are backfilling the area wherever it has been created. And after backfilling the area, we can, as usual, use the area. It is not going to create any ruckus or any disturbance in that area, no, sir.
And for these investigations, whatever you have done, is it done for the same area or in different places? You have listed some 4 cases, I think.
5 cases, sir. 5 declinations I have done, sir. Yes, sir.
Is it in the very same location or different locations?
For the same location only, sir. Why? Because the simulation part, we wanted to test it before only. Why? Because the soil soil layers, whatever we have created, that was based upon the selected location only. That's why I said that it is Rajasthan, sir, because of the loose sand and dense sand properties.
Okay, Raghu. Okay, thank you.
Yes, sir.
We can move on to the next. Someone is asking. Shivashankar sir?
Yes, sir. I'm here. So we'll go to the next one, sir.
Yeah, okay.
So the next
Thank you,
presentation, paper ID 50, Parvati J, Jayamohan and Shruti Johnson. I have already given you the presenter status. Parvati?
Yes, sir.
Yeah,
We are
please,
available.
yes, please share your screen. And Anand sir, can you please stop your presentation and share?
Sir, is the screen visible?
Yes, yes. It is visible.
Good afternoon all. Today our topic is detrimental effect of oil spill on the behavior of footing of nearby structures. Myself, Adira, an 8th semester civil engineering student of LBS Institute of Technology for Women, Trivandrum, and my teammates are Ardra, Janu and Parvati. Is the slide moving, sir?
Yes, it is moving on.
Coming into the introduction, oil contamination is one of the most common soil contaminations. Over 2 million tons of oil are produced all over the world every day, and about 10% is entering the environment due to tanker accidents, pipeline breaks, discharge from coastal facilities, etc. Oil causes a change in engineering properties of soil. These changes may lead to a loss in bearing capacity and increase in total or differential settlement of foundation of structures. Next is the objectives. The objectives are to study the influence of oil contamination on bearing capacity and settlement behavior of footing by varying eccentricity and quantity of contaminant, and to determine the tilt occurring in the footing due to contamination. Now let's deal with the materials and their properties. The first material is soil, which is sand. The properties of sand are given in this particular table, which are obtained from various laboratory tests. The next material is heavy motor oil, that is Servopride 40. The properties of oil are given in this table, which is obtained from the official website of Indian Oil Corporation. Next is model footing. Square model footing of size 10 by 10 by 1.6 centimeter is used for our experiments. Coming into the methodology, for plate load test, sand is filled in a tank of size 1 by 0.75 by 0.75 meter in 6 layers, and each layer is compacted using plate vibrator. Plate load test plate load apparatus is assembled over the square footing placed on the soil, and model plate load test is carried out. Model plate load test then conducted after spilling oil at various eccentricities, that is 0.5 B, B, 1.5 B and 2 B, where B is the breadth of footing, by keeping the quantity of oil constant at 25 ml. Test is repeated by varying the quantity of oil by 25 ml, 50 ml, 75 ml and 100 ml, while keeping the eccentricity of contamination constant at 1.5 B. Load settlement curve and tilt behavior is plotted for both the cases. This is the figure that shows the experimental setup. The next laboratory test was modified direct shear test. The shear test is carried out to determine the angle of shearing resistance and the cohesion. The test is conducted for both clean and contaminated sand. This is the figure of modified shear box apparatus. Next is the relationship between quantity of contaminant and extent of contamination. The relationship between quantity of contaminant and extent of contamination is determined by exhuming the soil after contamination. The depth of collection of sample, corresponding horizontal extent of contamination, and the oil content of collected sample are presented in this particular table. It is observed that the horizontal extent of contamination and the percentage oil content of collected samples are increases with the increase in quantity of oil, and but there is only a slight increase is observed in the case of depth of contaminant. Now let's discuss the result that obtained from these laboratory tests. The first one is influence on shear parameters. The curve is plotted between angle of shearing resistance and oil content. It shows that angle of shearing resistance decreases with the increase in oil content. In the case of cohesion intercept, the curve is plotted between cohesion and oil content. Initially, the cohesion of sand particles increases rapidly with the increase in oil content. Later, the rate of increase in cohesion slightly reduces. Now, let's see what happens to the load settlement behavior upon the influence of eccentricity of contamination. The curve is plotted between vertical stress and normalized settlement, that is S by B ratio, where S is the settlement and B is the breadth of footing. From this curve, it is clear that the bearing capacity is significantly influenced upon the addition of contaminant at various eccentricities. That is, ultimate bearing capacity reduces with the decrease in eccentricity, and the settlement increases with the decrease in eccentricity of contamination. Next is the influence of quantity of contaminant on load settlement behavior. The curve is again plotted between vertical stress and normalized settlement. With the addition of oil, settlement of footing increases. The ultimate bearing capacity is decreasing with the increase in oil content. From 0 to 25 ml, there is a drastic decrease in bearing capacity, but the further increase, the decrease in bearing capacity is almost constant. Now let's see what happens to the tilt behavior upon the influence of eccentricity of contamination. The curve is plotted between vertical stress and tilt of footing. With the decrease in eccentricity of contamination, the tilt increases and bearing capacity of footing decreases. Next is the influence of quantity of contaminant on tilt behavior. The curve is again plotted between vertical stress and tilt of footing. With the increase in quantity of contaminant, the tilt increases and bearing capacity of footing decreases. Now, reduction factor. In order to quantify the result obtained from laboratory tests, reduction factor is calculated. The stress corresponding to 5% S by B ratio is used for the calculation of reduction factor. The curve is plotted between E by B ratio and reduction factor. Up to an E by B ratio 1, reduction factor increases, and thereafter it shows a slight decrease. The next curve is plotted between Q by A ratio and reduction factor, where Q is the quantity of contaminant and A is the area of footing. And from the figure, it is observed that the increase in quantity of contaminant, reduction factor decreases. Coming into the conclusion, based on the test result, following conclusions can be drawn. Oil contamination near to a footing adversely affect the load settlement behavior of footing. Increase in quantity of contaminant and decrease in eccentricity of contamination increases the settlement and tilt of footing. Oil contamination reduces the angle of shearing resistance and increase in cohesion intercept. There is an increase in cohesion intercept. The bearing capacity of clean sand is obtained as 298.44 kilopascal. It is reduced to 186.21 kilopascal when the soil is contaminated with 25 ml oil at an eccentricity of 0.5 B from the center of footing, where B is the breadth of footing. For varying eccentricity of contamination, the maximum reduction in bearing capacity is obtained as 37.6% at an eccentricity of contamination of 0.5 B. Bearing capacity of clean sand reduced to 148.97 kilopascal when the quantity of contaminant increases up to 100 ml at an eccentricity of 1.5 B from the center of footing. For varying quantity of contaminant, the maximum reduction in bearing capacity is 50.17%, which is obtained at 100 ml. The reduction in stress is obtained as 62.99% for an E by E ratio 1 and as 69.07% for a Q by A ratio 1. It is based on the stress corresponding to S by B 5%. These are the references. Thank you. Any questions? Hello, sir.
And now it is open for queries or discussion. Any questions? You can pose. Any questions from the participants? Okay, now Parvati, no?
Atira.
Atira, sorry. So you have made a presentation, good, and you have analyzed the use of oil. How about the other properties like soil properties, moisture content? What way that will have some control during this analyzed?
Sir, we have conducted test on dry sand. The properties of sand is given this particular table by conducting this laboratory test.
Okay. So you are conducted only purely on this uniform material of sand only.
Soil types purely graded sand.
Okay. Okay, fine.
Thank you, sir.
All right. Thank you, Parvati and your team. So the next one in the line is paper ID 215. Razal Mustafa and Dr. Husni Taskuddin. So you are already given the presenter status.
Thank you,
May
sir.
kindly,
could you let me know when you see my screen?
Yeah, sure. Yes.
Is it visible?
Yes, it is visible. Yes.
And it's the slides are changing, right?
Yes, they are changing.
Yeah. Okay. So thank you to the Third International Conference on Advances in Civil Engineering for inviting me to present my paper. The title of my paper is Assessment of Land Use and Land Cover Changes in Selangor, Malaysia, using remote sensing and GIS techniques. My name is Mohammed Firas. I'm the author, and my co-author is Dr. Mohammed Razal Mustafa. We are from Department of Civil Engineering and Civil and Environmental Engineering in University Technology Petronas, Malaysia. So a little background on the paper that I'm going to present is the land use and land cover changes globally has been changing over the years. The main factors that are responsible over this are human development activities, and the increasing population is recognized as one of the main factors that is affecting the land use. It's the same case for Malaysia as well, where the rapid urbanization has changed the land use patterns of the country. Between the years 2000 and 2020, there was around 400% increase in urbanizations. And a little background on the land use and land cover changes before the year 2000. Between the years of 1918 and 2000, the agricultural transformation was the major reasons for the change in Malaysia. So the objectives of my paper are to recognize what are the new land use, land pattern changes, and what are the driving factors in the coming years from 2000 to 2020. So the study area that we have considered for our research paper is Selangor in Malaysia. Selangor is one of the 13 states in Malaysia. It has 9 districts in it. Selangor has Kuala Lumpur and the capital of Malaysia, and the federal administrative capital Putrajaya in it as well. It has the largest port in Malaysia, as well as a very well built transportation system. So the expansion won't be hindered. The total area of Selangor is 8,100 kilometers square, or with the population around of 6.5 millions. The temperature around here fluctuates from 23 degrees centigrade to 30. Tropical environment.
You also start eating Vignesh. It's late for you. I mean, food late time.
Sorry, is there some issue? May I continue?
Yeah, go ahead.
Okay, thank you. So now let's look at the flowchart of our methodology. First of all, we collected the data for the different years for Landsat 5 images for 2000, Landsat 8 images for 2010 and 2020. Our first step was to pre-process the images that we collected, like changing the geospatial formations of it and removing the cloud cover where it was necessary. Then it was run through the support vector machine classifications to identify the different land use patterns. These classification outputs were then run through the accuracy assessment. And after getting the satisfied accuracies, we moved on to analyze the different land use and land patterns that change between the years of 2000 and 2020 and the percentage changes in the land cover areas. So in the SVM classification, we considered 6 classes for our classification. In water, we considered the rivers, the other water bodies and hydraulic structures. The built-up land was the industrial areas, the residential areas, and other developed areas. Barren lands for uncultivated lands, the ongoing construction sites. Agricultural lands consisted of plantations, commercial agricultures and other agriculture. Forest lands were mainly the forests which are mostly dense forests, and wetlands were found in the western coast of Selangor. So here I would like you to focus on 3 major landforms that can be seen in Selangor. This is the land use classification of the year 2000. So the forest covers are mainly found on the eastern boundary of Selangor, whereas the agricultural land is found on the western boundary of Selangor, with the built-up area occupying the center of it. So in the year 2000, you will observe that the agricultural area was around 4,000, whereas forest was around 2,500 and built up around 1,000. The rest barren around 500, water was around 110 and the wetlands were 165. And now the changes that you will observe in 2010 that happened there was a significant drop in agriculture areas. You will see that the drop will happen from 4,000 to 3,000, and this also resulted in rise in the built-up area. You can see that there's a rise in the center of the map as the built-up area expands, and the same thing is continued in the classification that was done for 2020. And again, you will observe that the drop in agricultural areas with the increase in the built-up areas, whereas the forest area remained the same throughout all the 3 decades or the years. Now let's look at the percentage changes over the years. As you will observe from the graph that there was a slight rise in the landform patterns of water, barren, and wetlands, as well as forest. The rise in the water can be attributed to the different construction of hydraulic projects that are taking place in the state of Selangor. And the major changes that occurred are between the built-up areas. In the first period, you will observe from the table, in built-up area, there was a 10% rise in the landform, and that continued in the second period of 2010 to 2020 of 1.34. Yes.
Maybe your presentation slides may be problem. Some other presentation will be coming. Please click on
I think
you want me to pause my reshare my screen?
No, your presentation is not visible now.
Okay, I'll try to re-share my screen. Could you let me know if it's visible again?
Yes.
Yeah, go ahead.
Another thing, which slide was the last one where it stopped, so I could continue from there?
Yeah, this is the one.
This is the one or this one?
This is the one.
Previous one.
The previous one, 2020. Okay, so from the year 2020, as I said previously, you will observe that the agricultural land has been progressively decreasing and the built-up area has been progressively increasing. Now the changes you will observe here are in this graph where the water, barren land, forest area and wetlands have a minute, like a consistent increase over the periods of time. This can be attributed to, for water, the different hydraulic structures being built, the barren, the uncultivated lands as they change over the areas as they occupy different places. The forest has almost remained the same. The slight difference is due to the lack of construction that is happening on the eastern coast, and the wetlands is as you will see that over the years in the coast, the wetlands are increasing slightly. So the major differences are between the built-up area and agriculture. So as from the table, you will observe in the built-up area between the periods of 2000 and 2010, a 10% increase has been observed, which has continued between the period of 2010 and 2020 by 1.3%. And then a significant decrease attributed to that has been seen in agricultural areas, where a drop of 12.2% has been observed between the periods of 2000 to 2010. And that has been continued in the years 2010 and 2020 by 2.53%. Now for the accuracy assessment that we did for our land use land cover classification, the overall accuracy came around 0.89, 0.9 for the years of 2000, 2010 and 2020 respectively. And the kappa coefficient for it was around 0.87 and 86 for throughout the year, so it was satisfactory. The major issue was during the classification was the pixels for agricultural area and forest areas were overlapping each other, because some of the plantations and the forest covers had similar pixels. That caused another issue, as well as built-up area and barren lands were coinciding as well due to the similarities in the landforms. Now for concluding, let's say that the land use and land cover patterns for all the 3 years, 2000, 2010 and 2020 were identified, and the factor that we identified for the rapid transformation was the increasing urbanization and the industrial development that is occupying the agricultural lands to give way to the increasing development. So in easy terms, the build-up plant is taking over the agricultural land for the expansion for development. And the support vector machine classification was very helpful in identifying these patterns in the state of Selangor. For our further researchers, we'll move on to find the different land use patterns and create predictions for the year, for the future years using different ANN and methods. So we'll take the patterns that were done between 2000 2010 and 2010 and 2020, and based on that we'll do our predictions. These are the references for the research, and thank you. I'll open the floor for any questions.
Any questions from the participants?
Yeah. So if you permit me,
Yeah.
So I will. So the presenter you are using for the 2000, 2010 and 2020. So the years land use land cover mapping you've done. Which seasons data you have taken?
Sorry, what?
Which seasons data?
Seasons data. The seasons in Malaysia don't really change. It's mostly tropical. There are two major seasons in Malaysia. It's the summer or it's monsoon. You don't get winter here.
And one more thing, it will be if you want to decide for the agricultural land, it depends on the season based. So the normally we have to go for the in India.
Yeah, so my criteria for selecting the images were to select the images between the months of June and July.
It means only single season data, so you are taken. So it will be how accuracy of your classification.
We have compared it with the other collected data as well. The differences are not major. It's mostly changes. The main issue while collecting this data is finding images which are suitable for classification, as this area has a high rate of cloud cover.
What is the
So
purpose?
finding proper images is an issue.
Yes. What is the purpose we are classifying of that one? You have to change detection, identification, and you are giving for the some action plan or something like that to proper utilization of the land purpose. That is the main purpose for the any land user going for the mapping.
Yeah,
But
sure.
the data itself, it will be the input data. So single set of the data. So how you can decide for the agricultural land and agriculture is land boundaries is fixed. So it will be fluctuating. It depends on the seasons. Normally in India we are taking for the 3 seasons data. Then we will go for the that one. That's why better to in the future you have to.
I do understand your questions that seasonally the agricultural lands will change over the periods. But these agricultural lands are mostly plantations and commercial agricultural lands. So it's not like they change seasonally. Do you understand what I'm trying to say?
Yeah.
I've compared it with the other years as well.
Whatever it may be,
There's no major changes between the agricultural
So
lands
in
over the
research
years.
in research we are not supposed to give the statements like that. Better to you have to take for the 3 seasons or 2 seasons data according to the cropping pattern. You analyze the cropping pattern and then you can go for this. Then you can decide that one. Then it will be coming to the it will total command of your work. So that is from my side my suggestion of that one. Thank you.
Sure, sir. I'll consider it.
I think the same thing that Professor Shivshankar has given a very valid point. But there is one more point, you have classified among the classification what you have done. You have agriculture. How do you distinguish?
Sorry, you cut out. Could you repeat your question?
Among the classes what you have listed, so you have forest and agricultural land.
I'll go back to that slide. Yes, here.
Agricultural land and forest.
Yes.
And how do you distinguish based on the reflectance agricultural land and forest?
Oh, I've references with real life images like through satellite images and the patterns that are given by the government data.
No, have you done the classification by yourself or?
I've done the classification myself, yeah.
No, but I am asking a very basic question. How do you distinguish the reflectance of agricultural land and the forest land? Because both are essentially vegetation.
Yeah, so the vegetation here basically is the forest lands are more like I would say it's more darker compared to the agricultural land.
But no. How it is? Both are essentially vegetations, and you clearly you are distinguishing purely on.
And one more thing, you are telling for the total the agriculture also it will be a total entire plantations or something.
Yeah. Yes. Same point.
That is the major problem.
No, this will a lot of questions regarding the accuracy of the classification. I think it is there, so you need to address that point, which Professor Shivshankar has clearly mentioned.
Okay, so you want me to address the seasonal variations and how I'm classifying between the two vegetations?
No, there are 2 points. One, what Sarah has listed, and second one is about the accuracy.
How am I classifying between the two landforms, right? Agriculture and forest. Okay.
Yeah, how accurate your classification? Okay. I think we don't have much time. We'll take up the next speaker. Yes, you can call the
Certainly, sir. Certainly. Thank you so much. The next one in the line is paper ID 122. It is Dilip Singh and Senthil Kumar. So, Senthil Kumar, I think I have given you the presenter status. And meanwhile, Anand Raju sir, could you please stop sharing your screen? Because we are seeing your home slide all the time. Could you please stop sharing your screen, Anand Raju sir, if you are still available? I suppose you are still there. I don't know why we are seeing your screen. Meanwhile, Senthil sir, we have given you the status of presenter. Please start sharing your screen. Yeah.
Slide is visible, sir.
Yes.
Shall I start, sir? Am I audible?
Yes, you are audible and it is visible. Yeah, please go ahead.
Thank you so much, sir. So I'm G. Sindhil Kumar from Satyabhama Institute of Science and Technology. The research topic is the measurement of volume fraction of air in water. This is actually an experimental study. What you are seeing in this picture, it is an open channel flow passage. And what you are seeing as the front, it is the upstream side, and I'm just standing on the downstream side. So between this upstream side and downstream side, the water is flowing from bottom to top on the upstream side, and over which you are able to see some wooden structure. It is a spillway weir profile. We can imagine a dam in a reservoir or any river, same concept here. So the water has to pass along this upstream side, and it has to fall down on the downstream side over this spillway weir profile. So the critical thing is how we have to design and fabricate this weir profile in such a way that we can minimize the entrainment of air. Because we know that when water passes over this weir profile, if it is not being designed properly, there will be lot of chances for flow separation of water. If flow separation happens, where air comes into play. So this is how on the downstream side, the main focus of the experiment is we are just measuring how much volume of air is being entrained. So this is one of the that research project outcome which we established in our fluid mechanics lab. Okay. We tested various spillway weir profiles like the top bulge, bottom bulge, trial and error method only. We tested many spillway weir profiles, and finally we concluded some profiles which will give the minimum air entrainment. So the first, at the beginning of this experiment, what we did was the air bubbles which are formed on the downstream side. Even if you open the tap water, if you keep your bucket, if you open the tap water, you can see the water is being collected. Simultaneously, you are able to see the bubble formation. That bubbles are macro bubbles, and they will burst at the top surface. But if the bubbles are very less, they will, you are able to see the bubbles which are at the bottommost phase, and they have longitudinal and transverse movement. In some applications, this bubble formation is not desirable, as I already pointed out. This is one of the outcome of the research project what we had with the IGCAR for that experimental investigation on main vessel cooling system and optimization of spillway weir to mitigate gas entrainment in a fast reactor, where they are using what sodium and argon, same we constructed with air and water, considering only the hydraulics point of view. And in the upstream side, the one of the tasks is the measurement of the velocity of the water on the upstream side. We know that for measurement of velocity of air, we have plenty of devices like anemometer and all those things. But for measuring the velocity of liquid at such a low level, it will be less than 1 meter per second or 1.5 meter per second. We don't have any such device.
You are in the same slide. You are still in the same.
Yes, sir. Yes, sir. Yes, sir. I can understand, sir. I will move, sir. So this is the velocity distribution we are measuring. We have designed and fabricated one propeller type anemometer for the measurement of velocity. And over the spillway weir crust, there is using ultrasonic sensor. The film thickness of water is also being measured. And on the downstream side, the volume fraction is also measured by means of the impedance probe. I'm just talking for the 5 minutes about spillway, and here in this picture you can see this 90 mm corresponds to the upstream side gap between the spillway and the outer transparent baffle, and on the downstream side it is 60 mm between the spillway and the transparent baffles. So here the water will flow and it falls down. Okay, and on the upstream side at the bottom we have the jet breaker plates or steam equalizer plate, because we have pipeline only at the center, but this entire setup is 2 meter length and 1.5 meter height, so it is very big. So water we cannot pass only at the center. If you pass at the center, it will flow like a butterfly, right? So a lot of places vacuum will be created, so it is not a correct procedure. So to have uniform jet thread, we used a jet breaker plates, and we optimized the porosity of the plate also.
So the water tested it is being synthesized by use of this ultrasonicator for its purification as well as some formation of the micro nano bubbles, right? So this is what I have spoken so far about these construction features. There will be a flow ball and rotometer will be there up to 700 LPM capacity to change the water flow rate, right? So coming to the results, first we tested the air entrainment. First we were able to measure only the depth of penetration. Okay, initially we didn't concentrate on how much quantity of air is being entrained, what is the volume fraction. So initially the research started, what is the depth of air being penetrated? Because I told that the entire setup is 1.5 meter height. We were able to see the air entrainments from the bottom from 200 or 300 meters height. So in this, there is a device available, air entrainment tester, by which we were able to measure the bubble formation. That bubbles and also not uniform size because it is a transient flow conditions. It is not laminar. And the upstream side we can maintain laminar conditions, and the downstream side, since it is passing over the weir profile, we cannot maintain laminar. It is a transient and little bit turbulent, so we are not able to measure the exact depth of penetration, and depth of penetration which is not uniform throughout the length scale, right? So this is the fall height with respect to the air entrainment. From bottom on the downstream side, from bottom we are keeping 0, 100 mm, 200 mm, like this up to 700 mm height. We measure the air entrainment depth for different flow rates. I already told you from the rotometer specification was up to 700 LPM, right? And this is the film thickness over the spillway weir profile by using the ultrasonic flow sensor. So the which spillway weir profile will have maximum concave shapes, will take all the water through inside which, so the flow separation will be minimum. So film thickness more means flow separation will be minimum. Our aim is to we have to minimize the flow separation, right? So here we used some ultrasonic sensor. Same for this volume fraction measurements, the same model is being created by using the CFD. So we have constructed a three-dimensional mesh model. Around 68,000 mesh is being created. And on the upstream side, I told you that we are using a jet breaker plates of porous, right? So we, after experimentation as well as from the CFD predictions, we concluded 38% of the porous jet breaker plates will have almost uniform velocities. So you can keep the different colors here. After one point of time, all the velocities will become uniform, same. Okay, this is what we validated with the experimental also, right? And regarding this volume fraction, initially we started with taking the photograph. Using high-speed camera, we just photographed the air entrainments, and using image processing, air we have given some different code, and water we have given some different code. To some extent, we could be able to measure the volume fraction. So in that sense, it is also not correct. Then along with that electronics engineering, so we just implemented that impedance probe. It can measure the volume of air directly. Okay, so like our pitot tube or any other instruments, when this instrument is being inserted, it observes only the air particles. So how much depth it is being inserted, accordingly we can directly have the display of volume fraction at one particular place, right? So the probe records the change in electrical impedance each time the power input is being varied. So by the measurement of this impedance, the retention time of the bubble at the tip was, right, we can measure, and the entire experiment was conducted nearly at 27 degrees Celsius, right? So this is the one such result we got according to the probe location, which is given in millimeters from 0.8 to 1.5 millimeters. What is the volume fraction of air is being measured in some 1 centimeter cube volume. Very small volume we have taken for initial reading. For this 1 centimeter cube volume, how much percentage of volume of air is being entrained in the water, we could be able to measure by using this instrument. So this is the outcome of this paper. Okay. So though the measured volume fraction of air in water is not an accurate one, it can support the previous studies. Okay. So there will be a lot of researches going on for measuring this VOF. So the accuracy and uncertainty error caused by the measuring instruments also accounted for the improper measurements. So in hydraulic structures, the entrainment studies are huge to arrive at a definite solution for this VOF.
this present investigation, we think it is also support the above phenomenon in a significant manner. And we also observed that for 0.1 mm probe location, the VOF variation was estimated to be 11.1% with an uncertainty error of 0.5% as depicted from the instrument. So these are the some references. The first one is our publication in this journal, Taylor references. Thank you, sir. Any questions, please?
Yeah, any questions from the floor? Okay, Sandil, when you are handling a situation wherein the quantity of water is huge, what will be the scenario?
Yes, sir.
When you are handling a situation where the quantity of water is huge, large
Okay,
quantity,
sir. Okay,
what will be
sir.
the expected scenario?
Sir, your voice is breaking. Hello.
So when you are handling a situation wherein the quantity of water is huge, okay,
Okay,
when
sir.
what will be the condition?
So quantity of water at present, this experiment is being conducted only in a closed circuit apparatus, sir. I think sir may be asking, for example, flood-like situations or any like situations. This device has to be moved to the prototype.
Because you mentioned in
yes,
the beginning,
sir.
you made a reference on that. That's why I'm asking.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Sir, it is in the research level only, sir. This bubble dynamics, it is on the research level only, sir, in our experiment.
Okay.
Yes, sir.
Thank you. Thank you so much, sir. So the next presenter in the list is paper ID 175, Arvind Divangan. Arvind Divangan, if you are there, because I haven't found you in the list as well. So I'm just calling upon the name just to check if you are there or not. Paper ID 175, Arvind. Well, I think he has also not responded to the group, so we will move on to the next presentation. Paper ID 180, Krishna Mohanta and team. Paper ID 180. So I think she's there, and I'm going to give the presenter status. Krishna, you can start presenting, ma. Krishna Mohanta and team.
I think some Anandaraju is presenting.
Anandaraju, sir, I don't know, sir. He has kept his presentation open, I think, and he has gone somewhere.
You saw that you can stop
from
the host side.
Yes, sir. Anil, sir, can we able to stop? I was trying, but it was not happening.
Sir, Anandraju sir has to stop, sir. I will contact him personally, sir.
Yeah, please do, sir. So meanwhile, Krishna, you can, yeah, I think you are presenting it. Krishna, I think it is taking more time for you. Can you unmute yourself and speak out? Krishna Mani Mohanta.
I think it looks like some network issues, taking a lot of time for uploading.
Yeah,
So,
I think I'll call upon the next one.
we'll give our chance at the end.
At the end, we can, yeah, meantime, we can call the next one, sir. So with your permission, I'll call the next one, 202. 202, Suraj Kumar.
Yes, sir, I'm here. Sir, can you hear me?
Yes, I can hear you. You can start presenting now.
Yes, I'll share my screen.
Yeah, please share your screen.
Sir, please do tell me if my screen is stuck and if it's not changing.
Yeah, you can just make a trial. Just go on to the second slide.
Yes, sir.
Yes, yes. Yeah, okay, you can go to the first slide and start your presentation. Thank you.
Yes, sir. Yes, sir. Good evening, panel. My name is Suraj Kumar Roy. I'm a student of Central University of Karnataka, Department of Geology. And today I'll be presenting my paper, Cyclone Amphan Tracking and Damage Analysis. I would like to thank KL University for organizing this and giving me this opportunity. Now, the introduction. India has a long shoreline and we are prone to tropical cyclones. As we all know that we are surrounded by water in the southern side and Bay of Bengal is also over there. That's one part, and we all know that how many cyclones have made landfall in the Bay of Bengal. In year 2020, it was Amphan cyclone, which I worked upon, and even in 2021, there was one cyclone which made its landfall in the Bay of Bengal. Now, these are tropical cyclones. These are just circular storms, and they have high wind speed, and there is so much water present in them that when it made its landfall, it just rains heavily in that area. Now, real-time data can be used to predict how a cyclone would affect a particular area, and we can use early warning system, which is a specifically designed system to help us in the prediction how it would happen, and we can also combine the database of previous cyclone data to do so. Now, the problems with this is that these are natural phenomena, and you cannot predict it with 100% accuracy. But still, what we can do is we can try to make it more convenient and maybe more easy, so that we can save more and more lives. And we know that India is a developing country, and in such condition, if a natural phenomena which can cost to more than crores of rupees to any particular state, if even if we can reduce this amount to by like let's say 40%, it would be of great help. And I think real-time data can be used to do this. Now, my methodology is data was collected from Giovanni, which is a part of NASA, and we used for pressure MERA2 model, and for wind again MERA2, and for rainfall GPM. And these special data were merged with Indian admin shapefile to track the path of the cyclone. And after this, for damage analysis, a special query was done, which was of around 150-kilometer radius from the position of the eye of this cyclone for damage, which was the radius of that image that we'll see in a minute. Now, here in the result and discussion part, we can see this first image. It is representing the average map of sea level pressure. Now here, as you can see, it initially started on 16th May, and as the pressure, low pressure system, it shifted from this southern part of India, this particular place where we can see it was near Sri Lanka. It shifted from there to Bay of Bengal, and so did the cyclone. Cyclone will follow the path of how the pressure system is changing. Now, this is a map of, this is the part where we can see how the moisture is getting transported. Now, in this map, these small arrows that you can see are representing the overall movement of moisture, and